and here we go.
There's the deluge. Here's ignition.
Doubling up.
Did it just do a Kerbal?
Back to the moon and beyond.
Put that in the big bag, you know.
Back at home, we all have a lot of work to do, but from here, it sure looks like a perfect flow.
Propulsion continues to be normal.
We did have an observation. 343 unfolds to go.
It's orange.
Water towers can fly!
Bingo! Right in the center. Where's Jacqueline? There it is!
That was surreal.
That's not what we want to see.
No!
Oh my God.
Yikes. You bet. We don't need any more of these.
Well, good morning, everybody. We are live once again looking at NASA's Space Launch System rocket. And, well, we're also looking at the timeline. But there are some things that didn't go 100% correctly last time. And we are going to see if NASA can rectify those issues and press ahead with Artemis II at some point next month. My name is Ryan Caton. Thank you very much for joining us. At a much earlier time than we were for the first wet dress rehearsal. That's because NASA has moved their simulated launch time for today to be a little bit earlier than it was on wet dress rehearsal number 1. So we currently sit at L-10 hours, 25 minutes, almost flat. Of course, we're not expecting any launches today, but we are, of course, expecting a full countdown rehearsal, filling up the pesky liquid hydrogen, filling up the liquid oxygen on both of the stages, making sure that Orion is ready to go. They're going to send out the closeout crew, believe it or not. They said they weren't, but now they are, apparently, so we're going to be on the lookout for that again, and then we will get to the exciting pointy end of the count, the terminal count starting at T-minus 10 minutes. But we're a little ways away from that point right now, so over the next 10 hours or so, we'll be live, we'll be chatting, we'll be actually providing you some commentary, we'll be answering your questions if you tag us in chat at NASASpaceflight and all of that good stuff. Anyways, I think we should start the show. Of course, it's not just my voice you'll be hearing today. We've got pretty much the entire NSF team will be on this live stream at some point, but kicking things off alongside me, we have the one and only Alex joining us. How you doing, Alex?
Well, I guess, part 2 here of the wet dress. I'm doing well. I'm just impatient today. I didn't feel like this for wet dress number 1. But today it's like, come on, go through and let's launch already. I don't know. It's just that feeling. I don't know.
And of course, we have a voice from the field. Joining us from the field is Max Evans. How you doing, Max?
Good morning, everybody. Well, a little bit anxious, I guess, like most other people are, to see how that tail service mast umbilical will hold up. We will wait and see how that goes, but we are certainly keeping our eyes on very closely. But otherwise, it is a beautiful morning here on Florida Space Coast.
Indeed. And I'm going to ask you how the weather is, because the last wet dress rehearsal, it was kind of on the tail end or kind of amongst that really cold storm that was coming through, and apparently everything was really cold and it was like unbearable. But how's the weather today, Max?
Yeah, it was very, very cold at that point, but I am happy to report that temperatures are much higher than they were then. Very, very, very pleasant, warm temperatures today. I want to say we are currently around the 72-degree Fahrenheit marker. Not sure what that translates into Celsius, but I'm sure you can have a converter on your end. But yeah, it is a wonderfully sunny day and a little bit of a breeze that is keeping everyone just cool enough. So weather should not be a concern, at least with temperatures, with today's wet dress rehearsal. Ooh, engineering camera. Look at this.
Wow, look at that.
That is a bit of a surprise, ladies and gentlemen. Breaking news, NASA finally looks like they're going to be providing us with some up-close views of this testing. Of course, they didn't do this last time around, but it looks like they are. I don't think this was communicated at all, but this has just popped up on NASA's program feed, and you can actually see there the engines chilling down there at the bottom. You can see them getting a little bit, the RS-25 is getting a little bit cold. Of course, the SRBs are not chilling down, but we can see the RS-25s chilling down with those vents there. Wonderful close-up views. Thank you very much, NASA. Hopefully we get more of these throughout the day, but it's always so much better to get up close and personal with this rocket, through a camera. Maybe not in person, unless you're the red team, but always wonderful to get up close and personal when the rocket is literally coming alive. Anyways, that's a little bit distracting. I will allow everyone to continue to be visually distracted whilst we continue on with the opening of the stream. Of course, Alex, this is Wet Dress Rehearsal number 2, because a couple of weeks ago we had Wet Dress Rehearsal number 1, which was, planned to be the only Wet Dress Rehearsal, but we all know how these things go. Sometimes more rehearsals are to be expected. But could you give us a little update / rundown of kind of what went wrong on Artemis 1, on Wet Dress Rehearsal 1, so to speak, to necessitate needing to do it all over again?
2 words. Blame hydrogen. Or I guess you could also use hydrogen leaks. Those are also 2 words. But yeah, that's basically what it boils down to, I guess, and no pun intended with a boil down. Because at the end of the day, what they had was a few issues during loading of the liquid hydrogen on the core stage. There's this interface on the tail service mast, those 2 black things sort of sticking from the mobile launcher there, where it says Florida on the ticker, right? Right above that, there's 2 things sticking up. The one on the right is for the liquid hydrogen to be loaded on the core stage, and that one is the one that was giving them problems because there's an interface, right, between the ground side and the vehicle, and that's where they saw increased concentrations of hydrogen, of gaseous hydrogen in the air. And that volume is actually usually purged, but obviously if the concentrations are high enough, then that can be an issue. And so that caused them to stop the filling of the core stage liquid hydrogen tank a couple of times during the countdown, and that made them delay eventually well into the test window. Now, they did fully load the rocket. They went through a few of these techniques, which we may explain later in the show, right? To be able to fully load the core stage, and also the second stage as well. You can see it there from that top view of the rocket, and then they were able to go out to Orion with a closeout crew once the rocket is fully loaded. That's when they go out there and they prepare the capsule. They close the hatch. They prepare the white room there at the end of the arm, and then they go into terminal count. So during terminal count, they also had an issue with hydrogen leaks. They stopped at T-minus 5 minutes and 15 seconds because, again, that concentration of hydrogen went up during when they were pressurizing the core stage. We may talk about those things later in the show as well, to the specifics, but that's essentially what happened. And so they were never able to fully complete the terminal count, and that is a very important part of the countdown. It's not just the fueling, but also preparing for flight. And a lot of the things that happened to prepare for flight happened on those last 10 minutes, and they were not able to complete that. And so today, after a few attempts at sort of changing the seals, for example, that's one of the things that they have done since. They have also done a what was called an integrity test, a confidence test, or something like that of that seal. I think that was earlier last week. I think that's when it was, and based on the data on all of that work that they were able to do, we are now on Wet Dress Rehearsal number 2, and let's see if there are no leaks or anything. Now, when the leaks happened on the first attempt, that was when they transitioned from slow fill, as it's called. It's pretty much self-explanatory. That means they're slowly filling the liquid hydrogen tank. When they transition to fast fill, essentially flows of hydrogen that are higher into the tank, that's when they saw the first leaks. If they are still going through the timeline, that should be in about 40 minutes from now. So we'll see in 40 minutes whether they find out anything or not. So we will see early on if that workaround sort of worked or not.
Indeed. L minus 10 hours and 17 minutes And the next kind of big event that should be coming up is at L-9 hours 55 minutes, which is, of course, the liquid hydrogen Schofield beginning on the core stage. We have a big timeline. We've also got that timeline, which you saw on screen a little bit earlier for the terminal count. We'll probably be showing that a little bit later, but we, of course, got the full timeline here as well. From the beginning of that Schofield on the core stage, all the way up to L-5 hours 30 minutes for LOX topping on the interim cryogenic propulsion stage. We've got our first question in chat from Laurie DS asking odds of a full wet dress today. Max, what do you think? Do you think they've worked through the issues? Do you think they've fixed the issues? Do you think they're going to get through to a successful full run of the terminal count like they so want to do, or do you think it might be a little bit of repeating history, a little bit of deja vu?
I mean, at the risk of sounding cliche, either they have or they haven't. So it really is 50-50, but just based on the amount of leakage that they have seen during the entire Artemis I campaign, and from what they have seen regarding the first wet dress and that partial tanking test, the odds are certainly not in their favor in terms of a perfect seal. Now, whether or not the actual leak concentration is high enough to warrant an abort for today is still up in the air. We still have not gotten to the point where we can even tell that at all. But either they have or they haven't. I don't want to be speaking too soon on either confidence or not confidence. But we'll have it's one of those things that that we often say we will have to wait and see. But there certainly has been a lot of work done to that tail service mast umbilical. And again, either they have fixed the leak or they haven't. So we'll wait and see.
Fingers crossed they fixed it, but yeah, if Artemis 1 is anything to go by, then they kind of had 3 years to fix it and they didn't, so it's been 2 weeks. I'm not 100% confident, but we'll just have to wait and see how these things pan out. In the meantime, over the beginning of the stream, and even before the stream started, we got some wonderful support in chat. First of all, Bideford, always in chat. Hello, Bideford. Gifting 5 Red Team memberships. Jeff Rowe, someone else who's always in chat, gifting a Red Team membership. We had AJ Downey becoming a PadRat member. 5WI becoming a PadRat member as well. And Flipper79 McGregor, literally part of our team, with a $10 super chat. Got my lasagnas. Let's go, SLS. I think we've all got plenty of snacks for the next 10 hours or so, because of course that's only counting down to the first quote-unquote T0. NASA, Alex, want to do a couple runs today, I believe.
Yeah, so as I said, that terminal count is very important because you have a bunch of the very important steps to prepare for launch, namely things like, the rocket goes into internal power, you got the tanks pressurizing for flight, many things as well, like the crew access arm also retracts. There's a bunch of things that happen there that are critical for flight, and you need to know if the rocket is going to be ready to, if you stop the count, for example, in the middle of that terminal count, and then you go back to T-minus 10 minutes, if the rocket is, and the ground systems, of course, are all ready to be able to go back to that pre-terminal count state and then go again. And so they're going to be doing a first run where, they have these planned hole at T-minus 10 minutes, right? And then they pick up the count, start the terminal count, and then they go to T-minus 1 minute and 30 seconds. That's the last time that they will be able to hold and essentially retry within the terminal count without recycling back, essentially. And by recycling, I mean, going back to a pre-terminal count state. So they're going to be trying that, and they're going to be holding there at T-minus 1 minute and 30 seconds for 3 minutes. That's the maximum time as well that they are able to hold in between T-minus 6 minutes and T-minus 1 minute and 30 seconds. After T-minus 1 minute and 30 seconds, they pick up the count again, and then they go down to T-minus 33 seconds. And that is when the ground launch sequencer, the ground systems essentially, that ground computer hands over control of the count to the rocket. Now, instead of actually doing that, the count will stop before that happens at T-minus 33 seconds. It's going to be a planned hold, and when that happens, as I said before, if they stop the count after T-minus 1 minute and 30 seconds, they are not able to continue the terminal count. They have to recycle before that and sort of go back to T-minus 10 minutes. So they're going to practice that by stopping at T-minus 33 seconds, right before the rocket picks up the count and sort of takes over control of it, and then sort of recycles back to T-minus 10 minutes. Then they're going to count down again. Mind you, recycling takes a while as well. So we're going to see an extended period of time. I believe Charlie Blackwell Thompson, she said, she's the launch director, and she said it will probably be about an hour or so for that recycling activity. So it's going to take a while to be able to go back again to pick up the count. But they're going to practice all of that, right? That's the point of this. And then once again, the clock will start ticking and will run all the way down to T-minus 30 seconds. So this time around, the rocket will actually take over control of the count. But at T-minus 30 seconds, there's a gate, so to speak, in the software checks. And it's going to notice that, well, the rocket is actually not ready for launch because it's on purpose just a wet dress rehearsal. It's just a ground test. And so that's when the clock will finally stop, and that should be the end. That will be in an ideal situation. Unfortunately, we did not get that on the first attempt. So we'll see.
I think the way I've kind of been describing it, and this is not 100% true, but it's almost like they're kind of purposefully torturing the rocket and the ground systems just to try and push them through like a really difficult hold and recycle situation. Like, we're going to make this really uncomfortable for you. Will you make it through? And that's the point of the test, right? They want to see what like actually happens to the real hardware when they have the chance to see what happens to the real hardware. They don't want to be encountering this for the first time on launch day. So by doing this, you know, by kind of simulating a pesky cloud or another piece of hardware going wrong and having to do that last minute hold, they know what's going to happen to the vehicle if they have to do that on launch day, and see what happens if they can recycle and actually turn it around for a launch. Because of course all of the launch windows for Artemis II, at least that have been published so far, they're all 120 minutes in duration, so there's always a little bit of wiggle room there for getting an actual launch off the ground. But of course, Max, it's not going to be launching for a little while, because following that first wet dress rehearsal, NASA pretty much, well, they did rule out all of the February launch windows, right? So we're launching no earlier than March.
Correct. I believe the current window is from March 5th through the 11th. 10th or 11th. I don't have the actual days in front of me, which I should. But it is in the first week or week and a half of March. There has been some chatter about opening that window to the left a little bit. The 6th. Okay, so it's the 6th through the 11th in the back channel. Thanks, Gage. There has been some chatter kind of away from official eyes about the launch window opening further to the left, but we have seen no official confirmation of that, so we can really only take that with a grain of salt. But they have that window to get Artemis II off the ground, but unfortunately, given the time of the month and just where the moon is, all of those launch opportunities are at night at some point. So not the greatest for our Mark 1 eyeballs, because Artemis 1 launched at night, and that was already tough enough on its own just for the cameras. But if all goes well, it looks like that the first week in March is certainly up for grabs. But the entire trajectory for the Artemis II campaign will either continue or pivot based on the results of the wet dress rehearsal today.
Yeah, and in fact, one of the most probable reasons why they are not picking that earlier, at some point we had been hearing like March 3rd, right, thrown around. One of the probable reasons why they are not doing that is because of all of the times that, so because they skipped the February launch window, right? Now they are going for the March window, and because they also sort of moved the wet dress few days to the right and whatnot, now it's too late in order to be able to do this test and then configure everything for launch. And that includes now retesting the flight termination system on SLS. So there's in fact, some people might have seen, might have even asked, I'm already getting ahead of your game, Ryan, here, that there's a crane out there. There's a crane right next to the rocket, sort of sitting to the side of the mobile launcher. Why is that? Well, because they're setting up in case today's test, hopefully, goes well, then they need to retest the flight termination system. And so there's going to be a crane going up there and setting up temporary platforms on the mobile launcher that will allow them to access the flight termination system on both the boosters and the core stage. So they have already set up that tooling, and they will just need to install it and then, do the work. But that extra work sort of adds a few more days to the timeline, and so it's not going to be much more of a quick turnaround than, for example, if they had actually done the launch on February. If you remember, we did, I think the wet dress was February 2nd, right? Correct me if I'm wrong. At the time, they were doing sort of like a 6-day turnaround to February 8th, right? That will not be possible in this case because of that work.
Although critically, back during the Artemis I campaign, that would have warranted a rollback, because at that point they didn't have the ability to service the FTS batteries at the pad, which of course now they do, which saves them potentially a bunch of time pending other issues being detected. So that is certainly a step in the right direction, and not having a rollback is in everyone's best interest right now. But again, if they find other issues on the vehicle that cannot be serviced at the pad, it will have to go back to the barn, as they say. But those cranes for the FTS batteries are certainly a step in the right direction.
The caveat to that, though, is that if they actually miss the March window, they do have to roll back. I believe the constraint in that case comes from the ICPS, if I'm not mistaken.
Yes, correct.
And they will have to roll back to the VAB and reset some things. I forgot the specifics about that, so I'm very sorry about that. But I do remember that March is the next attempt, but if they do not hit that, they have to roll back. So we'll see what happens. On the other hand, if that were to happen, we have a higher chance of a daylight launch. I'm not. I'm not gonna summon that possibility, because I want this to happen as early as possible and as safe as possible, of course. But on the other hand, we will probably have a higher chance of a daylight launch, because as we get closer to the summer, and because of orbital mechanics and alignments of the sun and the Earth and the moon and all that stuff, you get a higher chance of having a daylight launch as you go into the summer. So, but yeah. We have March at the very least.
And along those lines, we actually had a question here from Terence, and they're asking, how long can the rocket be left outside exposed to the weather before it needs to be returned to the VAB? I don't actually know if there is like a weather limit, because on Artemis 1 they did kind of leave it outside when there was a hurricane coming, so I don't know if anyone has numbers on that, or if it's unrelated to the weather at all.
I think the only weather that they would have to really take into consideration before rolling back are wind speeds and directions. They chose to roll back before the arrival of Hurricane Ian, which was a Category 4 or Category 5 hurricane that made landfall in southwest Florida and then came up through the Cape afterwards. And then, of course, they chose to leave it at the pad during Hurricane Nicole, which came from the Atlantic and slammed right into the east coast of Florida. Which took off some of the RTV seal around the Orion aero cover there, which in hindsight wasn't that big of a deal, but seemed a bit of a contradiction to be leaving it out in such weather. But it is mostly down to wind direction and speed for leaving it at the pad or not. Otherwise, it can stay out there for pretty much as long as they need to, pending other issues being detected. Like, say, if they found some pesky woodpeckers burrowing their way into the Sophie foam on the core stage, which they had happened during, I think, 1 or 2 space shuttle missions back in the day. So it can stay out there for quite a while. I don't really foresee them having an issue with weather that would warrant rolling it back, of course, pending a hurricane coming this way, but at this time of year, that is highly unlikely.
Yeah, it is not really the time of year for those sorts of weather events to be happening in this part of the world. But we are now approaching L-10 hours, and about 5 minutes after that is when the scheduled start time of the core stage liquid hydrogen slow fill is, and then 5 minutes after that is when the T-minus clock should resume from T-minus 8 hours and 10 minutes. So those are a couple of the things we're going to be looking out for over the next few minutes, so do keep an eye out for those. In the meantime, though, we have got another great question here from Sard, and they're asking, don't the human landing systems have a 60 to 90 day loiter period? If it doesn't launch before May for Artemis II, would that be concerning for a future landing mission? I think what they're asking here is, say if Artemis 3 has the issues that Artemis 2 had, Alex, I'll throw this to you, would that then prove a problem for the lander? Because, well, the lander's going to be hanging out a lot longer than it's supposedly rated for.
Yeah, that is definitely a concern, at least for, everybody that actually keeps around, I guess, and sort of keeps a close eye to these issues where it's like, yeah, you can tolerate leaks and whatnot when it's only this, right? When it's only Artemis 1 and Artemis 2, where it's just SLS and Orion, it's okay. You can take the time, whatever you need. But after this, how are you going to tolerate this if you keep slipping month by month, right? And you have a lander waiting out there around the moon. And that's sort of the concept of operations for these landing missions, where it's like the lander waits around the moon, and then after that, you launch SLS with Orion. And so because of that, by the way, I just saw an update. Core stage liquid hydrogen slow fill is now underway. So
Excellent.
Liquid hydrogen slow fill. Again, this is the one that, it might still leak a little, but they don't see concentrations that are too high because it's low pressures, low flows into the tank. So this is the one that for now they should be okay. It's the one that when they go to fast fill and faster flows of the liquid hydrogen, that's when they see these issues. But coming back again to this argument, it's like they really need, it's the same, I guess, it's the same argument. They really need to fix this, right? They really need to find a way to fix this. And I think Jared Isaacman's post the other day on X talking about this was very important, because he committed the agency to actually redesign the tail surface mass, the connections to the core stage. And I feel like that's sort of probably what's important, a commitment to say, we'll try to make it work for Artemis 2, but this needs to stop, right? Like the ideal is, and especially SLS, it's pretty much already designed to work, right? You put it on the pad, you feel it, you launch it. Like that should be the idea, right? They spent many years designing this rocket, and it shouldn't have these problems, right? And so they have committed at least now to redesigning those connections. I don't know how they're gonna test whether they work or not, like without actually putting the rocket out there. They don't have test tanks or anything like that, like we see, for example, with Starship, or we've also seen that with Neutron and New Glenn, and et cetera, like many other companies out there have usually Pathfinder vehicles that go out to the pad, they test the systems and things like that. Unfortunately, the SLS program, it's not rich on hardware, let's put it that way, and so that was not a thing. We'll see what they do. I think Jared also talked about maybe doing more cryo tests going forward, not just on Artemis 3, but like future missions as well. So we'll see how they do that, how they make sure that that redesign, that promised redesign, works this time around. And now liquid oxygen slow fill is also underway.
So they're actually a few minutes ahead of the planned timeline there with slow fill.
Indeed.
Well, about 5 minutes on the hydrogen side, almost half an hour earlier on the oxygen side, or a quarter of an hour earlier on the oxygen side. So maybe they're just trying to get ahead of things. I mean, they already have an extra hour of hold time in the countdown today. So maybe it's an hour and 15 minutes they needed after all. But yeah, that's definitely good news to everyone asking. And yeah, this is the full update from NASA. To everyone wondering in chat, is the rocket getting fueled? There's your answer. Yes, it is. Hydrogen and oxygen loading is underway on the core stage of SLS.
Yeah, and you're right. They have added at least 1 hour extra on the clock, on the countdown, and also we're like half an hour earlier. So that's why we're beginning this stream a little bit earlier than when we covered the first wet dress rehearsal, because both the countdown got an hour longer, and we're counting down to half an hour earlier in the day. But that's great news. That's good signs that we are proceeding on time. If you remember from the first time around, we actually were 40 minutes delayed. Like we were behind 40 minutes compared to the plan of the countdown, right? Here we are actually a little bit early. I guess technically it's the same time. It's just that the timelines have shifted 1 hour. I don't know. But it's great news nonetheless, and so that means if they have any issues, they have more time to resolve them, which is always good. They're gonna need the time.
More time, more better, or something that Jack said. I don't know. But yeah. Again, great up close views. Thanks to NASA of that venting ongoing at the aft end of the core stage there, near the RS-25 engines. And you're also getting a wonderful view of all the numerous tracking markers they have across the pad and across the vehicles. Those black and white little markers you see there dotted all around the vehicle and the ground infrastructure allows NASA to basically kind of track how the vehicle and ground infrastructure moves relative to one another from their engineering cameras after liftoff. So very useful for getting data and the like. Anyways, as we continue to count down, we have another question here. I've lost it. That's awkward. Give me a minute to find that again, and we can gawk at some more beautiful NASA views. Where did it go? This is wonderful television, I know.
Oh, Ryan.
Oh, here it is. We have, I found it. Danley, they're asking if moving the rocket from the VAB to the pad is what causes the leak. What's the alternative to fix this specific issue during the move? Could NASA make the connection only at the pad? First of all, I'm going to kind of rephrase the question. Is the problem being caused by rolling the rocket to the pad? Because I'm not sure on that one.
I mean, it's tough to say on that one definitively. That is certainly one of the most dynamic environments that the vehicle will see outside of launch, because, of course, while the crawler with the mobile launcher on top of it can only move at about 3/4 of a mile an hour as a top speed, it is still a very dynamic environment in that the rocket is constantly shifting and moving and swaying. Because, of course, the ground, even though as much as they try, is not perfectly level, and it still has to traverse over a whole bunch of Alabama River rocks that lay across the crawlerway. There is actually some video out there from Artemis II's rollout, and someone had a rather tight-in view of the launch escape system on top of Orion, and you could actually see the entire rocket swaying back and forth despite how slow it's moving. So that means the entire vehicle is moving, and that means all of its actual connections to the ML are also moving and shifting. So while it is easy to look at that and say, hey, this might be a cause of your leak, I'm sure that they take all of these motions into account regarding the actual connection and how much movement and play that how much play the connection can tolerate there. So I would like to think that's already built into the equation here. But I think the problem here is more a fact of just how pesky of a molecule that H2 is to work with.
I think it was Amit Chatria. I'm sorry for butchering his name. That talk about that potentially being one of the things that they're looking at. He also mentioned other dynamics such as like winds and whatnot that may also sort of shift that connection in between the ground side and on the mobile launcher and the rocket itself, because obviously the mobile launcher does one thing when wind blows in one way or the other, right, and the rocket sways one way or the other, so like that can also maybe shift around a little bit that connection, and so both the rollout and winds and other dynamics, they're looking at everything, right? But I do wonder, just as the question was saying, that maybe you only connect those things late in the preparations. Like you don't really need that connection to be made until rather close to the start of the countdown. it takes a bit to do that connection, but it doesn't take that much. So I do wonder if maybe for future Artemis launches, or even on Mobile Launcher 2, once they start, with 4 and 5 and whatnot, if there are any beyond 5, if that might be one of the ways that they go and proceed. Definitely one of the things I would love to ask if we were able to, but we'll see how this test goes in the first place.
We have another question here. I don't know if anyone knows the answer. If not, we can fire it away and go and find out the answer. But Offshore Diver is asking, do we know roughly what the flow rates actually are?
I'm not sure we know exactly. You got to think about this. So it takes about, so fast fill takes about an hour and 25 minutes to fully load the liquid hydrogen when there are no leaks and stops to that filling sequence and whatnot. So think about, the volume of the hydrogen tank, and then divide that by 1 hour and 25 minutes, and you probably more or less get a good guess as to what's the rates. And also for the liquid oxygen, per the timeline, it takes about 2 hours and 20 minutes. So, you can do a rough estimate about that, but I don't think we have any hard numbers.
And we've got in a little bit more support over the last few minutes. Donnelly with the 10, I'm not sure what currency it is, but thank you for the support nonetheless. Asking that same question again. You don't have to do a super chat for a question. They all come in the queue. Of course, we can't get to them straight away because there's lots of questions coming in, but thank you for the support nonetheless. And we have Zed, Man Over Street, with a $5 super. Thank you very much for your support as well. They're asking, does the number of shuttle engines we have left determine the number of SLS launches we can have? And Max, the simple answer is no.
No, although there is kind of a caveat here, because there were 16 RS-25D engines, which are going to be used for the first 4 flights of SLS. The first 3 being the Block 1, and then the Block 1B coming online from flights 4 onwards. So actually, the flight, the Artemis 4 Block 1B will be the only Block 1B to use the RS-25D variant, which is kind of interesting. But of course, Artemis, there is no part of the SLS stack apart from Orion that is going to be officially recovered and reused at some point in the future. Unlike during the space shuttle, all 3 RS-25s came back and then were refurbished and then flown again. The RS-25s for every single SLS launch to this point are unfortunately going to be expended. So there's no way to actually recover those. So they have to build more. And so from Artemis 5 and onwards, they are going to be using the RS-25E variant, which is a variant of the RS-25 specifically designed to be expendable. Because of course the RS-25D was reused. It was designed for multiple flights and multiple relights. That of course is not needed when you are only using the engine once, and of course it makes a lot more sense to design the engine around that philosophy when you have to build more. So they had 16 originally. Of course, they lost 4 on Artemis 1 when that flew, and they will unfortunately be losing these 4 as well whenever this does end up getting off of the ground. Although Ryan or Alex, I believe you guys would be better at walking us through the actual flight history of each of these engines. But there are quite it is quite a unique quartet, I guess it's fair to say here on the core stage.
If I've got my orientations correct, I believe the engine in the bottom left of this view is engine 2. I'm just waiting to see if anyone screams at me, and they haven't, so I'm going to assume I'm correct. That has flown 5 times before. 3 times were on Space Shuttle Atlantis, including STS-125, and twice on Space Shuttle Endeavour, including STS-134, of course, the final flight of Shuttle Endeavour. The other engine we can see here on the right side is engine 3 that hasn't flown before. This is actually a rookie engine, but it was built late in the shuttle program. However, it does contain flown parts. So components of that engine have flown before. And then on the other side of the rocket, which we can't see right now, we have engine 1, which is the most experienced engine for Artemis II. That is serial number 2047 and has flown 15 times before on space shuttles Discovery, Atlantis, Endeavour, and Columbia. And it even flew STS-135, the final flight of the shuttle program, first flying on STS-91 on Space Shuttle Discovery. And the final engine is engine 4, which is the least experienced non-rookie engine. It's flown twice before, both times on Endeavour, also supporting STS-134. So we've got some interesting flight histories from those engines. And of course, the SRBs themselves, the big boosters, the various components of those bits of hardware have also served a number of shuttle and ground testing missions as well. So plenty of flight history on this rocket, it's all gonna end up at the bottom of the Pacific Ocean, or
Or burned up.
vaporized in the atmosphere, or burnt up, one of the two.
Yeah. Even the Orion engine, the main engine on Orion, is also from an orbiter, from a shuttle.
Yes, that has flown 6 times before. That on Atlantis, first flying on STS-101, most recently flying on STS-112.
It's funny to
And-
me how. Oh, sorry.
No, go ahead.
I was going to mention that it's an AJ-10 engine, of course. It's a different configuration, but an AJ-10, like it was part of the Delta upper stage, the hypergolic one, not the hydrogen one. I mean the Delta II, for example, upper stage. And it was also part of the main propulsion system on Apollo, but it's like a widely different configuration now of that engine.
It's very interesting how these how this hardware is kind of being developed throughout time, and in some way, you can stem pretty much every component of this vehicle back to something much, much older, which is pretty cool. Something else that is pretty cool is the fact that we are continuing to count down. We have confirmation that NASA has passed through or resumed the count at T-minus 8 hours and 10 minutes, which takes place at L-minus 9 hours and 50 minutes. Alex?
Yeah, I just saw the update. Core stage liquid oxygen fast fill is underway. So now they have transitioned from slow fill to fast fill on the liquid oxygen.
And that is scheduled to take place at L-minus 9 hours and 30 minutes. So once again, we are a course of an hour ahead of schedule, which is very exciting. More
Still
time,
on
more better.
slow fill. Yeah, still on slow fill for the hydrogen, but that should change rather soon as well if they are ahead of the timeline. It's supposed to transition to fast fill at L-minus 9 hours and 35 minutes. So we should be about under 9 minutes now from that. But again, it seems like we're running a little bit ahead of the timeline, so it might happen any time now.
We will continue to stand by for that update, but again, we are going to be live throughout the entire day here. We got 9 hours and 43 minutes left in this first run, then they're going to do another run, so we're going to be live for well over 12 hours today if everything on NASA's side goes to plan. There's also supposedly a Starlink launch tonight. Whether that goes ahead or not is still to be seen. I'm sure we can talk about that at some point as well, which we'll of course be covering if that goes ahead. Lots of spaceflight activity happening on the Space Coast today. So lots of things to be looking forward to. We've got a little bit more support from Justin Mora, who's become a Capcom member. That means you get access to our Discord server, where a lot of unhinged activity takes place, and I think I'll leave it at that. And we have Larry Mills becoming a PadRat member as well. So thank you to everybody becoming members of the channel today. There is I can assure you, going to be a lot of wonderful pictures coming from the field of this launch and all of the other launches and activity that we cover here at NSF. So it's something I can highly recommend if you want to see some behind-the-scenes pictures, because we dump all of those, especially if you're on L2, because pretty much every single photo I think gets put on L2. So plenty of stuff for you to pore over if you want even more content being kind of shoved into your face. We have an interesting question here from Metro498. They're asking, are the solid rocket booster nozzles sealed with covers to prevent moisture entering solid propellants while sitting at the pad? Does anybody know the answer to that question?
The plug.
The what?
There's a plug. They in fact at one point had concerns way back when they were developing SLS that maybe the plug will sort of blow out at engine ignition, at booster ignition, and sort of hit the SRBs, not the SRBs, excuse me, the RS-25s. You can see like the nozzles of the SRBs are very close to the RS-25s, right? Like the solids with the liquid engines there, very close. That was not a thing on shuttle. But when they were developing this, they were like, maybe that plug will be a problem or something like that. It turned out that, you know, it wasn't. But yeah, they are plugged. As soon as the boosters ignite, the plug just breaks off, of course, and gets blown away.
I've just gotten a message from a certain Chris Bergen who is very excited by the fact that I have plugged L2. There you go, Chris. That one's for free.
Speaking of plugs, right?
Yeah.
But yeah.
Kind of getting a bit speculative on the future of Artemis. We have a question here from King Behemoth, and they're asking, would New Glenn have the same payload and lift capacity as SLS Block 1B, or would they need to use New Glenn 9x4 to match the power needed if they wanted to use New Glenn for Artemis? Max, the New Glenn 9x4, it's kind of a beast. New Glenn, as it stands right now, especially with that kind of thrust-to-weight ratio at liftoff, I'm going to hazard a guess that SLS Block 1B might be a little bit more powerful than it right now.
I mean, yes, but also keep in mind that the 9x4 variant of New Glenn is going to incorporate 9 BE4 engines on the first stage as opposed to 7, hence 9, and then 4 BE3U engines on GS2 or Glenn Stage 2, hence 4, so 9x4. At least in terms of if at some point NASA was looking for upper stage alternatives if the EUS or the exploration upper stage was falling behind, it looks like GS2, the 4-engine variant of the GS2 might be able to fill in for that if they were able to find a way to have those two merge together. But overall, the 9x4 variant, I don't have the projected performance figures right in front of me, unfortunately. It very well could be, but remember, I think the core stage itself. Oh, Alex is saying that the ticker stopped.
You shouldn't read that stuff. I was just reacting to the ticker. No, it's still the same.
Okay, sorry about that.
Continue.
I was alarm bells were going off, Alex. Sorry.
I was like that too.
It could very well be enough, even despite the initial thrust to weight off of the ground. Remember, just because that's the actual thrust to weight on the ground does not mean that is going to be the case further in flight. Of course, the farther you go into flight, the less your overall vehicle weighs, and thus increasing your thrust to weight ratio. And of course, in this case, the solid rocket boosters on either side of the orange core stage are only good for about a little over 2 minutes. And then, of course, they depart. But also, mind you, without them, SLS would not even be able to get off the ground at all. The core stage itself does not produce enough thrust to lift the stack by itself on the ground. It actually produces less thrust than a Falcon 9 first stage booster with 9 Merlin 1D engines at sea level. But also, the RS-25s are designed to also be used in a vacuum, hence why the nozzles are so big. So its performance on the ground is not necessarily... It's, how do I say this? The RS-25's performance on the ground is not entirely needed of course, that is why they have the solid rocket boosters on each side, and that's for the initial minutes of liftoff. But in the vacuum, the RS-25s have more than enough grunt. The first stage of New Glenn burns for a little over, oh gosh, I believe it's over 3 minutes and actually goes pretty far down range. And of course, if you elongate the tanks, throw in more propellant, and throw on 2 more BE-4 engines on the first stage, you were talking about a pretty solid figure in terms of lift performance. And then throw on 2 more BE-3Us on Glenn Stage 2, you may have a competitor for the EUS in terms of performance and lift capability. So, very, very long answer. I think the 9x4 variant of New Glenn could very well lift Orion if they needed it to. If not, at least Glenn Stage 2 could be a good substitute for the Exploration Upper Stage or the EUS for the Block 1B variant of SLS. We will have to wait and see. Oh, is this this is courtesy of one of our Space Coast live cameras down at the port. I think this is the booster lift point on Blue Origin's screen.
Yeah. Might be rehearsing some of these operations, because there's definitely not a New Glenn booster out there. I can tell you that.
If we miss that, we may as well retire.
Yeah. I will say to quickly answer on my own this question, based on the numbers that Blue Origin has published, it does seem like at least 9x4, if expended, this is sort of the asterisk there, if expended, it could have a similar performance as SLS Block 1B, but, you will have to expend it. Then it's like, well, what's better? Launch a little bit more, but like maybe a couple 9x4s that are reusable versus fully expendable Block 1B that launches once every 3-4 years. Anyways.
And also, so whenever you have to expend a booster, whether it be Falcon 9, Falcon Heavy, Starship at some point, and also New Glenn, it means it's going to be more expensive because the LSP or the launch service provider is not getting that hardware back, and they want to make sure that they cover themselves for new hardware in the future via extra cost. But that being said, the cost of expending a New Glenn first stage probably is still nowhere near comparison to a single launch of SLS. I think that's still fair to say.
Yeah, and I should say, since we're talking about, reusable rockets, if we were to expend them, they could match X rockets capacity. Well, you also have Starship, and if you were to expend it, of course, it can probably launch more than 100 tons and things like that straight to the moon or something like that. But obviously, the point of these rockets is to reuse them, right? So that's very important in their roadmaps.
You say if you expend Starship, you can launch loads of stuff to the moon. Well, I'm pretty sure they've expended Starship every flight so far, and they haven't launched anything to orbit. But
one thing is launching a reusably fitted rocket with landing legs and things like that, like New Glenn, for example, and then oops, we lost the booster, right? Or oops, we didn't land on the barge, or things like that. Or in the case of Starship, it's got all of the reusable components, but oops, our second stage burned up over the Turks and Caicos, right? Like that's a different thing from actually not fitting the rocket without any of that, or even attempting to return them. Anyways.
Speaking of expensive rockets, we have a question from Lily TLI asking, what makes SLS so expensive and other rockets way cheaper? I'm going to start this by saying that if we reuse shuttle hardware that we already have and have already paid for the development for, it will be really cheap, right? Right? That's what we were told, right?
That was one of the main selling points of SLS, and that of course has become one of the greatest elephants of the program, in that it has been far over the initially requested budget for the program. It is a very, very, very expensive beast when you have multiple hands in the SLS pie in terms of jobs, in terms of hardware, in terms of launch infrastructure, both here in Florida, Alabama, Utah, all over the country. It's an entire. The SLS is a product of an entire of our country's space program in its entirety, from multiple sites, and multiple different agencies and companies. But there's no really good way to answer this without like seeing red, just because of how expensive it's become. I think each RS-25 is in the neighborhood of around $100 million a piece, when the Raptor engine on Starship is around like what, $1 to $2 million a piece right now, I think, or at least that's the goal. And the Raptor produces a lot more thrust than the RS-25. So yeah, that was one of the main selling points. Of course, it just has not worked out that way, and SLS has become far more expensive than anyone would have liked, especially considering the fact that we are not getting any part of the rocket back to fly again, apart from Orion. And it's also old. A lot of the hardware was developed in the late 70s for the space shuttle, like the SRBs, the RS-25s. Those were all developed for the space shuttle, and were changed. Not very much to accommodate the Space Launch System. I'm kind of rambling. I don't really have any real specifics to go off of in front of me, but I'm sure Alex or Ryan have also much wittier answers than me. But it was designed to be initially less expensive, or not expensive, but it has turned out to be far from that.
I would
I
argue
don't know if
that.
Alex has anything to add.
Yeah, I have a lot, but I'm gonna concentrate about just one main point, which is, compared to the shuttle, the budget for SLS and all of its ground systems and everything per year, it's actually not that much more expensive, and yet the shuttle was able to launch on average every 2 or 3 months, essentially. Like, hang on, let me do the math mentally. I believe over the program, the average was like 4 launches a year or something like that, or 1 launch every 4 months or something like that. If SLS were to launch 4 times a year, I don't think a lot of people will like. Some people might complain still, right? But I feel like the number of people complaining about the cost will be substantially decreased, right? That number will be a lot lower, and I think that's the main problem of this rocket right now, where it's like you still are having a similar budget to the shuttle, and yet you're only able to launch like maybe once every few years, right? The core stage, for example, like I think at maximum they can only produce 1 every 18 months, essentially, like about a year and a half, every year and a half or so. Not every year and a half, sorry. The core stage timeline, the fastest that they can do, it's like 18 months. So that means like you can do, by doing 3 of them at a time, you can do like maybe a surge of 1 every 9 months or something like that. It's a weird metric that they have, but that's like the top. And we are not there yet by a long shot, like not even close to even like half of that, right? And so it feels to me that that's one of the main problems of this rocket, that despite spending about the same amount of money as the shuttle, they are not able to really ramp up the cadence at all, and it's not even set up for that. And it's a pity, because whether you are a hater or not, if you're a hater, you will at least want to see this money well spent, right? And that means more flights, more cadence, and things like that. And if you love this rocket, you will actually want to see this flying more often, right? I really, I'm ambivalent, if you will. I believe that's the word, where like you're not really on any camp. I just want this thing to be able to launch safely more often and things like that. Everybody will probably want that sort of thing, and I feel like that's one of the main problems of this rocket, unfortunately.
I guess a faster cadence gives the kind of perception that you're getting more bang for your buck.
Yeah.
You know, you're getting more, even if it's not actually reality, but it just gives, you know, if things are happening more often, keeps it in the news cycle, right? Keeps people's attention. With the 3 years between Artemis 1 and Artemis 2, it's
it helps for the leaks too.
Yeah, that's true.
You keep the hardware fresh, if you will, all of the procedures and everything, and you're able to test more often, be able to eliminate all of these issues and things like that. Like, I don't know, I feel like it will solve a lot of issues across the board.
Over the last few minutes, we've gotten a little bit more support, so it's only right that I read those out and thank the people who helped to keep the channel running. First of all, Bideford, again, with a $25 super chat. Thank you very much for your support, saying good afternoon to Chris Bergen, who I'm not going to leak anything, but he's going to be on the stream later, so stay tuned for that. We have Turtle Sanctuary with a $5 super chat as well, saying, if this test goes well, will you in fact get some Forgive Hydrogen merch? No, because Hydrogen still scrubbed the first test, so
Oh God,
they're
he
still
said
to
the
blame
word.
for that one. They're still
Oh,
to
yeah,
blame
you
for
said
that
it.
one.
Right?
Yep,
said
and
the
I was
word.
referencing a previous test, not this test, a completely different thing. There you go. And we also have Thomas AFB with the €5 support. Thank you very much for that as well. Let's have a look through here. We have a question from Brett's Weird World, and they're asking, why is the foam orange? Is it an aesthetic choice, or just the color that the material they use is? I think it's more of the latter. The foam just happens to kind of turn orange, Max.
Yeah, it's just how it looks naturally, or I shouldn't say naturally. That's the wrong word. But when it's all put together in its mixture and sprayed on, this is just the color that it turned out to be. During STS-1 and STS-2, the first two missions with the space shuttle, they actually opted to try and paint the external tank, or the ET, white to help with any sort of thermal issues that they thought that they might encounter, and then they went away with that to save a bit of weight, and then of course they didn't use the white paint for the rest of the program. So Sophie, I think, at least in terms of the mixture used on SLS, and also Delta IV Heavy, mind you, is just orange in its natural state, although it's a lot brighter of a shade of orange when it's first sprayed on, and the longer it sits out in the sun, it'll, I guess, tan in a way, and its overall color will darken, and it'll have a tan on it, essentially. So yeah, it's a very light orange when it's first sprayed on, but again, the longer it sits in the sun, the darker it gets, and that's most obvious on the LVSA, or the Launch Vehicle Stage Adapter, which is the conical-shaped structure connecting both the core stage and the ICPS, or the interim cryogenic propulsion stage. So, yep, light orange at first, and then darker orange the longer it sits out in the sun.
I wonder if we're going to get into a scenario here where Artemis II has to wait at the pad so long it kind of goes like scorched brown or something. I don't know.
I mean, if it was like Delta IV Heavy and just flowed a bunch of hydrogen through its engines at first and then just lit a big fireball around it, then it would launch almost black. But of course, that is not that is one of the many reasons Delta IV Heavy or Delta IV at all was never human certified. was because of that big fireball on RS-68 ignition.
Now we are at L-9 hours and 23.5 minutes, and as far as we know, we're continuing to count down, although at L-9 hours and 30 minutes, so 6.5 minutes ago, we were scheduled, 9 hours and 35 minutes, so 12 minutes ago, we were scheduled to go into fast fill of the liquid hydrogen on the core stage, but the latest update we have from NASA is from over 20 minutes ago at this point, saying that they have transitioned into fast fill for liquid oxygen, but no word on that liquid hydrogen. So it's going to be very interesting to see what has happened with that, whether there has been maybe a delay on that part, or if NASA has moved into that part of the countdown and they just haven't told us. So we will be waiting to see what happens there. But the clock at the press site is continuing to count down. And again, they've added an hour to today's countdown. And they were about a quarter of an hour early on some of the events as well. So maybe some wiggle room. I think the on-screen timeline may have gotten a little bit confused.
Yeah. I'm already telling the back channels that yeah. So in that timeline, it's the fast fill of the liquid hydrogen is in green. That shouldn't be the case because we don't have any confirmation that that's happened. But yeah,
Yeah. So
I'm-
go ahead.
I was gonna say I'm a little bit concerned that it should have happened already. We have not gotten any updates for like 30 minutes, and so please NASA, an update. That will be fun. That will be amazing.
Yeah, I mean, Pro, we've got up close cameras finally this time around whenever they like to show them. Con, we're still getting updates like kind of rarely. So again, we would love to tell you exactly what's happening, but we don't have the information to be able to provide you with exactly what's happening at every moment right now. So we are doing the best we can, and we're going to be, talking about this rocket for pretty much the entire day until NASA decides that they are no longer wet dressing this vehicle. In the meantime, whilst we talk about this rocket, I think we can answer some more questions and comments in the chat. We have a question here from the Cavalier Crusader asking, this is a good one, will we ever have a Space Launch System rocket with 4 SRBs? Think so.
I don't mean to
Anything is
laugh.
possible, but
Yeah,
I'm going to say I don't think so.
I don't mean to laugh. I don't mean to laugh at the question. I was more laughing at the fact or thought of a core stage equipped with 4 solid rocket motors. I don't think so. The core stage is only designed to handle the loads from 2 on either side. Strapping on 2 more solid rocket boosters will add on that much more stress to the core stage, and then of course it'll have to be reinforced, thus adding weight and material to handle it. And of course, I don't really think they had the need for that much lift at least off the ground yet. And if they ever did, I'm sure that they would just hop on over to Starship, because at that point it would be a lot cheaper to hitch a ride there than to re-engineer an entire rocket like this that is fully expendable.
At that point, you would probably just airlit the core stage.
Just pull a Titan 3, Titan 4, and let it.
Yeah, like Titan. Airlit RS-25. I mean, it was gonna be done with Ares 1 originally, but yeah, good luck with that.
But didn't Ares 1, wasn't that supposed to have the RS-68?
For the upper stage, there were thoughts on which way to go. I believe in the end it was RS-25 as the engine for the upper stage. Just in, vacuum optimized and all that stuff. Yeah. It's in part why Boeing is doing the core stage. It's a long story, but it boils down to Boeing was supposed to do the upper stage of Ares 1, and that contract was turned into the SLS core stage. If you look out there, you will see that the company that was doing the external tank for the shuttle was Lockheed Martin. Why is Boeing doing the core stage instead? Well, that's why. It's a mess. That was a mess.
Because, they're related, right?
Yeah.
They're very similar, upper stages and the SLS core stage.
It's the same
sarcasm.
thing.
Your sarcasm if you can't detect that.
Hey, it was gonna be orange. So orange, Hydrolox, RS-25s, come on, right? It's the same.
Same thing. Oh dear. Anyways, L-9 hours and 18 minutes. The next event on the timeline is the LH2 chill down of the ICPS upper stage. But again, if you're just joining us, we have gone well past the point of liquid hydrogen fast fill on the core stage, and we haven't heard anything about it from NASA yet. That was meant to happen almost 20 minutes ago at this point, and the last update we have from NASA almost half an hour ago. So again, we're waiting to see what on earth has happened with the liquid hydrogen. Last time around on the first wet dress rehearsal attempt, blame hydrogen. We all know how that went. A little bit leaky from that tail service mast umbilical. So we will just wait to see what NASA has to say when they say, hopefully when they say something and not if they say something. But I will say I am very much a fan of the engineering cameras we have finally been graced, our eyes have been graced upon for this test. It makes such a difference being able to actually see up close and personal with the hardware. Unlike the long range cameras that we otherwise have to use, which are a few miles away with, you know, it's Florida. There's a little bit of heat haze. Can't really delete the heat haze, unfortunately. If you did delete the heat haze, then nobody would be able to breathe. So that'd be a little bit unfortunate.
Our cameras would be a lot happier, though.
The cameras would be happier, but there'd be no one to turn the cameras on.
We've got an update.
Finally.
Teams in the firing room at NASA's Kennedy Space Center are experiencing an issue with ground communications and have moved to backup communication methods to maintain safe audio command and control. The launch director has decided to maintain the current vehicle state, continuing the liquid oxygen fast fill but delaying moving into liquid hydrogen fast fill, while engineers troubleshoot the issue. So there you go. Now blame communications, I guess. Should we start
the hydrogen load has been delayed, but it's not because of the hydrogen's fault. It's because they've got a communications issue. Okay. I think they had communications issues last time as well, so this will be interesting to see if they are related at all. But yeah, that's slightly concerning. But at least they have that backup.
It's interesting because they also had issues during the first wet dress as well. I believe Charlie talked about that. Those comms issues as well. It did not get to the point of them actually saying let's stop and like continue with where we are right now and not proceeding to any other steps. But well, we'll see what they do. That's an interesting development, I guess.
Yeah. Somewhat surprising of a development, I will say. But is the rocket not plugged in? Is it on the ground for communications? Like,
it's like when you see.
Is there not a cable they can just run or something?
It's like when you see like green flashes on your HDMI or something like that. I don't know. I have that issue a few times when I'm changing my monitors and things like that.
Yeah.
Imagine
or they've
them.
just got like a dodgy fiber line somewhere. I don't know. Maybe someone ran over an Ethernet cable. But at least they've got that backup. Fingers crossed they can resolve that soon, because if not, then yeah, they're holding the state of the rocket, which is not the point of the test. They of course want to be able to push ahead with the test. So yeah, we'll see what happens. Anyways, in the meantime, we've got a bit more support over the last couple of minutes. Anonymous has purchased a Starship print. Thank you very much for purchasing a print at shop.nasaspaceflight.com. I'm not sure who took that. Is Max, is that one of yours? I can't actually tell.
It is, yes.
Oh, there you go. You can thank them personally, Max, because of course, the photographer of the print gets a cut of the purchase.
Indeed. Thank you very much. That is one of my all-time favorite photos that I have ever taken, and I hope you enjoy it on your wall.
And we've also got Turtle Sanctuary with a $5 super chat. Can you hear me now? Oh dear. I think I don't know if the store team is working on it yet, but I do think we need a Blame Communications shirt to go alongside the Blame Hydrogen shirt. We can have a nice little, Blame collection on the shop.
Don't worry. By the time we get to Artemis II, we can just do Blame HLS.
Yeah.
Oh gosh.
That will sell like hotcakes, because. Yeah. Anyways, I'm gonna reserve my comments on that.
Yeah, compared to Artemis 1, 39A looks a little bit different from this perspective. You can see the Starship Tower and the work that's
Indeed.
going on down there.
Sure does.
You can even see in the background there, Space Launch Complex 41, just barely.
And a little bit to the right, I think you can see a little of Slick 40. I wish this will see Slick 37, because then in the future, Artemis 3, you could imagine having like Artemis 3 SLS here doing tanking tests or something like that. And then out there, Starship at 39A and Slick 37. How cool will that be, huh?
Indeed. And Turtle Sanctuary with another $5 super. If you can hear me, start hydrogen now. Thankfully, they don't have the voice assistant by Jeff Bezos in the capsule this time around. I won't say the name because I know I will trigger potentially hundreds, if not thousands, of them around the world, which would be kind of funny. But yeah. They did have that on Artemis 1. I think they called it Callisto. It was like an overall system package they had inside Orion for that flight. They don't have it this time around because on Artemis 2, if you didn't know, they have humans inside on this mission. So they have some humans that Mission Control can communicate with if they need to change anything on the spacecraft. But yeah, that's one of the interesting things from that first flight of SLS and Orion. Let's have a look through here for some more questions. Of course, if you are just joining us, you can tag us in chat at NASASpaceflight or at NSF, and that brings it into a nice little organised queue in the background here, which we can sort through and talk to. We have a good question here from Rosebud53, and they're asking, isn't Mission Control in Houston? So Max, if you wouldn't mind just giving a little example or a little description of the different teams, because of course Mission Control is in Houston, but there is a team in Florida looking over this rocket. Quite a big team.
Yes, indeed. So, as you just said, Ryan, that Mission Control themselves is in Houston, yes. But while the vehicle is on the ground and until it clears the tower, the rocket is in the hands of the launch team at the Kennedy Space Center. So, when the vehicle goes into its pitch and roll program, as it used to in shuttle, that is when the official comms handoff will be handed to the teams in Houston. So, while the vehicle is on the ground here, it is in the hands of those at KSC.
And of course, those are the kind of the official hubs for where all of that stuff happens. But I am sure there are going to be teams, pretty much, if not all over the country, all over the world, with the various NASA centers across the United States. And of course, there is a Canadian component to this mission with Jeremy Hansen. So I'm sure the Canadian Space Agency will probably be having some people doing some things in Canada. I don't know if ESA will be doing anything, because of course the service module is built by Airbus under contract from the European Space Agency, so maybe they have some involvement as well. Of course, the International Space Station, they have people all over the world, so I'm sure something similar will be going, not to that scale, of course, but I'm sure something similar will be happening with Artemis II. We're seeing some B-roll in the bottom right there of the Launch Control Center at the Kennedy Space Center, which is, of course, that kind of big horizontal building next to the VAB. Quite iconic and quite easy to spot if you ever happen to be on that KSC Visitor Center tour. And we have got fueling data. Yippee!
Yay.
We have got information on how much the core stage has been loaded with liquid hydrogen, which is 27% for the oxygen and 8% for the hydrogen on the core stage there.
Makes sense, because they're only on slow fill for hydrogen, so it's like when you just barely open the tap.
Could they technically fill up? I mean, it would take a long time, but could they technically fill up the entire tank on slow fill?
Oof, I don't know. One of the problems of doing that is the boil off, and also when in terminal count. So one of the problems that we saw during the terminal count on the first wet dress rehearsal is that the hydrogen tank comes up to flight pressure, and the way that they load hydrogen on SLS is by pressure differential. So while the oxygen, they have pumps on the tank farm, for hydrogen they what they do is they raise the pressure on the ground tanks, and sort of the pressure on the rocket itself is lower. And so that's what forces the hydrogen into the into the core stage, and they have valves and everything to regulate the flow and whatnot. So what happens is that when the rocket tanks go up to flight pressure, that's a higher pressure, and it sort of forces it forces them to be in a situation where it's like mostly fast fill. In the case of the interface between the ground systems and the flight systems, in that case it's through the bleed line. So the hydrogen boils off, right, and they need to reclaim it, and they also they chill down the engines and whatnot. So that boil off from chilling down the engines, that goes through the main, so through the main TSMU, the tail service mast umbilical, and there's a dedicated line, 4-inch line, and that's where they also see some of that leakage. That's where they saw that leak during terminal count, and that's essentially what led to that. So yes, they could fully load this, but they will see again the same issue with the terminal count if that leak were to happen again. So that's one of the things that they're trying to solve. It's a very technical thing, I know, but you know.
But at least
it's
we are
rocket
still
science.
seeing a little bit of loading there. Liquid hydrogen now sitting on the border of 9%, liquid oxygen up to 28%.
Yeah, liquid oxygen, thankfully, is fast fuel, I think.
Or at least that's the latest information NASA has provided us, what we're basing that off of. Speaking of blaming things, Max, you'll like this one from New Glenn. Geohound says, we need blame the cruise ship merch.
PTSD intensifies from hearing that, both from New Glenn Flight 2 and also, oh my gosh, what was it? There was a mission in early 2022. I can't remember the actual name of it off the top of my head. But I think there was a cruise ship violating the keep out zone in the water, which of course led to a S-word at about 30-ish seconds before T0. So, yeah, it has happened more than once, and it will just by the odds of how often rockets are flying now, likely will not be the last time, unfortunately. So, it isn't as prominent as blame hydrogen in this case. That is more to do with Falcon and New Glenn now. I think if a cruise ship violated the keep out zone for Artemis II, there would be a lot bigger problems.
That's the good thing of launching in the middle of the night, though.
Also true, yes.
You don't have any cruise ships in the way. I guess that's one advantage of the nighttime launch windows. But yeah.
But you've got to launch at night because the moon only comes out at night.
Yeah,
right. Speaking of nighttime, Don Cogswell is asking, if outer space is so cold, why is boil off an issue? And Alex, that sounds like a great question, with your name written all over it.
For the same reason that it's cold at night and it's hot in during the day, because the sun is out there, right? And unless you're in the shadow of the Earth or the moon, you're basically all the time being bombarded by light from the sun, and so that heats up materials, and also, it sort of hits the tank and it warms up the tank, and that means everything that is inside also gets warmed up, and that means, it boils off. Now, there are other things that may suffer the opposite. So because one side of the rocket gets hit by the sun, the other is also in the shadow. So in one side you get shadow, the other gets sunlight. So that means one is warm, the other is cold. Normally for cryogenic fluids like liquid oxygen, liquid hydrogen, liquid methane, the normal thing for them is just to boil off because of how that balance between light and shadow works. But for things such as kerosene, thinking now of the second stage of Falcon 9, for example, it might happen that the shadow side actually wins and it actually gets colder rather than being warmer. And so in that case, what happens is that you actually need to keep the kerosene warm. So in that case, for example, we've seen in the second stage of Falcon 9, Falcon Heavy has also done that as well, where they paint a gray stripe and that sort of allows a bit more sunlight to be able to come in. You usually also try to point your rocket in certain directions so that the sunlight is maybe to the engines and not the tanks, for example, or maybe the payload itself, but not the tanks. And that way you sort of keep the temperatures under control. You can also do venting as well, which lowers the tank pressure, lowers the temperature as well, etc., etc. There are ways to mitigate this, but yeah, it's an issue because you have the sun essentially hitting the tank. In this case, for Artemis, the second stage has its own TPS, its own thermal protection system. So the ICPS, that second stage, has that. Whenever they go to the exploration upper stage, instead of orange, you might actually see it white, and it's going to be painted white for that same reason, to keep the radiation off, sort of keep it colder. So it's not going to be orange like the core stage, even though it's going to be produced in a very similar fashion. But yeah, so there's your long answer. I guess you threw it to me, so you get an Alex answer.
Wouldn't expect anything less. Let's see if we can get any more Alex answers as we approach L-9 hours and 1 minute. Of course, if you are just joining us at this point, we should be well into LH2 chill down on the upper stage and approaching fast fill start of hydrogen on the upper stage. Unfortunately, though, that is not going to happen just yet, and they haven't even got to liquid hydrogen fast fill on the core stage, which was meant to happen half an hour ago at this point, because NASA, according to an update at 11:11 Eastern Time, are experiencing an issue with ground communications and have moved to a backup communication method to maintain safe audio command and control. And while they are on this backup communications system, NASA is not going to be doing anything different. They're not going to be progressing forwards with the countdown. They are going to keep the vehicle in its current state, and that current state is fast fill for liquid oxygen on the core stage, slow fill for liquid hydrogen on the core stage, and the upper stage not loading anything just yet. So plenty of time in the window. Of course, they added an hour to the countdown for this wet dress rehearsal to give them more time to troubleshoot and figure these things out. They're about 15 minutes ahead of schedule earlier in the countdown. So, I mean, technically they've got an hour and 15 minutes of margin to play with. So, fingers crossed they can get that communications issue sorted out as soon as possible to continue on with today's test of the SLS rocket ahead of Artemis II. Let's have a look through here. We have a question from North Space Enthusiast, and they're asking, will you be showing the Falcon 9 launch on this stream? Well, it depends when the Falcon 9 launch happens. If it happens today, then yes, but Alex, there is, should I say, some doubts about whether it will happen today or not, because we did see the fairings roll back and then come back out to the pad, or they went to the pad, then they came back to SpaceX, they went back to the pad. It's a bit of a back and forth going on with the Falcon 9 later today, I think.
Yeah, yesterday they rolled back the fairing, obviously with the Starlink stack inside. But, you know, they only rolled out a new stack with the fairings and whatnot this morning, very early this morning. So we'll see if that's enough time for them to be able to integrate that with the rocket and then roll it out to the pad. I believe it already is very close to the end of the window anyways. I think they were targeting 8:41 p.m. Eastern, which, by the way, that will be 11 minutes into the test window for SLS. So that's very funny. So yeah, and the window runs until 9 p.m. for that flight. But it could be an interesting one because that's the Bahamas Starlink. They're doing another landing out there in the Bahamas, so that's gonna be rather interesting if they do it today.
We will, of course, be keeping an eye out for that. And if it does happen, we will, of course, be covering it because we're NSF. That's what we do. We cover rocket launches. So if you want to see some rocket launches live on the channel, then I think there's a button you can press to do that. It might say subscribe. You know, you can press that, and you also get notified. You know, or if you want to follow us on the socials, you got all of that as well. You know, just saying if you're interested. We have got a bit more support as well over the last 10 minutes or so. So I'm going to thank these people very quickly. Earl Blake becoming a Pad Rat member. Thank you for that. And they also did a $20 super chat. No message, just throw in the money. But thank you very much for that support. Nonetheless, Earl Blake, it is greatly appreciated. And again, I know I say it all the time, but it's true. We genuinely could not do this without your guys' support. We also have Rodrigo Gozambrano. Sorry if I pronounced that incorrectly. But thank you for your support. And they are saying, or they're asking, during the wet dress rehearsal, how do they stop the count right before the rocket takes over? Is there a person standing behind the ground computer ready to unplug it? Alex, I'm pretty sure there's a software kind of hold or restriction that's put in place, right?
Yeah, the onboard computer. So we talked about how they're doing these 2 runs, right? The first run is not even handing over control of the count to the rocket. So it will be actually the ground computers, the ones doing the stop of the count. The second run, after they go through the terminal count, then the ground computers hand over control of the count to the onboard computers on SLS. But when they do that handover, then SLS runs like a bunch of checks, right? Automated checks and whatnot. And in those, it will see that it is not ready for launch because there are other certain procedures that they're not setting up for in this run, in this wet dress rehearsal. So it'll see through those checks that it is not ready for launch. A very similar thing, and so that's what's going to trigger the stop of the count. A very similar thing happens, for example, with Falcon 9. Where, T-minus 1 minute, we always say that's startup for Falcon 9. That's when the ground computers hand over control of the count to the onboard computers on the rocket. And a bunch of automated checks start happening. And if those checks say, hey, there's something that doesn't look good, then the countdown gets stopped automatically. So it will be a very similar thing here where it will see that it is not ready for launch because it's not in launch configuration. And so it will see that. And so it stops at T-minus 30 seconds, like 3 seconds after getting the control. It's like, whoops, nope, I'm not ready to go. And I'm stopping the count. And so we will still, so one of the things that they will not be able to go through, of course, is those last 30 seconds. But those last 30 seconds are essentially, things like turning on the hydrogen burn-off igniters, the water deluge, and igniting the RS-25 engines. And of course, that should be something that they're going to be doing much more interestingly, of course, during launch day, but not today. Those last 30 seconds are not going to be tested on today's wet dress.
We are, of course, not expecting any ignition events of the engines, especially the boosters, because once they're turned on, they're burning for their entire duration until they run out of propellant. Let's put it that way.
Yeah.
Also, Doug J. Oh, go ahead.
I was gonna say, also the RS-25s, if they ignite the RS-25s, like say, yeah, of course they don't light up the engines, the solar rocket boosters. But if they ignite the RS-25s, then they have to refurbish them. Like if they ignite and then they scrub, they have to go in and work on the engines and whatnot. So that will be another mess to deal with, and that's why they don't do a static fire test of the rocket.
Doug J with a $20 tip at tips.nasaspaceflight.com. Thank you very much for that. A bit more of a direct way to support us if you didn't know. That goes directly to us and it doesn't go through anybody else. So thank you for that, Doug. They're asking, hypothetically speaking, if they don't launch in March, would they roll back to the VAB? If so, what might that timeline look like for the next rollout to the pad? I happen to have vacation plans to Orlando and KSC March 6th through the 10th, so I'm hoping we can at least see it on the pad if they don't launch. Max, I'll toss that one over to you.
So in the event that they are not able to make the March window, that would most likely mean that they would have to roll back to service some components on the ICPS up top below Orion. While they now have the ability to do a lot more work on the TSM and both the FTS batteries as well on the pad, I believe that whatever work that would need to be done on the ICPS itself can only be done via the work platforms inside of the vehicle assembly building's High Bay 3. So yeah, if it can't make March, that means it's likely going to roll back, and depending on how long that work takes, it could be 2 weeks, it could be a month, it could be 2 months. I'm not entirely sure. I don't think it's going to be the latter half of time there. Hopefully, it'll be just a matter of weeks, maybe a month tops. But the vehicle, it is the clock is ticking once the vehicle gets to the pad. It isn't as high pressure or as tight of a timeline on the pad as it used to with Artemis I, because of the work that they can now do at the pad compared to what they would or could have done during Artemis I. But there is still some work that cannot be done over there. So if they can't make March, that means a rollback to Bay 3. Although everyone is hoping that is not the case, because that is essentially worst case scenario here in terms of timeline.
I do wonder though, because I feel like it will also depend on how today goes.
Yeah, 100%. Yes.
Because let's put an imaginary scenario, but there's a low chance that it might happen, right? So let's imagine this: today's test does not go to plan, and they're like, we need more time to work on this, to figure this out. And it's very unlikely that we're going to make a March attempt, which means they have to roll back yes or yes. Like, if they don't if they don't launch on March, then they have to roll back because of the servicing and whatnot. And so will they try to roll back as soon as possible so that they at least get enough time to be able to go back out for the April launch attempt? Because there's another window in April. It feels to me, because of the time that it takes to prepare for rollback and then prepare again for rollout again and do all of the launch preparations, that maybe they will try in that case. But then, I don't know, right? Like that, I'm talking a scenario where this test today does not go to plan, and they sort of decide that they're not going to go for the March attempt right away, just like the February attempt was thrown out the window right after the first wet dress rehearsal. So we'll see what happens. But if that were to be the case, Doug, in this hypothetical scenario, it might not be out there by the time March 6th to 10th comes around. You may still see a Starlink launch, though. Just saying. You're guaranteed to have one at the very least. But yeah,
most likely more.
Yeah, depending on when that happens. Yeah.
And that what we're seeing in the upper box, by the way, in the middle, is the New Glenn landing simulator, which is currently being lifted at Port Canaveral. So, as I said, plenty of action going on today at the Space Coast, and New Glenn also getting in on the action with its landing simulator there, and Blue Origin, testing some things out ahead of their next flight, which could be soon. I think is the best way to put that. When is it actually scheduled? Let me look on nextspaceflight.com. Funny good a website. Net March 2026 is what Next Spaceflight says. So next month.
There is actually news on that front. Blue Origin actually just posted not long after we went live that the payload for AST Space Mobile, who is the client flying on New Glenn Flight 3, their payload has since been encapsulated in New Glenn's payload fairings, which is quite exciting. But it's also, I'm still getting used to how big their fairings are and just how big New Glenn is in general. But that is 100% positive news on that front. Although it has been over half an hour now since our last update from NASA teams on the latest news from the comms issue. So there's some good news for today so far.
Of course, another rocket of Artemis. There are many rockets of Artemis. Pretty much all the rockets are rockets of Artemis at this point. But of course, New Glenn is meant to be launching Blue Moon Mark 1 and Mark 2. Or, well, it depends if Mark 2 comes after New Glenn 9x4, but it's still a variant of New Glenn nonetheless.
Mark II at some point will launch on New Glenn. We just don't know when, right?
Yes, exactly.
Mark 1, I believe Dave Limb most recently said 3 to 6 months. So we'll see which corresponding flight of New Glenn will that be, but me thinks it's probably going to be like New Glenn 5, 6. We'll see.
Again, if you're just joining us, you would have heard Max talk about that communications issue. The last update we had from NASA was at 11:11 Eastern Time. It's now 11:40. I wait 2 seconds. 3 Eastern Time, and we haven't heard anything since. So NASA is having a ground communications issue. They moved to a backup communication method to maintain safe audio command and control. But because of that, the launch director, Charlie Blackwell Thompson, made the call to not change the state of the rocket whilst they were on this kind of backup communications method. So they are staying in the exact same state. That state being fast fill of the oxygen on the core stage, slow fill of the hydrogen on the core stage, and no fill of any of the propellants on the ICPS upper stage. So that is the state the rocket remains in to the best of our knowledge. Hopefully we get another update from NASA soon. But yeah, again, we are only getting kind of these rare blog updates from NASA. There's no official kind of mission control loop that we can listen into, or, you know, if we had that information, trust me, we would be sharing it with you as soon as we could. But right now, we only have that last update from half an hour ago, over half an hour ago at this point. But nonetheless, we will continue live streaming. We'll continue talking about this big orange rocket, which is on the pad. And the clock at the press site continues counting down. We have a question here from ResistoChat asking, assuming the astronauts haven't been in quarantine since the first wet dress rehearsal, they haven't, they were let out of quarantine just after, what will they be doing, and have they already returned to quarantine? Must be quite hard while waiting. Well, Max, while they are preparing to go into quarantine again, I don't believe they've gone back into quarantine just yet for the new launch window, but they continue training and looking over all the systems and rehearsing, right?
Oh yeah, there is always something to do on their end, whether it be training on something else, making sure that systems are good on their front in the simulators or whatnot. There's always something to do, but at this moment they are not in quarantine just yet. They were actually due to arrive at the Kennedy Space Center the very next day following the first wet dress attempt. But of course that didn't go well, and they were since released from quarantine and have not been back in it since. But if today goes well, we may expect them to enter quarantine here, potentially by maybe mid to end of next week before they come to the Kennedy Space Center and get ready to fly. But of course, today has to go well in order for that to even be a reasonable possibility.
And of course, if you didn't know, the crew actually enters quarantine, or at least previously they entered quarantine in Houston, and then they flew themselves, or they were going to fly themselves to the Cape. So they, even though they are traveling between Houston and the Kennedy Space Center, they remain in quarantine. They fly themselves, and that quarantine period means they can, you know, stay in Houston where they live. Where they live with their family, so they're not, you know, too disconnected from the real world while they prepare for launch. Because of course we don't want any space bugs when we are on the other side of the moon. We have another question here from Kofi. Sorry if I pronounced that incorrectly, but they are asking, will there be any upgrades for the RS-25s for Artemis II? Alex, I will throw this one over to you. As far as I'm aware, they're just going to be repurposed space shuttle engines, but I'm not sure if NASA has done any work to them to make them more powerful between that flight, or if they're literally, to, in layman's terms, just kind of taking them off the shuttle and putting them on SLS.
So, to the engines themselves, no. But engine adjacent hardware, if you want to call it like that, yes. So, for Artemis 1 and 2, they not only reused the engines themselves, but also actuators and hydraulic systems and things like that, that sort of allowed them to be able to move the engines while in flight and things like that. However, that's where the reused hardware stops in that sense, right? Starting with Artemis 3, they need to manufacture new parts for that, for the gimbaling system and things like that. In general, just actuators and hydraulic systems and whatnot. So while the engines themselves will not be upgraded, I guess, well, not upgraded, but new at the very least will be those systems, engine adjacent systems, if you will, TVC and whatnot, as it's called. TVC meaning thrust vector control, the gimbaling system, actuators. For Artemis 5, and that will be when they debut the new Artis 25E engine. That's going to have a little bit of a boost in thrust, as well as being easier to manufacture, using 3D printing and things like that. Bunch of different simplifications of the engine design as well, because it's not going to be reusable anymore, whereas these are essentially brought down from the shuttle program, right? So that's one of the many different things to look out for, but Artemis 3, specifically the engines, will not have any upgrades.
And during that marvelous Alex answer, we got an update. Normal communications have been restored, and NASA teams have made the decision to transition to fast fill of the SLS rocket's core stage with super cold liquid hydrogen. Core stage liquid oxygen remains in fast fill. Fast fill rapidly loads hundreds of thousands of gallons of liquid hydrogen and liquid oxygen into the core stage tanks, blah 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 blah. Next up, teams will start chilling down the liquid hydrogen tank on the interim cryogenic propulsion stage of SLS. Good news! Finally, fast fill is underway. So where are we now? L-8 hours and 40 minutes. So that was scheduled to take place, fast fill of the hydrogen, at L-9 hours and 35 minutes. So according to that countdown, they are 40 minutes-ish. Oh, sorry, 50 minutes behind. Quick maths.
We're back to wet dress rehearsal number 1, I guess. Yes, we were also like 40 or 50 minutes behind. So yay, we're back to that. But in that case,
I think it's worth mentioning that this time around they have added an extra hour of holding time to the countdown.
Exactly.
So theoretically, and they were 15 minutes ahead of schedule earlier in the day. So theoretically, they've still, I'd say, probably got 20 minutes or so of margin in there. So I wouldn't worry just yet, unless anyone disagrees with me.
Let them do the fast fill for a little bit and see the concentrations of hydrogen, and then we'll talk. Now it's when the big moment starts, because this is when, when they transition to fast fill, that's when they increase the pressures through the line. It gets colder as well, so seals get a bit more. I guess the word is that here it's when it's the maximum impact of the fueling, right, on that sealing. So this is when they're gonna be keeping a close eye to those concentrations of hydrogen in the air, in that cavity in between the flight interface and the ground interface. So we'll see what happens. Of course, let's knock on wood and they don't cross any thresholds. If you remember from Artemis 1, I believe the threshold was 4%. Now they have increased that to 16% for Artemis 2. So they also gave themselves a little bit more leeway for that concentration to go up.
And also during the first attempt of the wet dress back earlier this month, they were seeing a leak concentration anywhere from 10 to 12% under normal load operations, and that is why they stopped prop load twice to let the seals warm up, as Charlie said, before resuming. And then, of course, they managed to fill the tank all the way. They saw the spike above 16% concentration when they began H2 tank pressurization in terminal count. So, yeah, nothing to worry about yet. They don't have a lot of margin, but the fact that they were able to resolve the comms issue as quickly as they did, oh God, I can't say the word. I can't say it. Anyway, they were able to solve it pretty quickly. So I'm not overly concerned yet. But again, this is when the TSMU, or the tail service mast umbilical, will either prove it's been repaired or not. And then this is really where this is where the oh my god, I can't talk. The trajectory for Artemis II will be dictated from this point onwards.
I will say, at the start of the stream, I was kind of bashing out the heat haze in Florida. It's actually not that bad.
Well, the sun's
pretty
also
good.
not out right now. It's behind a cloud.
Oh.
That's probably why the
okay.
heat is not
Okay.
bad right now.
I take my compliment back.
When the sun comes back out, it'll increase again. And actually, I think I see it beginning to come back. So give it a couple more minutes.
Okay. Well, I will enjoy the clearer views whilst we have the opportunity.
Really interested to see if we get back the graphic about the feeling of the SLS, with the percentages, because during the first wet dress they started seeing, or at least they did the stop of the flow into the liquid hydrogen tank around 55%, if I'm not mistaken. So it'll be interesting if we were to have that graphic, because then we can see if they go past that and they still are filling up the tank, right? But we'll see if they actually show that anytime soon. It'll be very interesting.
Yeah, again, that is something provided by NASA. They only show it when they feel like showing it. So if we had that data, trust me, we'd be sharing that with you the entire time. But unfortunately, we can only share with you what NASA shares with us to that degree. So we will bring that to you as soon as we have it. Also, this view giving us a wonderful view of that crane, which is positioned on the right-hand side. A little bit easier to see there up the ramp at 39B. Well, as I say that, the camera starts violently shaking. Anyway, swiftly moving on. Telstar86, thank you. Always in chat for your £5 super chat. They're saying, not sure if you answered already, but why does it take so much longer to load SLS compared to the rapid speed of Starship and Super Heavy? Max, I think it's kind of just SLS being SLS a little bit. The design is different. This is kind of how NASA has always done their rockets. They load carefully ahead of time, then they'll send out the crew, compared to SpaceX, which is more of that, let's do everything we want to do with the rocket before we fuel it, then we fuel it kind of mentality.
Yeah, it's a combination of multiple factors. I think the first and foremost of which being that SLS has a lot more capacity for propellant, and thus takes a lot longer to load in the first place, being about 700,000 gallons in general between the ICPS and the core stage of both hydrogen and oxygen in their liquid states. But also because of the SOFI in the insulation on the ICPS and on the core stage, SLS has the ability to be topped off when the tanks are full, and thus be held in a stable state when it is full of propellant. And that is the way NASA likes to do things, is when the vehicle is fueled and stable, that is when they send their people out, both their closeout crew and their astronauts, to board the vehicle. Falcon 9 and Starship do not have that SOFI or insulation, and their propellants are super chilled down to as cold as almost they can be. Thus, when at the instant they begin prop load, the propellant on board wants to boil off and warm up immediately. So that is why SpaceX opts to load and go, both with Starship and more prominently with Falcon 9, which is how they pioneered the load and go procedures. So essentially, SLS has the ability to hold, where Falcon 9 and Starship do not. But also, it's a difference in philosophy in how people approach the rocket. Again, Falcon 9 is completely empty when the crew approaches it and boards, whereas SLS is fully fueled and in a stable state. So just a bunch of differences.
Indeed. We have Bata Tui, sorry if I pronounced that wrong, gifting 5 Red Team memberships, but thank you nonetheless. Veronica Green, thank you for your support as well. And they're asking, where are the umbilicals where they put the liquid hydrogen through? You can't actually see it on the close-up view, but it's on the other side of the vehicle. I don't know if we could, if I could backseat produce for a moment and ask for a kind of full screen view of the rocket, so we can kind of point this out for everybody. But the main umbilicals we are looking at are called the tail service mast umbilicals, and they are at the aft end of the tail. So they're kind of the two grey structures which stand up from the mobile launcher. There we go. We can see the two grey structures which are at the bottom of the mobile launcher there.
Yeah,
And they
stick it
then
up.
connect up to the aft end of the core stage. Alex, I'm pretty sure one of them does hydrogen, the other does oxygen, right?
Yeah, the one on the left is mainly oxygen, and the one on the right is for hydrogen. The reason why it's at the bottom is for the same reason why you basically have the same thing on very much every rocket has it also on the bottom. That's where you load the stuff, and as it gets loaded, the level sort of goes up to the top of the tank. Now you see the umbilical tower, right? And you might think, well, wait, it's also connected to the core stage. What are they doing there? Well, you might see one arm at the very least is on the intertank section. So in that case, what it's doing is twofold. So it purges the intertank, the space in between the liquid oxygen tank and the hydrogen tank, right? And then it also is connected to the top of the hydrogen tank, and it takes in the gaseous hydrogen that is boiling off in the tank and sort of reclaiming it and sending off to a flare stack out there to the side of the pad. Up the tower, you also have a bunch of other umbilicals as well, but some of those are also for the ICPS, for the second stage, and some of those are also for like the same sort of purging as well of the launch vehicle stage adapter, for example, the cone-shaped orange part of the rocket and things like that. So you have a lot of things like purging of certain volumes, and also you have fueling of the upper stage, which is also done from the bottom of the tanks, just differently because one of the tanks is sort of sitting inside of what you would call like the interstage, that cone adapter there on the core stage. But yeah, so the main umbilicals that we sort of are talking about that leak and things like that they're seeing problems with, those are at the bottom, sticking up from the mobile launcher and connecting to the bottom of the core stage.
Thank you to Jake Keegan, currently producing the stream, for bringing up that closer view for us. We also have a $5 super from Ron Smith, and they're asking, what are the three towers for? Max, what are the three towers for?
Well, I was waiting to see if somebody had a funny answer there, but essentially those
I'll throw
are
you under the bus.
No, you're good. Essentially, the same function that we see the four towers over at Slick 41 and Slick 44 in being lightning protection. Those towers themselves aren't the actual protection. There are catenary wires that run in between all three and then down to the ground to help disperse electrical charges down to the ground. And of course away from SLS, as we saw a lot during the Artemis I campaign, because that took place for a majority of its time over the summer months here in Florida, which are very prone to daily afternoon storms. So that is why they are there. They have been in place, I believe, since 2008 or 9, when the Constellation program was still alive. But of course, while Constellation has since long died, Artemis is certainly still going strong and is currently serving SLS over at pad 39B. So they are actually, I think they are the tallest lightning towers at both the KSC and the Cape Canaveral Space Force Station as well. Although the towers at Slick 36 are also very, very, very tall. But TLDR, they are there for lightning protection.
We even saw them in use on Artemis 1.
Exactly. And to be clear, like, the number doesn't really matter that much as long as they do the work, right? For example, at LC-39A, Max, you were talking across other launch pads, but for example, 39A only has one. It's the one at the fixed service structure, right? Like, the number, sometimes it just comes down to what they think might be needed, right? So this has 3. We see, oh, there we go. There's the graphic. That's great news. Okay, so we are 39% of the hydrogen. Liquid oxygen already past halfway point. That's good. But coming back to my point, I was about to finish it, which is, different pads need different systems. The number just boils down to what they think might be needed. As long as they have this cable system that's sort of arresting the lightning and whatnot, that's perfect.
Now, unless I'm remembering things, or actually, I need to thank Wolf Caller for upgrading to a Red Team membership, but unless I'm remembering incorrectly, I think we're kind of around the point now where we saw the issues with the leakage beginning on the hydrogen TSMU umbilical. I guess I just said ATM machine. But they just ticked up to 40% liquid hydrogen there. So, we'll keep an eye, but at least according to this graphic, fueling continues in fast fill on that stage.
Yeah. We'll see once they get closer to like 55. I think it's when we saw them stop last time around. So that's gonna be interesting how far they get. Hopefully it's all the way to 100%, right? Like that should be the ideal of not seeing any issues. I think. Hang on, because I'm seeing the graphic. Have they also painted the umbilicals? So you can see there at the bottom, the tail service mast umbilicals. They're also painted.
Oh yeah.
See there? They're also there.
Red.
Yeah, those are the ones that we were talking about before. If anybody was wondering, those are the ones. Now we're looking at the launch tower, I guess.
Just wait for it to spin back round.
Yeah.
There
Exactly.
we go.
There you go.
Very interesting indeed. 41% now on the hydrogen. It's still going up. Again, fingers crossed, but it's still going up.
Yeah, it takes a while. Again, it's a pressure system. It's sort of like, I guess, it's the closest that you can get to your tap water, right? It's also a pressure system, although some places they do have pumps and whatnot. But like the liquid oxygen does get pumped from the tank farm. In the case of the hydrogen, you just have more pressure on the ground systems. You sort of increase the pressure, and that's the way that you push the hydrogen out. Mainly the reason why they do this is because hydrogen is very undense, I guess. It's the opposite of being dense, I guess. And so because of that, it will take a really big pump to be able to pump it. And that's also in part why the RS-25s and any Hydrolox engine you might see, like they usually have like a big chunk on the side, like a big thing to pump through the stuff. In that case, it's most likely the hydrogen pump, because it's very, very undense. And yeah, it makes rocket engines that are Hydrolox very complicated, but it's also much more efficient.
41% now on that hydrogen, 54% on the oxygen on the core stage. Still standing by for that loading to begin on the interim cryogenic propulsion stage, the upper stage for SLS Block 1. That is, was scheduled fast fill for the hydrogen to start at L-8 hours and 45 minutes. So we are just over 20 minutes behind on that as it stands. But again, core stage took a little while to get going because of that communications issue they had earlier today, which has now been resolved as of 20 minutes ago. 25 minutes ago, technically, I think. We have a question here from Bootleg Banana asking, will any pieces of the core stage survive re-entry? Max, it is scheduled or planned to re-enter over the Pacific Ocean. Now, it's going to be coming in quite hot and quite toasty. I would hope that most of it disintegrates in the atmosphere, but do you think there's a chance that any little bits of orange foam might drift down to the surface of the ocean, perhaps?
I mean, it's a big piece of hardware, and something that big, despite how fast it's going to be traveling, it's likely that it's not going to be 100% burnt up, especially in the more the thicker sections of the core stage that are more metal than others. So I think there will certainly be sections of it that come down in pieces. Although I think it'll be nowhere near one piece by the time it gets to the surface of the ocean. I think some of the RS-25 components may survive, like the power head, considering how much hardware is there.
Yeah.
Maybe the thrust puck as well. But a lot of it is actually pretty thin aluminum on the tank. So it's going to be in a number of pieces by the time it gets down there, but it's not going to be burned up all the way, I don't think.
But of course, there's a reason why there is a huge blocked off area in the Pacific Ocean where they plan to re-enter over in the eventuality, just in case anything does make it through. They don't want anyone in the way.
Correct. Emphasis on that.
Yeah.
And, we've seen this with other rockets as well, where technically this could go into orbit. Like, SLS has enough performance that the core stage could be dropped off in low Earth orbit, at least with the ICPS. But the problem is you don't want that to happen, right? Like, you want it to actually be coming down over an area that you can control. And the way to do that is launching into this weird sort of elliptical low Earth orbit, right? It's not even a low Earth orbit by then. Like, the apogee, it's already in medium Earth orbit. But, like, because you want the core stage to be brought down, right? Unless you have a capability of relighting the engines or like a separate propulsion system or something like that, the only way to do that is tweaking your launch trajectory so that eventually it comes back down. And we've seen that with other rockets, namely the shuttle. See, you thought I was going to say Starship, right? But the shuttle also did this with the external tank. No, but yeah, we've seen that with Starship, of course, with the shuttle. Used to do that as well with the external tank. But yeah, so once they go to Block 1B, if they go to Block 1B, I guess, that'll be different because the expression upper stage is heavier. So the core stage will actually be, I think in that case, it's re-entering over the Indian Ocean. It's a bit shorter in speed, or maybe Eastern Atlantic. I'll have to look it up. Depends on the cutoff speed.
Yeah. Just for comparison, the core stage will drop off the ICPS and Orion spacecraft in a 2,222 kilometer by 27 kilometer orbit. So the perigee there, the lowest part of the orbit, dipping into the Earth's atmosphere, allowing the core stage to re-enter. But yeah, 2,222 kilometers. If you want to do a quick comparison, the ISS orbits at about 400 kilometers. So that is a significantly higher apogee than the International Space Station just after launch. So on the very first orbit, fun fact, ladies and gentlemen, on the very first orbit just after launch, Orion will become the spacecraft. It will set the intergalactic record for the toilet, which has traveled the furthest away from Earth, breaking the record of Polaris Dawn.
Oh my god. I was wondering when that was going to come up.
with Dragon there. As soon as they passed 1,300 kilometers, that record's being broken.
It's a big upgrade compared to Apollo, though. Apollo was a bag, so hey. Toilets around the moon. Who would have thunk it?
This is the earth-shattering research and development which goes on behind closed doors at NASA, ladies and gentlemen. This is what the taxpayers' money is put towards toilets around the moon.
You know the thing, too bold to go, right?
Oh dear. Okay, let's see if there's some more questions we can talk about. First of all, offshore diver, and they're asking if for some reason they missed the March window, will they have to roll back? Max, I believe the answer is yes.
Yeah, there are some components on the vehicle that they cannot service over at the pad, unfortunately. Granted that they can do a lot more than they could have during Artemis I, hence why you see that crane on the right-hand side of the mobile launcher there. That is there in place to service the Flight Termination System batteries, or the FTS batteries, which they had to actually roll back for more than once, I believe, during the Artemis I campaign back in 2022. They can now service that at the pad. But I believe depending on what the issue is with the TSM or the tail service mast umbilical, and also some things that have to be serviced with the ICPS up top there, right above the orange core stage, also can only be serviced inside of the vehicle assembly building's High Bay 3 when the work platforms have been extended. So yeah, if all does not go well today, and they have to unfortunately miss the March window, I do believe a rollback would be incoming.
And while we have this engineering camera on the left-hand screen, we have a couple questions related. First of all, there's a lot of venting coming from the aft end of the vehicle there, and Souls Redacted is asking, why do they chill the RS-25s so early in the count compared to Merlin and Raptor? Alex, correct me if I'm wrong, but I don't think they're actually chilling the engines right now.
Well, now
Right?
they are. So
Okay.
it's a very complicated process where, when they start loading oxygen into the core stage, we do see the venting, but it's technically not. Like, you can actually notice the difference between the venting that we saw at the start of the stream when we saw the engines and they were venting and whatnot. It's a lot different. Now they are actually doing engine chill, and that venting is engine bleed, just like we see again, Falcon 9, Starship, and other rockets, right? We see that all the time where, they chill down the engines and they vent overboard the gaseous oxygen. Of course, in this case, for the hydrogen, that also goes through the engine, but it's not dumped overboard. They reclaim that through the tail service mast umbilical, and that's what I was referencing like an hour ago, where, during pressurizing the tanks and whatnot, they also do drainbacks and all that, and so that's when they also saw some of the increase in concentrations in that plate. But mainly the problem here, or sort of the reason why, it's because it's a very long countdown. A lot of the conditioning of the engine just takes a long time to do, and so I think nominally it takes like 2 hours, and after 2 hours it's already conditioned, but they do that early on so that it's already conditioned and they don't have to worry about that. Like, it's already in the state that they need it to be, essentially, and so it stays there for the entirety of the countdown. So it's sort of as if you were to see, for example, Merlin and Raptor engine chill very early on, and then it's just kept chilled all the time during the remaining of the count. Like, instead of doing Raptor engine chill, I think it's like T-minus 19 minutes, right? So if instead of that, maybe you start that at T-minus 50 minutes, it takes 20 minutes or so to do, so T-minus 30, it's already chilled down, but you just keep it there. And you keep it there in that state until you actually have to light up the engines. That's more or less what happens here. The actual process, it only takes like a couple of hours. I say only, but like, compared to how long?
Beep, 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 beep. We've got an update.
Yay!
Teams began chilling down the liquid hydrogen lines for the interim cryogenic propulsion stage of NASA's SLS rocket. This critical step cools the propellant lines ahead of loading supercold liquid hydrogen, chilled to minus 423 degrees Fahrenheit, into the SLS's upper stage tank. The chill down process ensures that hardware is properly conditioned for cryogenic temperatures, reducing thermal shock and safeguarding system integrity. Once complete, teams will transition to fast fill of liquid hydrogen, followed by liquid oxygen operations later in the countdown. The ICPS, powered by an R10 engine, will provide the in-space boost needed to send Orion into high Earth orbit before its lunar flyby. So, we are getting ready for loading the upper stage of SLS, which is great news. So that chill down of the liquid hydrogen lines is scheduled to take place at L-minus 9 hours and 15 minutes. So we're about 1 hour behind schedule here. So a similar delay to what we saw with the core stage, which, kind of makes sense considering the ground communications issue they had earlier today. That's not the only update we had, however, because NASA has also published an press release, that's also English. They say, during a news conference at 2 p.m. Eastern Time on Thursday, that's today, in less than 2 hours' time, NASA will discuss the findings of investigations into the 2024 crewed flight test of Boeing's Starliner to the International Space Station. NASA
Oh, boy.
participants include Administrator Jared Isaacman and Associate Administrator Amit Kshatriya. That is really out of character for NASA, announcing a press conference 90 minutes, 103 minutes to be exact, before it's scheduled to start. Today just
I
got
didn't
even
realize.
more exciting.
I didn't realize that. I was like, oh, on Thursday. I'm like, okay, that's
Thursday's today.
Thursday's today. It's 2 p.m. Thursday. That's like, yeah, wow. When you put it like that.
Okay. I'm gonna say,
And
I think we might have some in wet dress rehearsal flight entertainment to watch while this wet dress is ongoing, because that is a very sudden announcement, very sudden and unexpected. Like, forgive me if I missed something, but that's incredibly unexpected.
what I find more interesting in this press release is that after that it says that media must RSVP no later than 30 minutes prior to the start, and I'm like, that's an hour from now. Like literally media has 1 hour advance notice, so that's interesting too. Wow.
On an unrelated note, I'm opening Outlook and I'm very quickly drafting an email.
You're gonna RSVP too?
Yeah, let's just put that in there and put that in there.
Live here
Okay,
with
okay.
NSF. Press coverage.
Ryan signs up for a press conference. There we go. Email sent. Okay, moving on. Yeah, stay tuned for that, because that's something else we'll be able to talk about. Not necessarily related at all to SLS, but I mean, Boeing built the core stage, Boeing built Starliner, I guess, crossover there. Yeah, very interesting. Very, very interesting. Anyways, let's move on. We have a anonymous store message here saying Godspeed Artemis II, and they have gotten the brand new vintage Artemis design on the t-shirt. That's one of 2 designs currently available on the store for Artemis, so keep your eyes out. We don't have I don't think we have an official Wet Dress 2 milestone, because on the store page we have the rollout milestone, the Wet Dress milestone, and the launch milestone. But
Wet Dress 2, the way of the hydrogen? Something
yeah,
like that?
I mean, if we get another Wet Dress design in there, I'm sure people will be very interested. I can't believe it wasn't hydrogen is a favorite right now. Blame communications. Yeah, plenty of options. Speaking of this wet dress rehearsal, Fighting Falcon is asking what changes are being made to this countdown compared to the one we had a couple weeks ago. Alex, I'll throw this one over to you. We've been talking a lot about the extra hour of time they have, but how has that actually come to be?
Well, the first one, so, you see on the top left, it says L-, right? That's the time to 8:30 p.m. Eastern, essentially. But internally, the way that the systems are running, it's through a T- clock. So the T- clock counts differently, and it counts down to different events. And that clock can actually stop, while the L- clock, essentially the clock counting down to 8:30, can still running, right? The reason why they do this is because the events don't need to happen at the same time as time, I guess, will be the way to say it. Like, the T- clock is a procedural clock. It is a clock that runs with the procedures, with the events of the countdown, and not counting down to the actual time. It's not counting down to 8:30. It's counting down differently. It's counting down along with the events. And so what that means, in essence, is that there are 3 planned holds, 3 moments where that clock stops and then sort of resumes while they do something, right? In the case of the first building hold, for example, it happens while they're getting ready for tanking. And so it stops at T-8 minutes and 10 seconds, which in the L- clock, the one on the top that you see there above the US flag right now, that that sort of start of the built-in hold, it will happen. It happened already. That was at L minus 12 hours and 35 minutes. And what they've done is that first hold before tanking starts, they extended that by 30 minutes. So instead of being 2 hours and 15 minutes long, now it's 2 hours and 45 minutes long. And as a result, that gave them enough time to troubleshoot anything that might have been needed ahead of tanking operations. And so that's probably why we were seeing that sort of them getting ahead of the timeline a bit, right? We were talking about at the start of the stream, they are ahead by 15 minutes or something like that. And it's like, well, that was one of the things that probably helped them. Then after tanking is complete, and once all of the stages are in replenishment, as it's called, then they do another hold for about an hour and 10 minutes now. It used to be 40 minutes only. They have also extended that hold by 30 minutes, and that allows them to get ready for when the closeout crew goes out to the pad and prepares Orion for the crew. Now, today's test, of course, will not feature the astronauts that are going to be flying on Artemis II. They are still at Houston. But the closeout crew will go out to the pad and will rehearse closing the hatch on Orion, preparing the crew access arm and everything for flight, essentially, just like on launch day. So adding those 30 minutes before and after the tanking operations probably is giving them that extra time to be able to troubleshoot any issues, and if they need a little bit of more time. But that's essentially one of the main changes compared to what we were, to sort of where we were on the first attempt here. I will note another thing. When they released the modified countdown, it seems like they deleted a bunch of the closeout crew operations on Orion. It seems like as soon as they arrive, they're going to be starting to close out the hatch instead of simulating actually loading the astronauts on board. So instead of having the extra trouble of getting people, simulating getting people into the capsule and everything, that probably was already rehearsed on the first wet dress. So things like that, for example, are not shown, and the timing between when they arrive to the pad and when they start closing the hatches, for example, is a lot shorter this time around than on the first wet dress, which also means they're supposed to leave the pad, I believe, about an hour earlier than before. So that's also rather interesting, because that gives them also time. Once the closeout crew departs the pad, there's another built-in hold right before terminal count. So, across the board, they're giving themselves time, which is very important. And it's something that they did not have on the first wet dress to be able to run through all of the troubleshooting.
And we've got
Was that
another...
long enough?
That was plenty long enough, Alex. Thank you very much. It even gave me time to do a tweet about the Starliner situation. We have another bit of support here from Veronica Green asking, will they also drain the water tank at T0 today? Or since the liquids won't be ignited, there's no need to suppress acoustic energy. That will only happen on launch day. Max, I believe the deluge system only goes off in the event they'll be lighting the engines, and they're not lighting the engines today, so I don't think that's going off, right?
Yes, some of the milestones that we will not be seeing today will be the ignition of the ROFEs or the radially outward firing igniters, which are those sparks that we see below the RS-25s to help the RS-25s ignite in a safer environment without the risk of excess hydrogen. But also, we will not be seeing the activation of the sound suppression water system, which is the deluge system, which floods below the area below the Mobile Launcher 1 to help deaden any sound from both the RS-25s and the SRBs upon launch, to try and minimize damage to the mobile launcher and the surrounding areas as much as possible. But yeah, the countdown will be stopped before we get to either milestone today, unfortunately, or rather fortunately.
Let's see what else we've got here. We've got a question here from Mafia Liquid Oxygen, Mafia Locks, and they're asking, what are the black and white logos on everything? Also, moon, moon, moon. Well, I guess we can see from this perspective, but Max, those look even better perspective.
Lots there.
Yeah, lots of black and white squares. What on earth are the black and white squares for?
So those are essentially serving as reference points for all of their engineering cameras for motion of the vehicle for analysis after flight. These help to serve as visual indicators as to how the vehicle is behaving under flight conditions. So essentially, it just makes it easier to track the vehicle's motion as opposed to just looking at the shape without any distinctive points to reference. So that's essentially what those are, and those will become very useful for tracking cameras downrange, but also the plethora of cameras that NASA has all around the launch pad for analysis after launch.
See what else we've got. Another good thing from this view, we have Ziggy asking, what is the 917 on the left side of the screen? Well, in this case, it's 813, and it's on the right side of the screen, Max. But those are the numbers of the engineering cameras, right? These are engineering cameras, and they have numbers?
I'm not 100% certain, but I think that's just the actual name, the name of the camera that we are looking at. I know they had different naming schemes for the engineering cameras for shuttle, like they had. I think they were Echo, and then whatever number they were, or E9 or whatever. It was E something or Echo something. But I think that's just the actual name of the camera. But I'm not 100% sure.
And Laura has been on the store saying big thanks to the Lockheed Martin Orion design team. They got the vintage Artemis Kid shirt and the SLS assembly shirt as well. Hopefully you enjoy those. Got the certain Swedish furniture store inspired instruction manual design. Let's have a look. Oh, good question from Resisto Jet. Oh, we've got an update.
70%.
Liquid hydrogen up to 70%, and no reports.
Let's go.
I don't want to jinx it, but no reports of issues. 71% and no reports of issues. Oxygen up to 68%. This is great progress. And hydrogen.
Someone mute this man.
Hydrogen. Okay. Well, we'll see you later.
ICPS. Look at that.
That's what I was
Liquid
saying. Hydrogen is 6% on, even though they've grayed it out for some reason. There we go. Thank you, NASA. Whoa! Look at that animation. I wonder how much that cost them. 6% now on the liquid hydrogen for the upper stage. Great news.
So that means they are in fast fill, I guess, for that one. They don't... I guess they do have some kind of timeline for slow fill on the upper stage, but apparently, like, the only event that they actually wrote down on their timeline was just fast fill. So... But it's loading hydrogen. That's the important thing.
J-Volt in chat says 813 is the engineering cam. I think it's 8th level, 13th camera, but not 100%. I mean, that would make sense if that was the case, but
that would make
interesting
sense,
information. They are absolutely booking it with this liquid hydrogen load on both stages now. This is great to see.
Don't jinx it. Stop it.
Can I not be excited? Sorry for being excited, Max. Forgive me. Oh, and for some reason, Jay Keegan has thought this is a great time to cover the numbers with a timeline. What are you doing, Jay Keegan? Oh my goodness. But there you go. You can now see on the timeline we are well into LH2 fast fill beginning now on the upper stage. That was meant to happen all the way back at L-8 hours and 45 minutes. So looks like they've made up a quarter of an hour or so of time. They were an hour delayed. Now they're kind of 45 minutes delayed. I don't want to jinx anything, but my confidence has been boosted.
So it's worth noting that... Oh, go ahead. Go ahead, Alex.
Well, I was going to say, I don't want to jinx it either, but shall we talk about what happens next in the loading sequence?
I mean, I'm not going to jinx it. If you want to jinx it, go right ahead.
Yeah, because, you know, once they get close to full, they transition from fast fill to topping, essentially sort of like getting that final few percentage into the tank, and per the timeline, that should have occurred at L-8 hours and 10 minutes. So we are right now sort of 12 minutes after that point in the L- clock, but they're already in the 70s. I don't know, like that can be maybe in the next 10-15 minutes. Once they get into the 90s, I think they start topping at 94-95%, if I'm not mistaken. So just less than 20% to go.
Good news.
And there we go. NASA confirms fast fill of liquid hydrogen on the ICPS. So there we go.
That is indeed good news. Although I am curious now, because even though H2 load is progressing nicely as we can see, I do wonder how that TSM is behaving in terms of leak concentration, if there even is any. At the moment we have no way of confirming if there even is or not. We do not have access to the cameras or data that would show that. But it's safe to say that based on how things are progressing now, the leak concentration, if there was any, is nowhere near that 16% threshold. Because I believe by this point they had stopped H2 flow into both the core stage and the ICPS for sure at least once by now, if not twice. I think they did twice overall during the first wet dress attempt, but so far not at all.
Yeah, so we'll see if that continues to be the case. Once they go into topping and replenishment, the flow of liquid hydrogen is lower, so the chances of a higher increase in that concentration goes down. So we can be a little bit more relieved, I guess, once we get to that point in the fueling.
We've gotten a wonderful tip from AltCloud. $5 tip. Where's hydrogen? There it is. There's the hydrogen. We have another. Thank you, AltCloud, for that one. We have a £2 super chat from 321 Ad Astra, and they're asking, how long does SLS sit there fully fueled for? Well, Max, considering we're at L-7 hours and 55 minutes right now, and they're probably going to be wrapping up fueling within the next hour or so, depending how things delay, or if they're not even going to mention the leakage. It's going to be sat there for a little while, isn't it? It's going to be sat there for a little while.
Yeah, assuming a nominal timeline was followed, the vehicle would be sitting at the pad fully fueled and in a stable state in being topped off for about 5 hours before the initially planned T0 or window opening. So it'll be sitting there fully fueled for quite a while, but that's how NASA wants it. They want the vehicle full of fuel and stable before people approach it, which means the vehicle is going to be alive once the closeout crew and the astronauts come near it, which is one of the more fascinating things, because I've always wanted to hear what either the space shuttle or SLS sounds like when it's full of fuel. Either the hissing, the groaning, the popping, the venting, everything. SLS is fully alive.
And we have another question from Hyperstring Rocketry. Interesting name. And they're asking, what would be an alternative for the human landing system on Artemis III if Starship HLS isn't ready by then, considering Blue Origin Blue Moon is made for SLS Block 1B? Well, Blue Moon is launching on New Glenn. It's not made for SLS Block 1B. So Blue Moon will definitely be able to launch on New Glenn by that point, I would assume, if they don't hit any major delays. So yeah, Alex, do you think that the Blue Moon Mark 1.5 or Blue Moon Mark 2 IL or whatever Blue is making, I've lost track at this point, but do you think that would be ready in time to take over on Artemis 3 if Starship isn't ready?
That's a big question, right? Which one will be ready first? Eric Berger reported, I think it was last week, right, about what the potential solution by Blue might be, talking about it being some kind of sort of initial capability or something like that for Mark II, slimmed down version, and needing 3 different tugs for the uncrewed demo and for the crewed demo. Mind you, the uncrewed demo needs to happen a year before, so they can review the procedures and the data and everything. So this means the uncrewed version of this whole concept must happen within the next 12 to 20 months, basically. Yeah, it needs to happen next year. So we'll see. I have no idea. I don't think neither will be ready for 2028 landing, whether it's January 2028 or December 2028. Within that big window. But as you said, Ryan, it doesn't matter that SLS Block 1B was going to fly on Artemis 5. It's not tied to the lander, or rather, the lander is not tied to SLS. It's irrelevant in that case. It can do the same if it's Block 1.
RC Horseman, again, a member of our team, gifting 10 Red Team memberships. So thank you, RC. And if you received one of those, make sure to thank RC in chat, because that is very generous, as always, to everybody gifting memberships, because it's the best of both worlds. You support the person supporting the gifted membership, the person gifting the memberships, that's what I'm trying to say, supports the channel, and people who might not necessarily be able to afford a membership get a month of membership for free. Win-win, all around. Okay, speaking of HLS, Thomas, Mr. Disney, is asking, Starship question, when do you think we will see the first Starship launch from Florida? Max, I'll go to you first. SpaceX have been making great progress at LC-39A.
They absolutely have. It is coming along very nicely. I think, assuming that the start of the version 3 program goes well, I think we could see the first launch from Florida by probably end of summer into fall time. I think at the earliest. So I think come like maybe September, October timeframe is when we could possibly see the first flight of Starship. But that's of course from pad 39A and not 37. I think we're still maybe a year and a half away from pad 37 seeing its first launch in general. But for Starship from Florida itself, hopefully by the end of summer or into fall time.
What do you think, Alex?
I would agree that, yeah, September, October. I wouldn't be surprised if it slips, but not because of the pad. As you all might know, it's tied to the production of vehicles at Starbase, and it'll depend on how flights go out from there, right? Because they're gonna have the first and second launch and whatnot. They're preparing Booster 19, Ship 39 for flight, so it'll depend on that timeline. It'll also depend on how fast they can produce vehicles out of there and then transport those vehicles out to Florida. And so we've seen already Mark Mac 31, which will be the barge that they'll use to be able to transport that hardware to Florida. But of course, if you think about it, transporting those vehicles from Starbase to Florida means stealing, if you will, a pair of vehicles from the from Starbase, and so it will be stealing one flight, I guess, from Starbase, unless they start reusing, especially the boosters. They already have the knowledge from version 2, right? So maybe the booster side of things might be okay, but the ship, we'll see. We'll see how they can start, when they can start reusing and whatnot. I think that's probably going to be the driver here for getting a Starship launch out of Florida. It'll be stealing one of the other vehicles from Starbase, essentially.
I have to agree with everything that's been said. Basically, yeah. I could come out with some random statement. They're going to launch next month. No, they're not. No, they're not. Yeah. Something that has just caught my attention though is that big, beautiful vent currently taking place from the core stage. Looks a little bit more windy than it was the first attempt. It's being pushed away a little bit quicker.
A little bit, yeah. I remember how kind of off-putting it was to see the vent being pushed almost. Hey, Pelican, that vent being pushed pretty much almost straight down because there was almost no wind at that point. But the wind is blowing pretty much northeast today, which is why that cloud is behaving the way it is. But of course, that they have the ability to vent the oxygen overboard as opposed to the hydrogen, because hydrogen is very flammable, and the last thing you want to do is have any sort sort of concentration of that around your vehicle, because all you need is a spark to cause a massive problem. So good thing that we are seeing that, and we should see that close off at around T-minus 5 minutes or so when they close that valve off and begin aux tank pressurization on the core stage. So, but we have a long way to go before we get to that point.
We have another question here from ResistoChat, and they're asking, on Artemis II, are they planning to run the RS-25s at 109%? And why would you run them higher than 100%, presumably pushing them harder? Alex, the RS-25s have this wonderful thing where they were rated to 100%, and then NASA was like, wait, we can make them more powerful. And then they had to make numbers bigger than 100%, which shouldn't really be possible, but, you know, it's all about how the engines were rated. Do you want to try and explain that one to us? Because I have a feeling I wouldn't do a very good job, considering the last sentence I just said.
You know, 100% here refers to the original thrust level of the RS-25 when it was designed way back in like the 70s and early 80s. And so that's what it's referring to. It's just like that. It's not 109% to the current thrust, right? The current thrust is 100%, right? Like the maximum current thrust is 100%. But compared to the one that it had way back in that time, it is 109%. And so that's why they still refer to that. And the reason why they use that is very simple. It's because you have a reference point, right? It's sort of like why Celsius is 0 degrees at the, you know, melting point of water and boiling point of water is 100. Well, because you need a reference point, and that's sort of the whole deal, right? So it boils down to just that. Now, initially, again, the RS-25 was 100%. Then they upgraded that to 104.5% later into the program, and with SLS, because it doesn't need to be reused, they can push it a little bit more. It not only doesn't need to be reused, it doesn't get reused altogether. So they can push it up to 109%. With the RS-25E, that engine is actually being designed to be able to run 111% thrust, and that'll be debuting on Artemis 5. That'll be giving about half a ton of extra performance to translunar injection. So not a lot, but hey, a little bit. You can carry a few more moon rocks, I guess, or rather on the way back. I don't know. I mix
You can carry more
myself
space
here.
toilets.
Oh my god.
That's a lot of space toilets. But yeah.
Anyways. Looks like there's a tour bus driving past the VAB right now. Looks like they'll get a nice view of SLS. Of course, they won't drive. They're not going to SLS today. With the testing, there's got a thing called an exclusion zone to make sure that nobody gets too close. But if they're doing the same as they were on the first wet dress rehearsal, I'm pretty sure they'll still go up to the gantry, where there's a new pretend engine on a pretend static fire stand, which is a little bit strange, but you know, whatever sells the tickets. 7 hours and 44 minutes left to go in the countdown. That is, of course, counting down to the first simulated T0. We are not launching today. We are simply filling up the rocket to see if all the systems prepare or work before going into an actual launch attempt opening no earlier than the beginning of March. So just testing everything and making sure everything is good to go before we get to that point, collecting as much data as possible, and making sure those hydrogen leaks are not as leaky. And at least, according to all the information we have so far, they're much less leaky than they were. So, again, I don't want to jinx it, but I'm getting excited. Just saying. Mike A. Griffey is asking, how many space toilets can SLS launch? What's the payload to TLI again? I'm being left in the dark here. This is brilliant. Space Launch System. Seriously, nobody wants to comment on the space toilets? That's hilarious. Right, let's have a look here. Payload to TLI is 27 metric tons. I wonder how much does the toilet weigh on Orion?
About that much, Ryan. About that much.
How much does the Orion base toilet weigh? This is riveting stuff. The Universal Waste Management System, designed for the Orion spacecraft, weighs approximately 45 kilograms. So if we do 27,000 divided by 45... Ladies and gentlemen, boys and girls, if the Space Launch System was launching exclusively Universal Waste Management Systems, otherwise known as space toilets, they could launch 600 on a translunar injection. That's a lot of toilets. Seriously? Nothing? Okay. I'll stop doubling down on the toilets. Something which is being doubled down, though, is Dave Limp. That wasn't even meant to be. I was trying to do another pun, and I did too. That was an accident. Anyways, Dave Limp, he's just replied to us on X. We were talking about Blue Origin earlier, confirming that Flight 3 of New Glenn will reuse Booster 2, which is of course the booster which landed on the last flight. So that'll be pretty cool.
Well, roll it out for launch.
Hopefully we see it soon. Just saying.
Where that, Dave? Where that? Where is it? Where's my booster?
Where's my booster, Dave?
Where's my booster, Dave?
Oh, dear. Oh, dear. I'm gonna rephrase this, but Yeoman is asking, does the wet dress rehearsal include testing the space toilet? I don't believe so. I think it will be only used when in space. The astronauts aren't actually getting on board today, so even though the closeout crew is planned to go out to the spacecraft and close it out and make sure everything is ready to go, like rehearsing for a launch, the astronauts aren't in Florida right now. They are still in Houston. They're not even in quarantine yet because we are a little ways away from the launch window opening, so they'll be going into quarantine about 2 weeks beforehand, 14 days beforehand, which for March 6th, which is the first official window at least, would be tomorrow. So it'll be interesting to see if we get that update tomorrow from NASA. And Max, I believe we have an update.
Indeed, it looks like, according to NASA's latest blog update at 12:43, NASA teams have begun chill down for the liquid oxygen lines on the interim cryogenic propulsion stage. So they are getting ready to load LOX into the ICPS very soon. And once they do, they will then transition pretty quickly, assuming all goes well, into fast fill for oxygen. So things are still trending in the right direction.
Again, I don't want to jinx it, but I'm feeling much more confident than I was on the last attempt for the wet dress. Just saying. But again, not going to jinx it. Not my fault. No responsibility. Anyways. 33 Raptors Mimi, thank you for gifting a Red Team membership. This is actually a great question. Okay, I know we've been talking a lot about space toilets, and I do apologise, but this is actually a great question because it's surrounding, like, astronaut well-being, and I think there's genuinely a mission rule in place about this. ArcCloud is asking if the toilet fails during the mission, what happens? I think if the toilet fails before TLI, they don't actually go for TLI. Like, I think that might be the rule.
I don't know off the top of my head, but that sounds about right. I know it's a really big deal whenever one breaks on the space station because human waste builds up pretty quick, and that is not something you want to have in the area around where people are. It's a big deal. So I think if there was to be any issue on it, yeah, I think that would call for a full mission abort.
Which would be equally devastating and hilarious at the same time. I'm getting a lot of puns being messaged to me by a certain Spanish colleague about
I'm just posting that on the back channel.
using
You
the
don't need to say
lavatory
anything.
whilst in low Earth orbit. But yeah, I mean, I'm seeing them and they're quite funny, but I'm not going to read them out.
What, they cannot go if they cannot go? Is that the one?
Yeah, yeah. Geordie Deviant, toilet merch question mark? I mean, I'll pass it on to the store team. It's what the people want. It's what the people want. It's what the people get. Okay. Outdoor Man Show is asking, why doesn't 39B use a fixed service structure at 39A? Is it due to the SLS weight on the crawler if there are weight concerns? Max, I don't think it's a weight concern. I think it's more, again, we were talking earlier about how SLS kind of came to be and how it's a bit old and how it's a bit unique. 39B is also a bit old. It was kind of designed to be a clean pad, wasn't it?
It was, but also, despite the fact that SLS is comprised of a bunch of shuttle hardware, which did utilize a fixed service structure, or FSS, because of the nature of how SLS is constructed and what it needs its own bespoke launch tower attached to its mobile launch platform. Hence why you see it the way it is now, going back to how they had their launch pad structure during Apollo. That is just how that is just the nature of how SLS has been designed in terms of its connections and being able to make sure that it can get to where it needs to while being serviceable. So, I guess
the camera's moving. Sorry, Max. The camera's moving.
Where are you moving to?
We're zooming. Oh
Oh
no!
God,
No! They got away. Why?
Okay, so that means they might be checking something out that maybe looked off nominal, or they just, I don't know. That was rather curious.
Oh, why'd you cut away for? Now
They
we're
were
more
looking at
interested
who's-
in what you're looking at. What did you do that for? Oh my days.
Yeah, that was not us. That was NASA who switched away from that camera.
Yeah.
That was so rude.
That's such a tease. That's such a tease. It's like, oh, we're going to zoom into some actual interesting hardware. No, we're going to cut away. You can't see that. Oh. Well, now I'm bitterly disappointed. Anyway, sorry for interrupting you, Max. You may continue.
No, you're good. But going back to the point of just how SLS is, yes, it is also incredibly heavy, mostly due to the fact that they roll out there both with the tower and also with the five segment solid rocket boosters attached to either side of the orange core stage. And because of that, they actually had to upgrade CT2, or Crawler Transporter 2, to carry the extra weight. And as a result, it is the heaviest self-propelled vehicle in the world, as is certified by the Guinness Book of World Records. So, yeah, a whole bunch of factors in there, but essentially that is just the nature of how SLS has been designed compared to how we had become used to with the space shuttle.
And you can also see a little bit of the difference there as well. Thanks for this camera, I guess. I'm gonna use it now that we are in this. They switch away from the other much more cooler one of the engines, but you can also see that there's a bunch of umbilicals, right, that go up further up the tower, and sort of the rocket, I guess, not the tower. The shuttle, it did have the beanie cap, and it also had the ground umbilical carrier plate. So those two, for example, got connected on the pad. But everything else, the external tank was fueled through the orbiter was connected to the mobile launcher, right? So all of those things you already had connected to the mobile launcher anyways. So you didn't need an extra tower. That's the point that I'm trying to make here, right? For the shuttle, you only needed that because you needed to load the people on board, right? And you had the rotating service structure to load payloads and accommodations, etc., etc. For SLS, like, even if you sort of, if you go back and if you go back and sort of consider them not doing a clean pad, and you're like, okay, how do we design this pad then for this tall rocket that needs umbilicals to the second stage and Orion? And thanks for that view, because that's the one that I was looking the side of my eye, because it shows the umbilicals to the second stage, to the ICPS. It shows the umbilical also to the launch vehicle stage adapter. So all of that will need to also be plugged in when you roll the rocket. And if it were to be fixed, then you need to plug it in. You need to test it out there on the pad. The idea was that SLS was supposed to just be built, all of it inside NVAB, nothing at all, and you just roll it out to the pad, hook it into the ground systems, and just launch it, right? But reality caught up to their original wishes, I guess, or design aspirations. But yeah, that's how it is, I guess.
We've also just got confirmation from SpaceX. They are indeed going ahead with tonight's launch of the Starlink mission, with the first landing back in the Bahamas for the first time in a year. So yes, we'll be covering it. Before you ask, everybody, we'll be covering it as if we didn't have enough things to talk about today already, with the wet dress rehearsal, and then this apparent Starliner conference coming up in an hour's time, and now a Starlink launch as well, and Blue Origin preparing for New Glenn at the port, Canaveral as well. Oh, just so much stuff going on. So much stuff going on.
It's a law of physics at this point, where if one major occurrence is happening in the world of spaceflight, there has to be multiple others to also combat with it. So it's just how it is sometimes.
Very briefly, we have 321 Ad Astra again in with the support. Thank you very much for that, with the £5 super chat, and they're asking, if the upper stage gets struck by lightning on ascent, would this trigger an abort? Oh, liquid hydrogen, 100% on the core stage without issues. Let's go. That is marvelous news. 39% on the upper stage for hydrogen, 86% liquid oxygen loaded on the core stage. Fully loaded with hydrogen. No, again, I'm not going to say no leaks happened, because some amount of leakage is to be expected. But considering the speed at which they've loaded hydrogen on that stage, the leaks must have been within margin. Again, we'll wait for NASA to officially confirm this.
Yeah.
But that looks very, very confidence-inducing to me.
That will be great news, because again, once they go into replenishment, the flow of hydrogen is lower, and so those concentrations should not go up again. We should stress, though, there's still terminal count, right? When they go and pressurize the tank, that is also another point where that concentration can increase if there's some kind of leakage. But if it did not at this point, it may stay in place. It may not leak and not see any higher concentrations during terminal count. And this is also great news for the closeout teams, because then this means now they just need to care about the interim cryogenic propulsion stage, right? The ICPS. Finish loading that, and once everything is in replenishment, the closeout teams can start going out to the pad and getting ready for all of their different rehearsals and whatnot, simulating a launch day operation. So great news all across.
Yeah, I'm actually speechless at the fact they've managed to get through this so well. Anyways, Max, very quickly, before we let you go have a little break, I think the answer to this question, which if the upper stage gets struck by lightning on ascent, would this trigger an abort? I think the answer is more, NASA would never launch it in a condition where that could happen, right?
Correct, and that is why there are Phase 1 and Phase 2 lightning warnings in place here at the Kennedy Space Center, and also rules associated with prop load in said rules. I believe they are not permitted to start prop load in a Phase 2 lightning warning, but if a Phase 2 occurs during prop load, they may be okay to proceed under certain under certain conditions. I'm not entirely sure what those are, though. I'm not too familiar. But yeah, if there is any severe risk of an actual lightning strike near launch, or near the targeted T0, you would think that NASA would opt to not even choose to launch that with storms being that close at all, because the last thing you want to have happen is lightning strike your launch vehicle during flight and causing a whole bunch of other issues. And we saw this during, of course, Apollo 12, where we got the famous switch SCE to aux call out from Mission Control. So yeah, ideally they would not be there would be no risk of those two things happening in such close proximity.
Of course. And with that, Max, I'm going to say thank you very much for joining us. We'll have you back on the stream later, but in the meantime, enjoy question mark the rest. I'm not sure if you'll be able to enjoy what's going to be coming up in 50 minutes time, but yeah.
Well, we will see what happens, both with the wet dress here, but also the news associated with Boeing Starliner capsule, which we are all kind of eagerly awaiting now. But thank you very much, everybody, and I will see you all again later on in the stream.
And in Max's place, joining us is a voice we've heard once before on NSF. Alice is joining us. How you doing, Alice?
Hey, I'm good. How are you, Ryan?
Doing great. I am very happy that we have a belly full of hydrogen, as Chris put it on X, on this rocket. Finally, the leakage is not as leakage as it was before. We're within margins. We've got a full load of hydrogen. I'm just feeling very happy right now because
I'm glad to hear that.
At least to my eyes, I'm not an engineer, but it looks like it's going much better than it did before, which is,
It certainly
what
does.
do you think?
You
Are you
seem to
more
have had
confidence induced?
You seem to have had an hour of drama, to say the least. I've been listening in to you for the last hour. Comms problems, press releases announced, and then the belly full of hydrogen. So who knows what's going to happen with this?
Yeah, but fingers crossed things continue to go as smoothly as they have been, barring the communications issue NASA had a little bit earlier in the day, just gone 1 o'clock in the afternoon local time. Currently counting through L-7 hours, 25 minutes and 45 seconds to that simulated T0 this evening, which is a little bit earlier. If you're wondering why we're live earlier than we were for the first wet dress rehearsal, first of all, the test has actually been extended by 1 hour. They've added 30 minutes to 2 built-in holds in the countdown, and the actual simulated T0 is earlier than it was before. So that's why we are a little bit earlier, as we get another splendid view of the aft end of this vehicle. Also joining us on the stream, we have a voice you'll all be very familiar with. Julia is joining us from the field. How are you doing today, Julia?
Why, hello there, Ryan. I am doing well. So I left home. I came out to the press site because why not come where you can sit in an air-conditioned room gazing out on launch pads and a rocket being fueled in its test flight while crocheting. All things I could do at home, right? I could watch along on the stream, but I am fortunate enough to be able to have this view with my own eyes. So I am here. I'm watching the clock. I'm so pleased to hear we have a belly full of fuel. Interested to see what the rest of the day brings. Hopefully, the rest of the test we are here for today goes just smoothly.
Yep. I mean, I was about to say we have more tests to go than we have seen so far, and in terms of the stream, that's true. In terms of the actual countdown, that's not. The countdown began at L-49 hours and 50 minutes. We were live streaming that, of course, over on Space Coast Live, 24/7, available every day of the week. But in terms of this live stream, at least, we've got plenty more tests to go. Around this time in the scheduled countdown, we should be seeing the liquid hydrogen replenish on the ICPS interim cryogenic propulsion stage, that upper stage for SLS. Of course, as we have been talking about over the last few hours, that communications issue kind of paused the count for a few minutes there. So they were running about an hour behind schedule, then about 45 minutes behind schedule, maybe half an hour behind schedule on some things. So it'll be interesting to see when those things take place. But again, as I was just saying, NASA has included an additional hour of hold time for this test, so they have plenty of margin to get these things done, and it looks like they're getting things done with a good effort, considering that hydrogen tank is now fully filled on the core stage, and the oxygen tank is almost there as well, which is great to see. Great to see. In the meantime, though, we have gotten a bit more support from Mike Alpha Tango Sierra. Mats is in chat, gifting 20 Red Team memberships. That's a lot of memberships, so if you received one of them, make sure to thank Mats in chat, because, well, as I've said before, and as I will say again, the gifted memberships are a really fantastic way to not only support the community, but also support the channel, because the person gifting the membership supports the channel, and the people getting the memberships get a month free behind-the-scenes content. And trust me when I say there's a lot of behind-the-scenes content, because there are a load of behind-the-scenes photos posted from all around our sites, from Starbase to the Cape. And if Artemis II launches within a month, then you're going to be seeing some behind-the-scenes SLS photos as well, which is something I would not want to miss out on. Heat haze is getting a little bit worse than it was earlier today, but Julia, how is the weather from your perspective? Of course, that first wet dress rehearsal took place during the big cold that was in Florida, to put it lightly, earlier in the year. But how's the weather today?
The weather today is very Florida. We're currently sitting at 83 degrees, so outside it is rather today in the sun. Too humid, but there is a breeze in the air. Nothing that will prevent, so far at least, nothing that will prevent this test from going forward without weather issues. Looking ahead in the forecast, there shouldn't be any of those phase warnings that Max was talking about earlier.
And we have just gotten an update from NASA. They are saying that NASA teams have transitioned the SLS rocket's core stage liquid hydrogen tank to replenish mode. This marks an important milestone in the test, as teams reach this step without exceeding the ground safety limit of the hydrogen leak concentration, as was observed during the first Artemis II wet dress rehearsal. So that confirms, I believe that ground safety limit is the 16% leak rate. That confirms this hydrogen load was conducted without going above that limit, which is fantastic news. NASA continues to say that after completing fast fill and topping, Replenish keeps the tank at flight-ready levels by replacing any LH2 lost to boil-off. Replenish is essential for maintaining stable pressure and temperature in the tank as the countdown continues. Cryogenic propellants like liquid hydrogen naturally warm and evaporate over time, even in insulated tanks. Replenishing the tanks counteracts this by continuously adding small amounts of liquid propellant to maintain the correct volume and pressure. This phase ensures the core stage remains fully fueled and ready to power its 4 RS-25 engines at liftoff, providing thrust needed to send Orion and its crew to the journey around the moon. But there you go, good news. Fully fueled, no leaks above margin. Of course, Alice, hydrogen, very little element, likes to escape sometimes, so some leakage is to be expected, but this is great news that they have managed to fully fuel under that 16% margin that they have.
Such positive news. I'm really pleased to hear that they've had such a success so far. You know, there was a bit of a worrying time an hour ago when we were talking about comms issues, but to see that they've progressed as quickly as they have with the hydrogen is such great and positive news for all of us watching.
And hopefully bodes well for the rest of the test and the coming days towards that March launch window. Okay. Let's go through some more questions. If you are just joining us, you can tag us in chat at NASASpaceflight or at NSF if you don't want to write NASASpaceflight, because it's quite long and annoying if you're on mobile. Trust me, I know. November 939NN5 is asking, is that curved skidded looking section on the top camera where the swivel part of the shuttle pad went on? I don't think we can see it right now, but on some of the NASA views we can see kind of like a curved rail section, almost looks like a railway track on the pad, Alex. That is where the rotating service structure went, right?
Yeah, that is sort of the rail tracks. I'm sure Chris will probably be able to talk. There we go. will be able to talk about this much better than me because I do remember some of the stuff he talks about the yellow cab and everything on the rotating service structure. But yeah, I think you can even see a little bit of where he was or where he used to sit there. The 4 footings of that structure. 3 of those were removed on 39A. One of them still is in place because it's partially structural for the fixed service structure. But yeah, on 39B, of course, everything went away, both the fixed service structure and the rotating service structure.
And along those lines, we have another question. Oh, maybe I've lost it. But there was another question in chat I remember from earlier. They were asking why 39B doesn't have a fixed service structure whilst we're talking about that rotating service structure. And that's essentially because 39B was built as a clean pad. There were going to be, theoretically, at least the idea was that multiple rockets could launch from here. You could have SLS, you could have Omega, if anyone remembers that rocket, which sadly no longer exists. But, you know, out of all of the rockets that could potentially launch from 39B, the only rocket that has turned up so far is the Space Launch System. We have a question here from Andrew R90, and they're asking, why is the rocket not white from ice forming on the rocket? And Alice, well, that's because it's orange, right? That's what that insulation is for.
Absolutely, that tanned insulation that we've been looking at since we had the rollout several weeks ago. It was much brighter before, and it's been out in that gorgeous Floridian sun and has gone a little bit darker in the meantime. And I believe that it's naturally that colour, which is why we are looking at an orange rocket and not a white one.
We did see on the Wet Dress Rehearsal 1, again, those were very cold for Florida temperatures outside. We could see kind of a little bit of a shine isn't the right word, but a little bit of a tinted kind of dulled colour, which looked to be a little bit of frost maybe, just because it was cold on the outside of the rocket. But especially at these temperatures in this kind of sun, don't be expecting to see something like that on the outside of the rocket. Again, it's just one of those design differences between SLS. SLS is not the only rocket to have insulation. Of course, the shuttle famously had its big orange insulated external tank. Other rockets paint their insulation, so it's more difficult to see. Vulcan has insulation. Atlas has insulation. New Glenn has insulation. Pretty much every rocket has insulation. Most rockets have insulation. It's just sometimes a bit more difficult to spot than others. Alex, I even think Falcon 9 has some insulation between the tanks, or it's not. I don't think it's on the outside of the rocket, but it's like inside the rocket, I think.
Yeah, there's parts that are insulated. Namely, if you think about it, Falcon 9 does have, so SLS here. Oh, thanks, because that change of camera helps a lot with the point that I'm trying to make. That excuse me, SLS has separate tanks. So the liquid oxygen tank is at the top, and then separate to that is the liquid hydrogen tank. On Falcon 9, the tanks share just one common dome, but it's not separate. Like, it's just one tube, and then you put in the middle a separation, like a barrier or something like that. In this case, a bulkhead, and that's how you create the 2 tanks, right? So that bulkhead, for example, is insulated because you have the liquid oxygen on top on Falcon 9, and then at the bottom you have RP1 kerosene, and the kerosene is obviously much warmer, and it can become, it can essentially freeze if it touches the liquid oxygen. And so that, for example, internally, they do have insulation. Also, for example, the transfer tube is insulated as well because it goes through the kerosene tank, and it carries liquid oxygen. So you have to think about those things as well when it comes to insulating. Here as well, I mean, we can see one of the transfer lines there right at the top of that engine cam. You can see like one tube coming out of the engine section of SLS. One of those is the liquid oxygen transfer line, and that goes from the core stage engine section up the rocket and into the liquid oxygen tank to load liquid oxygen and also drain liquid oxygen during flight and after any tanking test or something like that. That's where the liquid oxygen goes through, and that is also insulated. Otherwise, it will also be frosty if it weren't insulated.
Indeed. This engine view is also giving us a wonderful perspective on the venting, wisping up every now and then from around the aft of the vehicle. Just saw another tour bus go by. In the support queue, I've got a couple people. Thank you very much for your support, Kyle Ryder. They're asking, they are cruising out of Miami Saturday evening. Odds of being able to see the Starlink Group 6104 launch pass by. I mean, it kind of depends what time you'll be in the air. I'm going to quickly check nextspaceflight.com, which is saying launching at 9:04 in the evening local time. So if you're airborne around that time, then perhaps, hopefully your plane doesn't violate the range. Or if you're I thought they meant airplane cruising. I actually now think you mean boat cruising, which would make much more sense. Make sure your cruise ship doesn't violate the range if you're on a boat. But yeah, 9:04 is when that window opens. So if you're around at that time, but that window does extend well into the next day, the early hours of the following day. So yeah, just depends if that lines up. But you know, download Next Spaceflight on your phone. Keep an eye. It's a good app. Highly recommend. Keeps you up to date. Approaching L-7 hours in the countdown now at this point. We are well beyond the point of ICPS LH2 replenish in the countdown. Hydrogen's replenish has started in the core stage, but I believe they are still loading in the upper stage at that point. So still running a little bit behind, but again, they have that extra margin this time around, so I wouldn't be concerned about anything just yet. And then, so those are the next events we should be keeping an eye on with the upper stage. And then after that, we should see the some communication systems being activated on Orion. And then we'll see liquid oxygen topping and replenish on the core stage and fast fill on the upper stage.
Let's hope they don't have any more issues with the communication systems. I believe it was during the Orion turn on last time that they were having some issues as well.
Yeah, that was very interesting. I don't know if we have like the definitive data to say the exact same issue happened again, but it's very interesting. They had communications issues last time, as they mentioned in the post-test press conference. That's a lot of P's, and this time around with their blog post update. So it'll be there is going to be a follow-up press conference tomorrow following this test. So maybe that's something to ask if there was any commonality would be the right word between those two communications issues. Very interesting nonetheless. Approaching 7 hours 10 minutes now. Wind is blowing the flag. Doesn't look too bad. We've got another bit of support here. Thank you to L4580 Motions for your support here as well. And we have some more questions. Again, if you're just joining us, questions and comments, tag us in chat at NASASpaceflight or at NSF, and we will do our best to answer them to the best of our abilities. Alan Plax, this is a great question. Nice one we can go around the room on. They're asking, any thoughts if the 2028 moon landing target is realistic? Julia, I'm going to start with you. What do you think about 2028 for Artemis III landing on the moon? Do you think that's realistic? Or do you think it's going to be delayed even further?
Well, let's see, we're in February 2026. I'm looking outside to my left, and I see a tower still under construction that may need modifications, well, you know. So as far as Orion and SLS go, landing on the moon. Well, I did see with my own eye a lunar lander going for testing to Texas, so I don't have a better answer than 2028 is This is hard, Ryan. I would say 2028 there's a lot of things that need to be done to reach that goal. I would like to be optimistic. I would like to see us go back to the moon. I've been wishing and hoping for this for a long time, before Mars, going to the moon and doing the things we need to do there. So late 2028 is where I'm going to set.
Oh, and we are nearly
Ooh.
at 100% on the oxygen on the core stage. And we are still loading on the hydrogen, and oxygen load has started on the upper stage. Are they gonna do the spinny animation, or because it's still grayed out, and it shouldn't be grayed out because they're fueling the oxygen.
Maybe
they're oxidizing.
maybe when it enters fast fill, they do that. I don't know.
Maybe it gets more color as it starts to add to it. Maybe they went with grayscale for this. Who knows? Because it does say liquid oxygen above it in gray, so maybe that was a really poor choice of coloring.
And it looks like they fixed the graphic so that hydrogen is in the correct tank on the upper stage. So well done, NASA. Progress has been made. That's another great step.
Yeah, because on the first wet dress, it was opposite. It was it was the hydrogen below and the oxygen above, and it's like nope. On the ICPS, it's the opposite of the core stage.
Hopefully, we get an update from NASA soon.
It's definitely going with grey. They've just gone with the grey color. They should have gone with something a little bit brighter.
I think it turned for the hydrogen didn't do the swoosh thing like at 6% or something like that.
Maybe it'll kick in around that point. I don't know.
Yeah. Let's see.
Anyways, Alice, 2028 moon landing. Do you think that's realistic, or do you think it's going to be delayed a little bit?
Oh, goodness me. It's never going to happen on time, is it? Let's be honest. I shouldn't be such a pessimist, but I am. Furthering what Julia said about I was there in December looking at the tower thinking that's not ready. That's going to go through more testing. Look, it sounds like a long time, 2 years, but it really isn't. And until we start to get Artemis II up and back again and learn all the data from that, we really cannot say at this point whether or not they're going to be on time. It really, if everything goes 100% and it all goes to plan, maybe. But I'll be honest, these things slip all the time because space is far harder than people realize.
What do you think, Alex? Do you think it's going to happen in 2028, or do you think it's going to happen a little bit later?
I think it's going to be later. Maybe I'm too European, and my thoughts on the whole race with the Chinese and whatever are not aligned. But hey, we have the European service module is ours. I used to joke on the first wet dress rehearsal that here in Spain we do the thermal control system, and that's gonna be put to the test on this mission because now they actually have people on board that they need to keep cool or warm depending on where in the mission they are. So look, I think it shouldn't be rushed. I felt these past few movements to try to rush it do not sit well with my own feelings and opinions and whatnot, mainly because I think we shouldn't trade off sustainability for rushing. I feel like even if it takes a couple more years, we should go through the sustainable route. We were talking about before, Eric Berger's reporting on the sort of faster way for Blue Origin to potentially deliver a lander, right? And it entails some weird transporter thing, tug or whatever, and modifying the Mark II lander. Like, it feels moot in my opinion. If they were ready already for 2030, why not wait the two extra years and actually build out a sustainable architecture, right? It feels weird to me, even if you were to go with Blue Origin, right? I don't know. And also, going away from being able to do reusability and refueling and zero boil off, which I feel like those are technologies that will enhance future exploration, not just of the moon, but also beyond and like Mars and whatnot. And it feels like we're trading off a short-term goal of getting there as quick as possible with long-term sustainability, and it feels wrong to me. I don't know. I know that's not the sentiment of everybody, and things like that. Again, call me too European. I'm not too concerned about Tigonauts on the moon in 2029 or 2030, because again, we have not heard even what their plans for sustainability are. Beyond, they plan a moon base, and there's the Long March 9 coming up and whatnot, sort of like a Chinese Starship sort of thing. But I mean, just imagine myself right now shrugging as I say all of that, right? Like, we'll see if all of that will happen, right? It's too short of a timeline, and there's not a lot. So we'll see. We'll see.
I do love the way you just apologized to being too European to two other Europeans.
Oh, there we go.
It's
Now it's
blue.
colored.
And blue, see, it's going the same color. They just started grey.
10%
Very
now
exciting.
oxygen and 84% hydrogen on the upper stage. I'm going to say the core stage is there we go.
There we
Core stage
go.
fully fueled, 100% on the oxygen and hydrogen, which is great news. So this tanking is going much smoother than it did last time around, which is wonderful to see as we progress towards Artemis. Oh, it's gone back down. Oh, we're back up to 100%. It's gonna. I think it's riding the sensor right now. It's like bouncing up and down. Maybe there's some waves going over the sensor, bouncing it between 99 and 100%. But I'm pretty safe to say it's pretty fully fueled at this point on the core stage, and hopefully the upper stage doesn't take too much longer. As a reminder, fast fill on the upper stage is scheduled to begin at L-6 hours and 30 minutes. So they might be, unless they're still in slow fill, they might be a little bit ahead of schedule on that one. But
Looks
I'm not
like it, doesn't
100%
it?
sure. Yeah.
We're like ahead of schedule.
Ahead of schedule is good.
Catching up, should it be? We'll see. Okay, Ryan, you didn't answer the question. What do you think? Do you think we're going to be landing in 2028?
I'm going to be an optimist, and I think 2028 is good, because I honestly think that maybe some good old-fashioned billionaire rivalry might encourage SpaceX and Blue Origin to push ahead and get a lander good to go for that time frame. I agree with what Alex said. I think we shouldn't be sacrificing sustainability in favor of beating the Chinese, but I do think that I am in favor of some good old-fashioned rivalry between SpaceX and Blue Origin, Elon Musk and Jeff Bezos, to get a lunar lander ready to fly in 2028.
I cannot wait until, we are beyond that point of Artemis 3 and we start talking about bases on the moon and things like that, and we start having people in our comments saying, oh, the Starship lunar base is better than the Blue Origin lunar base or something like that. Instead of the lunar lander, it's gonna be lunar base race, right? It's the race for the base. If you've watched For All Mankind, you
Oh, yes.
see that. But go, Alice.
I was going to say, it's coming back on the air soon. I can't wait.
Yeah.
We're counting down till March.
I'm watching one episode per day. I started on February 15th, and because it's like 40 episodes, it's like 40 days. So it's like, yeah.
Love that.
Almost 7 hours exactly now left in the countdown, which is great to see. On that 2028 moon landing, Kevin is asking, which will be first, Artemis 2 or GTA 6? I'm gonna hazard a guess, Artemis 2.
Yes,
Just saying.
absolutely. Yeah.
I'm not gonna be too pessimistic on Artemis 2, especially considering how well this fueling test has gone so far. GTA 6 maybe a little bit more delayed. And there we go, under 7 hours until that simulated T0 this evening. Again, simulated because we're not actually going to be launching this rocket. This rocket is not launching today. We're simply doing everything but launching the rocket. We're testing all of the systems, testing everything we can. Yeah, if this was a launch attempt day, the only things we're not doing is launching the rocket and putting the crew on board. Pretty much everything else in the countdown is going ahead as planned. So it's a full-on rehearsal, which is exactly what you want to do before you launch one of the most powerful rockets ever made and NASA's most powerful rocket at liftoff.
Definitely don't want to see a launch. If something happens and it launches, there's definitely a problem.
We do not want any Tiangong 3 accidental static fire becoming dynamic fires happening today.
Well, definitely a bit of an issue. Speaking of issues, I think there's a presser coming up at the top of the hour about another issue that they've been dealing with at NASA.
Great transition, yeah, because if you have just tuned in over the last half hour or so, NASA has sprung a surprise conference on us to discuss the findings of an investigation into the crew flight test of Boeing's Starliner back in 2024. And, you know, I'm not one of those people which has been covering NASA for over 20 years, but I've been covering NASA for a little while at this point. And the only time I remember a conference being sprung on us 2 hours before it was going to start was when Jared Isaacman announced the expedited return of Crew 11 with that medical issue on board the International Space Station last month. So, you know, I'm not going to say the findings are going to be fantastic, but, you know, it's something to watch, and we will be piping that into this stream as well, because we're very interested to see what they have to say. On that conference, participants will be Administrator Jared Isaacman and Associate Administrator Amit Kshatriya. So, the two top dogs at NASA talking about probably the most famous mission to come out of NASA over the past 2 years. Might be something to keep an eye on. So we will be bringing that to you.
You called it spicy earlier, Ryan, because it sounds like it's going to be very spicy. If the early reports are correct, and we've seen them come out already on some media outlets, they're saying that it could possibly be a Type A mishap, which is pretty scathing. That's the same level that they had both the shuttle disasters at. Not a good sign.
Not a good sign indeed. And that again puts the future of Starliner into question a little bit. Will Boeing continue to fund it? Will Boeing continue to develop it? Because that's... So I was going to say that's not good, but that's an understatement.
It is. And what a date for it to be coming out, right in the middle of the wet dress rehearsal for Artemis II. Very questionable.
Yeah, I mean, the timing is a question mark, but again, NASA... Or NASA Administrator Jared Isaacman says he wants to be transparent. He wants to bring this information out as soon as it is available. Perhaps coincidentally, this report wrapped up right now, and he wants to get this information out as soon as he can. So,
I'm surprised they didn't do it on Friday. Friday, 5 p.m. That's when you give the bad news.
Right? He obviously didn't get that memo when he was onboarded.
Anyway,
maybe he just wants to bring us some extra spice in the middle of all of this.
Yeah, wants to give us some in-test entertainment for Artemis II's second wet dress rehearsal. That vent is continuing to go at the top of the core stage, as we should expect, but it's going much faster than than what I remember on wet dress rehearsal 1. So maybe that's a sign the winds are a little bit higher. I'll go to our field reporter Julia, who is our field representative for this part of the stream. How are the winds, Julia? What is it being like wind-wise in Florida today?
Wind-wise feels like a typical Atlantic breeze, to be honest. Nothing really to be concerned about, but just like Falcon 9, you know, we see our off gases and things like that behave a little bit different depending on the wind. And the flag is not stiff, but it is definitely waving, so you're seeing a little bit more action with those gases out at the pad. Nothing to be concerned about, though.
Countdown clock continuing to count. That, of course, is that L- clock and not the T- clock. I do hope on launch day they'll put the T- clock on the press site, because right now the only way to actually see that T- clock is inside the press center at the KSC, and it's not exactly the most broadcastable location, I'll put it that way. Also, hopefully they turn the brightness up, because it is a little bit washed out, should I say, from the sun. We saw on the last attempt they were struggling with the clock a little bit. There were some pink squares popping up, and the numbers weren't exactly aligned, so hopefully they've worked on that a little bit. But yeah, it's a little bit dim.
You know, Ryan, you said that, and it darkened just a smidge right after you said that. But I even struggled to see it in person. Yeah, it's a thing. Maybe we need just a few more clouds. Not really, but that would help your situation.
Yeah. Although I appreciate the sun for seeing the rockets, so you know. You can only have one or the other.
Definitely can't have it all.
No. A bit more support that we've been getting over the last few minutes. We have Captain Q becoming a Red Team member. Thank you very much for that. And we have Drunar, who has done a 5 Canadian super chat. Thank you very much for your support, Drunar. Great to see you in chat as always. They're saying, if I recall correctly, there was promises of moon bases and a permanent human presence during Apollo. What the chance of sustainability dies after someone, quote-unquote, wins again? That's a great question, because Apollo, was meant to not wrap up. It was meant to continue, and then the political will to continue kind of fizzled out. So, I don't know. I'll toss this to whoever wants to take it, but what do we think about the same thing happening again with Artemis once the political will dies out?
I think we're going.
That was my point.
Bases?
No, it's not going to happen this time round. I just think last time it was all federal based. I think now we've got so many commercial companies that have been built up and this whole new economy that's growing. I think the chances of it going away just because of political will are slim at this point. Sorry, I didn't mean to talk over you, Alex.
No, I just did that sort of like barging in and saying, that's what I said. That was my point. Right? Like, yeah, if we once again trade off sustainability with rushing and trying to get first than somebody else, it's like I still think that the rush or the race or things like that should be sort of like a motivation kind of thing, right? Something to keep people motivated and be willing to work. But the long run, the long expiration, the that much far future thinking should be primary, in my opinion. Being able to have a sustainability, a long range sort of goal much further down the line than say, oh, let's land on the moon. It's like, yeah, what are you gonna do, right? That's what happened with Apollo, right? Where it was like, yeah, we landed. Now, what do? We beat the Soviets already. They started winding down the program even before Apollo 11 happened. Like the funding started to go down in '68, and the production stopped essentially within the year after that. While Apollo 11 was still happening, like we're talking about this stuff of like motivation sort of went away. But it happened even before the landing itself happened, and so I feel like we shouldn't trap ourselves in that sort of situation, and by ourselves I mean the world. I'm saying this. I'm a European. I know there's still a chunk of that rocket there that it's ours, but still I do believe as a species we should probably think more about long term than short-term goals. And you can see that across the board with other industries as well.
Absolutely,
we'll probably be going too far off the rails here, but it's happening, or it's happened before as well, where other industries, they were focusing more on the short-term goals and the short-term winnings, and it's like, yeah, and now you destroyed a bunch of the future stuff for future generations. Good luck. So I don't know.
Just taking a look at those fueling numbers again, we can see the core stage remains at 100% on both tanks. The oxygen is climbing through 31% now on the upper stage, but the hydrogen on the upper stage is at 87%.
Just dropped.
86%. And 10 minutes ago, it was at 88%. So it has dropped by a couple of percentages at that point. So that's very interesting to see. Hopefully the hydrogen problems on the core stage haven't been traded over to the upper stage, which would be annoying. But the upper stage went pretty well last time around. So, yeah.
Let's not jinx it, shall we?
Let's not jinx it, but it's definitely something to keep an eye on. And it's very interesting. Hopefully it's a temporary pause and we get an update from NASA soon. The last update on their blog at least came at 13:23 Eastern, which was just 17 minutes ago at this point, coming up to 20 minutes ago. So it'll be interesting to see if we get an update at some point. Let's see what this ticker says when it appears again. Anytime, NASA. Where did it go?
It's almost like they're watching us and then they take it away.
Okay, so that update is still from 12:57 Eastern, so a little bit older than the blog. Talking about the upper stage fast fill underway for the oxygen.
Well, I was gonna say, the ICPS connections are a carryover from the Delta for heavy upper stage. I don't know if we're gonna see, was it 917, the one that looks at the ICPS connections. But if you take a look at that umbilical connection, it is basically a copy of what you will see on the connections for the upper stage of the Delta for heavy, because it's the same one basically. So it's got heritage to it. If there's any issue, that would be weird. That's sort of the point that I'm trying to make here. That it's not like the core stage umbilicals, right? Those are brand new. It's got nothing to do with the shuttle, for example. I know a lot of people saying, well, the external tank, blah blah blah. The external tank and the core stage of the SLS rocket are nothing like it. First of all, the SLS has an engine section. The external tank doesn't, or didn't, I guess. And the connections and the ways that they get fueled and everything, it's a lot different. So the design is quite different. But for the upper stage, it's the same. you see a side by side, and it's pretty much the same umbilical system.
We have a great question here from James about the solid rocket boosters. Of course, on the space shuttle program, those were recovered, and these SRBs, in fact, are built out of hardware which was recovered from space shuttle missions. Every single casing on of those twin solid rocket boosters have flown before on a previous shuttle mission. Pretty much all components, apart from, I believe, 2 stiffeners, which are brand new. So, for anyone who wants to take it, why are they not reusing the boosters anymore? Why are they being thrown away on SLS?
Well,
I'm gonna
I
get
guess I
Alex to
can.
take that one. I'll go, Julia.
Well, I'm going to let Alex take it after me, but as someone who did not get to see a shuttle launch, the fact that these are from the shuttle era and were used during those flights does make me happy. Now, as somebody who has a foundation in chasing ships that carry rocket components, I'm very disheartened that we are not going to recover them, because I would have loved to see that process. And we do have ships available. Those were very basic ships back in the shuttle era that went out and recovered those. We have the ability to do that. But Alex, why don't you go into why we are not doing that?
I think it was Alice, the other one, trying to talk.
No, Alex. I think you're probably a really good person to answer that. I think it's to do with money, but I'm sure you're far more in depth than I am when it comes to things like that.
So it's in part money, in part the expected cadence, in part also the how hard it is to recover these. So as you probably notice, if you take a side by side of those SRBs with the ones on the shuttle, there's an extra segment. They are slightly longer, and that means they are also heavier. And they try to recover, for example, the RS-1X first stage. That was technically not 5 segments, because it was sort of like a mock-up of 5 segments. But they essentially had issues with that one, recovering that one. It actually got damaged during landing, and one of the main reasons. So again, there's like a bunch of reasons, right? But one of them was also that it was harder to recover these because they were longer, bigger, and heavier, and that meant probably like bigger parachutes and things like that. So we'll have taken more effort to do that, and also think about recovery operations out there. But also, the cadence of SLS is not huge, right? It doesn't launch that often to need recovery. Like in the time that it takes them to launch another SLS, they can produce the boosters right away. And that was another problem of the shuttle, where reusing the boosters was actually more expensive than making new ones. However, and here I'm gonna turn that argument back on its head. I think that's the expression, where it's like, if you actually reuse it, even if it costs more, Now you only need to clean it up and actually fill it up. It's a very complex process, but it actually takes less time to do that complex process than creating a new SRB from scratch. And that was sort of the main reason why the shuttle was able to launch that often. Apart from the fact that the external tanks, they were built quite fast compared to the core stage here. But imagine if, in the case of the shuttle, every single flight, they had to throw away the shuttle, and I don't know, the astronauts will land on parachute or something like that. Or there will be like a separate jettisonable capsule or something like that, and that's what lands, and the rest of the thing gets thrown away. The reason why they were able to launch that often, 4 or 5 times a year, was because they were reusing hardware, even though it cost more than creating than making it from scratch. But because it took less time to reuse it than creating them from scratch, they were able to fly more often. And I think that's one of the missing points here of SLS, where it's like, if you were able to reuse those components, you could probably launch more often, and you could probably make up some of the money that they're actually dumping into this program.
All very valid points there. It looks like we're getting... Yeah, absolutely. I was just going to say it costs more. It costs more is generally what it all comes down to when it comes to federal contracts. It is what it is. And I hope that like you say, that they'll think about reusability moving forward. At least they are reusing some of those components. It looks like we're getting an update now from what we're seeing with all the fuels, which looks good. We're back to 87%. It's been hovering around 86 to 88% for the last couple of minutes.
Oh, I had a revelation now that you said that, Alice, because I forgot. So in the timeline for loading both tanks on the ICPS, there's a step where they do what it's called a vent and relief test. And I wonder, whenever they go through that point in the count and they do that test, whether they have to stop the flow, do that test, and then resume. And maybe that's what happened here, where now we're going back to 87% and going up. Maybe they stopped, like maybe that's what we were seeing before, where they stopped, did that test, and then continued. It's a normal part of the countdown for people that might not be aware and watching right now. But maybe the procedure involves stopping hydrogen load for a little bit, do the test, and then continue. I wonder if that's the case, because if so, it would explain why we saw that number stop and then go down by a few percentage points. And now it's going up. It just dawned on me as you were saying that. I was like, duh, maybe it's this.
Well, let's hope you're right. Go on, Ryan.
This is why we have Alex on stream, because he's really good at figuring this stuff out.
I did not connect the dots. I'm sorry. I just realized that now. Could have done that earlier, to be honest.
Anyways, we are now L-6 hours and 40 minutes, and in the countdown, that is scheduled to be the core stage LOX topping, but that's already underway. So at least on the core stage, things have gone so well. NASA is ahead of schedule. Meanwhile, on the ICPS, they're kind of on schedule / catching up. It's quite difficult to tell at some points. But things could definitely be going worse. I don't want them to go worse.
No, we are in that.
They could be going worse.
I was going to say, we're in that area now where they're supposed to be the Orion communication systems activated, correct? Which is where they had a few issues, I believe, in the first wet dress rehearsal.
Yeah, that's a radio frequency communication to mission control, and that's scheduled to happen around this point. So, again, hopefully we'll get an update from NASA. The last update we got was about half an hour ago. But then I wouldn't be surprised if NASA's public affairs people might be slightly distracted for the next hour or so.
I wonder why.
As we have this upcoming Starliner conference, which we are going to be very interested in. We'll be taking that live when that starts. So some mid-test entertainment for you all. And for us too.
For those who've just tuned in, that is nothing to do actually with the current wet dress rehearsal. It is to do with the Starliner results of their report that's supposed to be coming out, we are hearing very bad rumors that they might be putting this as a Type A mishap, which is pretty bad. It's literally on the same level as the 2 Challenger and Columbia disasters that happened under the shuttle era. So not a good sign for Boeing if this is what we hear at the top of the hour.
Indeed, but again, we will wait and see what NASA Administrator Jared Isaacman and Associate Administrator Amit Kshatriya have to say on the matter. With this out of character, very abruptly called press conference starting in 8 minutes' time. Wonderful views of the venting on top of the vehicle here. I do have to say, thank you, NASA. Oh, we've got an update. 13:50 Eastern Time, NASA teams have completed the fast fill of the upper stage liquid hydrogen tank on the SLS rocket. Liquid oxygen fast fill continues on the upper stage. On the rocket's core stage, both the liquid oxygen and liquid hydrogen tanks are in replenish mode. Replenish keeps the tanks at flight-ready levels by replacing any liquid hydrogen lost to boil off. Wonderful.
Who knew we'd be so excited about fuel?
It's the fact
if
that
you
we
work
got...
at a gas station.
It's the fact that, you know, we were so hopeful and we were so optimistic at the start of Wet Dress Rehearsal 1, and then our hearts sank as they had those hydrogen leaks, and we're just like, oh, not again. And they went back, they did some work, and it seems to have worked. I mean, they fully loaded the core stage hydrogen tank on the first attempt.
It's definitely
seems like a pretty good, yeah, seems like a good sign to me. Anyways, very briefly, I think we need to do some support because these streams would not be possible without your guys' support. First of all, to everybody just tuning in and watching right now, thank you for tuning in and watching, because if you weren't here, we would be talking to ourselves, and that would be slightly awkward. But especially thank you to those who have financially contributed to the channel. It is so appreciated from each and every one of us. Jake Whiteley with a $10 super, and they're asking, if you were clean sheeting SLS, same goals but no need to use shuttle parts, what would you design? I'm not an engineer, but I think Starship? Maybe something that's fully reusable and cheap to operate, maybe?
It also depends when. When are you designing this rocket? Is it in a position where you are in like the 80s, 90s, the 2000s when Constellation began, and you're told, you know, it's okay if you don't use shuttle parts?
I mean, technically, parts of this design have existed since the 1990s, right? If we're not I mean, obviously, shuttle has existed since the 70s and before that. But like, even like the National Launch System, this kind of configuration of rocket has been an idea for over 30 years at this point.
Yeah, but it says no need to use shuttle parts. So like, you don't need to use the solid rocket boosters. You don't need to use the RS-25 if you don't want to. Just use something else. And it's the 80s. And it's like, okay, I'll look across the board. Oof. Like, if you look around, it's like you have Titan, and like, unless you cluster a lot of engines. First of all, Titan was hypergolic. Yeah.
Spicy.
Yeah, probably not that. Delta was around, but Delta 2, the RS-27, was it? The engine? I don't remember exactly. That was Carolox. I think it was like 100 tons of thrust. You will have to do like clusters of these, like maybe 12, 13 of these to make like a first stage or second stage. There were no other than the RL-10 engine. There were no good upper stage Hydrolox engines either. Depending, like, this is why I'm asking, when are you referring to this, right? Because depending on which decade, you have different technologies to use. Now, if you go to the 2000s, you start having RS-68, you have other options like the Merlin engine at the time was starting to come up as well. You start having more options, right? And of course, as you said right now, Ryan, there's Starship, New Glenn, etc., which, yeah.
Yeah.
And if you were starting from scratch now, it will take you another decade before we get to this point. So It's not such a bad thing that this has been planned and worked on for so long. We are at least in positive steps forward with this program.
I still remember.
Oh, we're zooming in again.
Woo!
We're zooming in again. Please don't cut away, NASA. Please don't cut away. What are we looking at? Oh, are we? No!
No way. They were looking at the liquid oxygen transfer line, I guess.
Looked like it, didn't it?
Why do they keep cutting away when they look at the interesting things?
Don't want to show what it is they're looking at too closely, just in case it gives away the secret source, I guess.
I mean, yeah, because we all know that building ICBMs with liquid hydrogen that requires being fueled 10 hours before launch is a great idea. Anyways, Aid Astra with a $5 super saying, with the idea of sustainable architecture, I feel like propulsion methods such as NEP and NTP are going to become more necessary. What do you all think? Alex, let's start with you. What do you think about nuclear electric and nuclear thermal propulsion?
I'm more of a nuclear electric than nuclear thermal, mainly because it's much more efficient, but also because nuclear thermal, you need big tanks to carry over. Like it's usually hydrogen that you use for. You can use other propellants and whatnot for NTP, but you have to carry big tanks around. Again, usually it's liquid hydrogen that you carry around. I don't know. I think electric is probably better in that case. But yeah, we're gonna need that sort of thing. It seems like there's movement at the very least to promote this in the future. So let's just see that. Let's do it. Come on. let's everybody go out there and be like, come on, do it. No, I'm just joking, but yeah, I'm excited to see that.
Nuclear propulsion is something Jared Isaacman, NASA administrator, is very interested in. So, yeah, hopefully some nuclear development pushes ahead, because it's something which has never really been done at scale.
No, and there's a lot of policy discussion around it at the moment, because that's the other area. People don't realise that there is just nothing in place to be able to allow for that right now. So there is a lot of very basic entry-level type discussions that need to be had before we get to the point of us actually seeing it in action.
Okay, as we approach this Starliner conference, I'll very quickly go and thank Patrick Bob, who gifted 50 Red Team memberships. Oh my goodness, if you received one of those 50 memberships from Patrick, make sure you thank them in chat, because that is 50 people. That's a lot of people now with access to the membership area for free for a month. So seriously, Patrick, that's huge. Thank you so much for that. And Drunar again in chat as we introduce the Starliner conference there in the bottom right. Drunar with a $5 Canadian to help fund putting shuttle wings on the SLS core stage for reusability. I mean, if you want to send that money to NASA, go right ahead. We can't do that with it. But thank you nonetheless, Drunar. Maybe the wings would need to be a little bit bigger, and maybe we'd need to figure out somewhere in Hawaii to land the core stage, considering it re-enters over the Pacific. But good thinking. Okay, we are now at the top of the hour here, which is when this press conference was scheduled to begin on Boeing's Starliner. So I will continue talking until it starts.
I don't know if you've seen that there's a message that's gone out from Administrator Jared Isaacman, Ryan, that is definitely worth us discussing before we get into it as we're waiting.
Yeah, I did see that. I'm not sure. It's quite a long letter, and I haven't had the chance to read through it all
It
until
is.
this conference starts.
Did you do it?
What do you have to say, Alex?
I'm already reading it.
Okay. I think we, for the time being, I will put a pin in that, not literally, because I don't want to break my monitor, but I will leave that tab open, and I think we should be starting right now.
Leaders will discuss the findings of investigations into the 2024 crewed test flight of Boeing Starliner to the International Space Station. Administrator Jared Isaacman will provide some opening remarks and answer questions alongside Associate Administrator Amit Kshatriya, who will give closing remarks. If you have a question, please join the queue by pressing *1. We will attempt to get through as many questions as possible, Shortly, NASA will send a news release that links to the report, redacted to the least extent possible for your reference. With that, the Administrator.
Thank you, Bethany. For those that are joining us today, I would like to read a letter that I sent to the NASA workforce in just the last few minutes. So within the next week, Congress will be briefed by the Aerospace Safety Advisory Panel, and NASA's independent investigative report on the Starliner crewed flight test will be released publicly. So many of you know this program intimately, and some of you lived every development in real time. We returned the crew safely, but the path we took did not reflect NASA at our best. There is no expectation of perfection in missions as challenging as those that we are entrusted to undertake. Even with our best efforts and programs like CCP that have seen great success, mistakes will occur. What defines us is whether we learn from them, improve because of them, and strengthen confidence across this workforce and the nation that we serve. This requires transparency and accountability, neither of which can be selectively applied. In this letter, I will summarize the timeline, the organizational root cause, and the actions we are taking to restore trust and move forward. Let me begin with the most important point. Starliner has design and engineering deficiencies that must be corrected, but the most troubling failure revealed by this investigation is not hardware. It's decision-making and leadership that if left unchecked, could create a culture incompatible with human spaceflight. To give you a little program history, Starliner was conceived under the Commercial Crew Program in 2010 with the intent to establish dissimilar crew access to low Earth orbit. After the retirement of the space shuttle, it became a national imperative to never again accept a gap in American human spaceflight capability. Now, the first test, Orbital Flight Test 1 of Starliner, was in December of 2019. A mission elapsed timing error prevented the guidance software from calculating orbital insertion burn timing, which triggered excessive thruster firings, incorrect orbital insertion, major propellant use, and 10 thrusters that were declared failed off. This mission was declared a high visibility close call. Orbital Flight Test 2, or OFT2, was launched in August of 2021. During the OFT2 launch countdown cycle test of the service prop module system, so this actually didn't launch, to be clear, but during OFT launch countdown cycle test of the service module prop system manifold isolation valves, 13 of the 24 oxidizer valves failed to cycle open. So they were stuck in the closed position, and that resulted actually in a launch scrub. So the spacecraft and the booster itself were rolled back, and the service module was removed, and it was replaced for launch many months later, which actually led to the Orbital Flight Test 2, OFT2, which did launch in May of 2022. Now, this mission proceeded mostly nominally compared to certainly the other mission. However, 3 aft service module RCS thrusters were declared failed off during the flight. Now, this led up to the actual crewed flight. So preparation for the crewed flight, OFT, and OFT2 investigations did not drive to or take sufficient action on the actual root cause of the anomalies that we observed. The investigations often stopped short of the proximate or the direct cause, treated it with a fix, or accepted the issue as an unexplained anomaly. In some cases, the proximate cause diagnosis itself was incorrect due to insufficient rigor in following the data to its logical conclusion. Now, we still stepped into crewed flight test, so CFT, which was launched in June of 2024. Now, after a lot of delays and an unexpected helium leak, NASA and Boeing launched astronauts Butch Wilmore and Sonny Williams aboard Starliner. During the rendezvous and proximity operations, propulsion anomalies cascaded into multiple thruster failures and a temporary loss of 6 degrees of freedom control. Now, the controllers and the crew performed with extraordinary professionalism. Flight rules were appropriately challenged, control was recovered, and docking was achieved. It is worth restating what should be obvious. At that moment, had different decisions been made, had thrusters not been recovered, or had docking been unsuccessful, the outcome of this mission could have been very, very different. The astronauts did remain safely aboard the International Space Station while they were advocating for data, for more testing, and for leadership engagement necessary to complete their mission safely. On the ground, joint Boeing and NASA teams conducted tests, reviewed data, and evaluated next steps. In September 2024, Starliner undocked autonomously. It did experience an unexpected crew module propulsion failure and landed successfully, though zero fault tolerant in the crew module thrusters throughout reentry. Butch and Sonny subsequently returned safely to Earth aboard SpaceX Crew 9 in March of 2025. Now, talking about the investigation, mistakes incurred from program's inception and continued throughout execution, including contractual management, oversight posture, technical rigor, and leadership decision-making. Boeing built the spacecraft, and from the onset, NASA approved variances, and we agreed to fly it. As development progressed, design compromises and inadequate hardware qualification extended beyond NASA's complete understanding. Now, variances exist across all major aerospace programs and by themselves are not unusual. The engineering reality, however, is that Starliner, with its qualification deficiencies, is less reliable for crew survival than other crewed vehicles, and that was as noted by the report. But at NASA, we managed the contract. We accepted the vehicle, we launched the crew to space, we made decisions from docking through post-mission actions. A considerable portion of the responsibility and accountability rests here. Now, talking about root causes, we have identified organizational root causes. The technical investigations to identify the proximate or direct causes for the service module and crew module thruster anomalies remain ongoing. So I think acknowledging that present-day reality is essential to mission success. So to the root causes first. NASA's limited touch acquisition and management posture left the agency without the systems knowledge and development insight required to confidently certify a human-rated spacecraft, and insight versus oversight was not applied consistently. Second, Boeing's propulsion system design and certification approach allowed hardware to operate outside qualification limits, which is incompatible with crew safety margins. Third, NASA's programmatic desire to maintain two dissimilar crew transportation systems influenced technical and operational risk discussions. Now, it is through that lens that we examine leadership decision-making through the various phases of the mission. Pre-launch. More than 30 scheduled CFT launch attempts created cumulative schedule pressure and decision fatigue. Prior OFT thruster risk was never fully understood, corrective actions from OFT-1 were incomplete, and flight rationale was therefore inadequate. Witness statements routinely reflected a belief that management within the commercial crew program could only succeed if Starliner launched. Now, on orbit, disagreements over crew return options deteriorated into unprofessional conduct while the crew remained on orbit. Witness statements described an environment where advocacy tied to the Starliner program viability persisted alongside insufficient senior NASA leadership engagement to refocus teams on safety and mission outcomes. Now, post-mission, despite the loss of 6 degrees of freedom control and cost thresholds exceeding a Type A mishap by a factor of over 100, a mishap was not declared. Concern for the Starliner program's reputation influenced that decision. Initially, our commercial crew program investigated itself. Ultimately, these decisions were inconsistent with NASA's safety culture, and a subsequent independent investigation was commissioned, and the record is now being corrected. Today, we formally designate this event a Type A mishap to ensure lessons are fully captured for future missions. Programmatic advocacy exceeded reasonable bounds and placed the mission, the crew, and America's space program at risk in ways that were not fully understood at the time decisions were being contemplated. This created a culture of mistrust that can never happen again, and there will be leadership accountability. Now, our path forward, NASA will continue to work with Boeing, as we do all of our partners that are undertaking test flights. Sustained crew and cargo access to low Earth orbit will remain essential, and America benefits from competition and redundancy. But to be clear, NASA will not fly another crew on Starliner until technical causes are understood and corrected, the propulsion system is fully qualified, and appropriate investigation recommendations are implemented. A little bit to transparency. Transparency is not a weakness, it is a strength. We will release the investigation in full, redacted only where legally required or as directed by our commercial partner. Pretending unpleasant situations did not occur teaches the wrong lessons. Failure to learn invites failure again and suggests that in human spaceflight, failure is an option. It is not. America entrusts NASA with the hardest endeavors ever attempted. The world looks to us for the discoveries, achievements, and leadership only this agency can deliver, and that requires putting the mission and the crew first. We will achieve success through extreme ownership, immense competence, and decisive action. Thank you.
And with that, we will open the floor to questions for reporters on the phone, and we will start with Marcia Dunn from the AP.
Yes, hello, Mr. Isaacman. Given that the space station only has 4 more years as of right now before it's decommissioned, why continue with Starliner at this point? Surely this investigation is going to be continuing on for a while longer. Why bother to keep Boeing on board at this point? Thanks.
So at NASA, we see near endless demand for crew and cargo access to low Earth orbit well beyond the life of the International Space Station. One of our top priorities here, in line with President Trump's national space policy, is to ignite the orbital economy, which hopefully necessitates numerous commercial space stations in low Earth orbit, in which case, as I mentioned before, America benefits by having multiple pathways to take our crew and cargo to orbit. We certainly hope, and we intend to fully work with Boeing in the months ahead to get to technical cause of the thruster issues, to implement the recommendations from the independent investigation, and return to crewed flight. Thanks.
And next, we will go over to Jeff Faust with Space News.
Good afternoon. Before this announcement, NASA had said that they were working towards a Starliner 1 cargo-only mission as soon as April, and if that was successful, that could be followed up by a crewed mission perhaps towards the end of the year. Does that schedule still hold based on what we have heard today about the various steps you believe need to be taken before Starliner is ready to fly crew, or will that schedule be altered in some way?
Well, I think a no earlier than date is just a no earlier than date. I mean, what we don't want to do is perpetuate past problems by establishing, endless target launch dates that we were unable to meet. I think right now, our focus here at NASA is working alongside Boeing, again, to understand the technical challenges that have caused these service module and crew module thruster issues, to remediate them, make sure we have a full understanding of the risk associated with this vehicle, implement the report, the recommendations from the report, and get back to flight. Now, if that happens to line up in April, then so be it. And if we can follow that on with crewed missions, that's fantastic as well. As I mentioned, I think there's going to be endless demand for crew and cargo access to low Earth orbit, well beyond the design life of the International Space Station. But we are not going to fly again, crew or uncrewed, until it's ready.
And next, we will go to Eric Berger with Ars Technica.
Hi, thanks very much for doing this. A couple questions. First of all, Jared, how widespread were the leadership failures in this case on NASA's part? And what does there will be leadership accountability actually mean? Are we talking about program changes at commercial crew, elsewhere at HEO, or sort of what could happen?
Well, in terms of what were the leadership failures, to provide more specificity, leading up to launch, while the astronauts were on space station and we were evaluating what actually transpired and what are our options to bring these astronauts home, and then after they came home, there was a continuous, the overarching programmatic objective of dissimilar crewed access was continued to be introduced into the conversation when mission and crew safety should have come first. Now, that resulted for the various NASA workforce and contractors that were involved in this process, a breakdown in culture, created trust issues, and where leadership failed was to recognize that this was taking place and to intervene and course correct. There was always an option. Everybody, even if you don't follow spaceflight closely, knew that there was always an option that could have been sent up, was inevitably going to be sent up, that could bring these astronauts home. Pretending that that did not exist, and focusing exclusively on a single pathway that was and now quite clearly a mishap, created a cultural issue that leadership should have been able to step in and course correct. What levels of the organization inside NASA did that exist at? multiple levels, including, I would say, right up to the administrator of NASA. I can't imagine a situation like that why there would not have been some direct involvement to bring people back to the mission and the crew and figure out the correct pathway forward, which we ultimately did arrive at. But as I mentioned in my letter and my remarks, how we got there was not the correct way.
And next, we will go to Will Robinson Smith with Spaceflight Now.
Yes, hi. Thank you for taking the time to speak with us this afternoon. Given, obviously, that these are two very different programs, but that Boeing is the contractor behind both Starliner and the Space Launch System rocket, as we're watching the tanking tests underway now, are there any possible overlap between leadership concerns from how Starliner was handled to how the leadership where SLS is concerned has been running and is moving forward at this point in time? Thank you.
Thanks for the question. It's a good one, but what I think what the administrator said is important is the alignment between the development methodology and the test and qualification methodology. So, in the environment we're in commercial crew, in the fixed price environment where you're providing services, you have limited insight and oversight. That works depending on the hardware richness of the program and the test approach. It doesn't work if you classically develop quality built in. So that's the real difference, is that those things have to be aligned. It's not about one versus the other. It's about making sure that you're testing and qualifying according to your development approach. And so with on the core stage, even on space station, the development approach is similar in terms of how it works with the company, but at the same time, the test, the qualification, the fault tolerance, how that's levied, and how the certification is done does match up. And so in that particular case, we have less concerns because we're basically testing like we should according to the way we're building the hardware.
And we will move to Bill Harwood with CBS News.
Thank you very much. I think this is for the administrator. Given the amount of work you're talking about will be needed to hammer all of this out and get these changes made, obviously that's going to take some time. I know you guys aren't talking dates about when a crew might fly on this vehicle, but it seems like with the deadline coming for station retirement, there has to be some point where you either have to get this going or it's not worth continuing. Is there such a point, or is the plan that you're going to press ahead with Starliner regardless of how long this takes and get it flying with a crew at some point? Thanks.
And thank you for the question. I think it's important to point out we are not starting from zero here. We are sharing the results of multiple actual investigations will essentially be coming to light in the literally the hours and days ahead. But work has been taking place continuously on this program. Obviously, at the time the astronauts were on orbit, we knew we had a problem that required significant attention, so much so that, again, we have declared it a Type A mishap. Boeing and NASA has been working to try and understand these technical challenges throughout that entire time period. Now, I did want to make sure I drew attention. We have not arrived at true technical root cause as it relates to the SM and the CM thruster-related issues in this. It doesn't mean we may not be close to it. We are committed to helping Boeing work through this problem, to remediate the technical challenges, again, fully understand the risk associated with this vehicle, try and minimize it to the greatest extent possible, and if we can implement a lot of the report recommendations, then we will fly again. And I think that's important even outside the context of the International Space Station. America is not giving up its presence in low Earth orbit. We have an unbelievable internationally assembled orbiting laboratory right now that's enabled continuous heartbeat in space for more than a quarter of a century. That will not end with the International Space Station. There will be other space stations, I guarantee it, and they are going to require crew and cargo access to and from low Earth orbit. And I think the nation and the world benefits when you have multiple providers that are capable of doing that. Thank you.
And we will now move to Joey Roulette with Reuters.
Thanks. Question for Jared. As a result of this report and the findings in your letter, are there any penalties or punitive measures being taken on Boeing or against any NASA employees? And have you discussed these findings with Kelly Ortberg or any other Boeing executives? and what do they say? Thanks.
Thank you. Joey, I think kind of part of your transmission there was a little bit garbled, but if I think I've got it. If I don't, please correct me. At least throughout my evaluation of this investigation, which I began to get briefed on and started to dive into the reports and the witness statements almost immediately after I was confirmed in this role, I followed that up with a number of interviews that I wanted to have directly with those that were involved in either the incident itself, or the kind of the post-mission investigation, to kind of hear it firsthand, especially since time had gone by, and I wanted to make sure what I was reading actually was still as it as the parties that were involved believed it to be the case today, and. And I would also say that so in that respect, I tried to have as many conversations, get as educated as I could on the situation as possible while the multiple investigations were underway, including speaking multiple times with the ASAP committee. I would also say that that I did have conversations with Boeing on this. I think they put out a public statement. I completely concur with it. Just as we are taking ownership of our shortcomings, which I think is absolutely imperative for NASA to be able to undertake our world-changing mission in air and space, they are doing the same. And I believe, and I've spoken to a number of our team members here at NASA that work closely with Boeing on Starliner, that there has been, some recognizable changes in their approach to the vehicle, and a very concerted effort to adjust the culture inside that organization. So clearly, both NASA and Boeing had work to do, and we are doing it right now.
And now we will go to Kenneth Chang with the New York Times.
Hi, thank you. This is for the administrator. So you were saying that this result of an imbalance between insight versus oversight over Boeing. I was wondering, was this also this imbalance SpaceX? SpaceX just happened to do a better job. And also, are there lessons here that you're going to apply to HLS? Thank you.
He said it was to you. I'm sorry.
I don't know. I'm not going to take it. Yeah, again, the point here is that we have to have a kind of risk-based approach to how we're doing insight and oversight. You can't apply the same method to two different development processes, and so the one approach allows for kind of total openness and into the systems. The one relies a little bit on kind of fixed deliverables and how that works, and you can't just kind of spread that out. It has to be tailored according to the risk in the systems, the propulsion systems, life support systems, et cetera, need to have more than kind of a spot level of insight, and that's what we're trying to right size. I think we've learned through every iteration of the commercial services approach, and a lot of our contracting approaches to make sure that we are tailoring those things going forward in the existing developments we have that use the same approach. But again, the most important point here is that it requires that intensive application of that per system, per company, per what they do for their development, and it can't just be assumed that they're symmetrical. And I think that's really the key here in terms of how we manage these programs going forward.
And now we'll head to Jackie Waddles with CNN.
Hi, folks. Thanks for doing this. Apologies, I didn't quite hear that last question. I hope I'm not repeating anyone, but wanted to kind of piggyback off of Eric's and Will's questions. If this is more of a systemic issue within commercial crew, does this raise any concerns that oversight is also inadequate for SpaceX? And then just since Artemis II is on the launch pad, question for Administrator Isaacman, does it raise any concerns for you that the safety measures in place are insufficient, not just for commercial crew, but maybe more broadly within the space agency? And if your answer is no, could you detail why you're confident that these issues don't carry over? Thanks.
Read the first part. I'm sorry.
I didn't hear the first part.
Let me take the second part of the question, which is just how do I view Artemis II on the pad right now relative to this situation, and if I'm not concerned, why? And then if you wouldn't mind just repeating the first part of your question when it's done. As Amit mentioned, these are two very different contracting approaches. SLS is very much conceived through a traditional procurement process. We have lots of prime contractors, lots of subcontractors. NASA owns a lot of the design and the assembly of the vehicle. I would also say, versus what was a Starliner which was designed to be procured essentially as a service in that. You can certainly see in the report that a lack of, or an inadequately applied insight and oversight into the original Starliner program is because we had very high confidence from the get-go in the manufacturer based on their past performance on other programs. And we, even after the OFT-1 and OFT-2, we still gave a lot of kind of benefit of the doubt there when we probably rightfully should have unpacked it a lot deeper, and maybe we would not have flown CFT-1 in hindsight on that. I think that's very different again from SLS. Leverages a lot of components that go back to the space shuttle program, procured and assembled in a more traditional way, and also with the mindset that this is now the most, important human spaceflight mission in more than a half century. There cannot be enough eyes on this program. I've dispatched, second and third and fourth sets of eyes during the Artemis II campaign. Amit has dispatched multiple sets of eyes on this. We have pre-FRRs down to the component level, the integrated level FRR. We are putting a lot of attention on this because this is a mission we do not want to get wrong. I will say, though, that part of the reason that we are having this discussion right now, leaning into transparency, and this is irrespective of the date that we're communicating it just so happened to be during wet dress, is to make sure we are sending the right message within the workforce of NASA that we have to make the right decisions in this circumstance. Leadership has to be appropriately applied because the situation we found ourselves in with Starliner, with CFT, could happen anywhere across the organization. And as I mentioned before, the approach we took is not compatible with human spaceflight, and we cannot allow it, or not permit it to continue. And if you wouldn't mind just asking the first part of your question again, and we'll see if Amit can answer it.
Sure. Sorry about that. Yeah, it was kind of baked in a little bit to the answer there, but I was curious, since it seemed to be an indication that there was more of a systemic problem within the commercial crew program specifically. I was wondering if there was if the scope of the investigation included looking into whether oversight of SpaceX is adequate. If there was concerns that there's carryover concerns between oversight of Starliner and oversight of Crew Dragon.
Yeah, let me just to jump in without picking on any one contract or the other. I spent the first 2 months on the job trying to visit every one of the centers and gather input from the workforce and almost every one of our partners beyond just human spaceflight, our robotic missions, aeronautics. I would tell you that almost every one of them included in their formal responses back to NASA that they would prefer less oversight, more insight, less requirements, right? So I don't think that ask is specific to any one contractor, but there are lessons to be learned here, which is, again, back to why you're transparent about this program. Certainly, taking that advice as it relates to Starliner did not lead to a good outcome. Right? This is part of why I put out my workforce directive to restore core competencies inside NASA, why we're bringing a lot of contractors back as civil servants, regaining some lost muscle memory on our engineering skills so that we can look at situations, again, regardless of contractor, and say, you know what, this is an area that is not necessarily critical to human life, and we can take more of an insight-based approach to this, or in fact, we can let the contractors tell us what is the best way to potentially achieve this outcome or solve this particular problem. And then there are other areas, regardless of the contractor and regardless of their past success, where we are going to want to have oversight, where our requirements are going to be very specific, because if we get it wrong, the outcome goes beyond that particular contractor, but has implications across America's space agency, and that's something that we can't ever allow to happen.
And this is just a reminder that if you have a question, to press *1 to enter the queue. Next, we will head to Richard Trepo with the Orlando Sentinel.
Hi, yes, thanks for taking my question. Now that you've reclassified Starliner on the same level as Challenger and Columbia, can you speak to the gravity of that and how you'll be discussing Starliner going forward? Would Challenger and Columbia be in the conversation as you discuss these things for either the administrator or on it? Thank you.
I think just to maybe give a little background on what a Type A mishap actually means, and then if we want to go a little bit deeper than that, I can pass it over to Amit. First of all, I mean, we had a WB-57 aircraft that had a gear up landing not that long ago. Right now, that is initially classified as a Type A mishap. So, I would not. I mean, it's defined as certainly it can have a human health consequence to it, but also simply over $2 million in damages. So this is just about doing the right thing. It's categorizing the mission appropriately. If a gear up landing of an aircraft is a Type A mishap and no one was hurt, and we could declare that, then we sure as heck should do that. When we had a very severe situation in space where we did lose for a period of time 6 DOF control over the vehicle, our astronauts spent an extensive amount of time on orbit, well in excess of the original mission design. And when we did ultimately bring them back home, we had to forego 2 astronaut spots that would otherwise have been conducting good science and research on the space station. That's a Type A mishap. So sure, you can point to some moments in our history where we made some terrible mistakes and there were really bad outcomes as a result of it. Those are Type A mishaps. We have had situations where a ground-based antenna was over-rotated and caused damage that approached a Type B mishap, for example. So it's not necessarily a question, again, of a human life. Anything to add, Amit?
Yeah, sure. Yeah, I think it's so. Just to be clear, and this is maybe a little pedantic, but if Challenger and Columbia vastly exceeded that threshold because of the loss of life, those were actually presidential commissions that were established to investigate those things at that level. That's not what we're suggesting here. The administrator is right that we do have procedural requirements, which, by the way, are informed by the lessons learned from those catastrophic events that lead to this mishap classification. That, strictly speaking, with respect to correcting the record, that's exactly what this means in terms of this classification. It also means that it would have invoked independent review. And we, because of the program in ISS as well as CCP, agreed to let that independent review occur. The process by which the review is conducted meets the standards according to what would have been invoked if it was a Type A mishap. And so we believe that the work has been done to identify that, the independent review, the witness statements, et cetera, the data collection that would have been done. This is simply about recognizing that we need to correct the mistake, and that according to what the administrator said, is exactly what this is.
And now we'll go to Andrea Leinfelder with the Houston Chronicle.
Hi, my question is a follow-up to that one. Is a Type A mishap literally then just something that's more than $2 million in damages? Can you clarify that? And also, when you start talking about management cultural concerns, I do think people start thinking of the shuttle. And so I'm curious if you saw any parallel to the shuttle disasters, and are there any cultural changes you're looking to make at NASA now? Thank you.
So, as I described before, Type A, Type B, Type C mishaps is relatively standardized across the government. So you hear it often referenced in Air Force or Navy-related matters when there's damages to aircraft and ships. So yes, there is a dollar threshold that's associated with it. It's depending on the service or the agency, it triggers various events, one of which in NASA would have been an independent review, which has already been conducted, and the findings of which being released today. But as Amit mentioned, this is about getting the record straight. And I do think that failure to acknowledge this as it was, which is a Type A mishap, and ensure that we are transparent and correct, management and leadership missteps that could lead to an unhealthy culture is absolutely warranted. Failing to do so invites repeats of previous catastrophic events, which again is never an acceptable outcome here at NASA.
Irene Klotz with Aviation Week.
Bethany, one clarification with the declaration of this now as a Type A mishap. Does that mean that the formal investigation board, you don't need to do one at this point? You're saying that that's already been completed, and the reclassification of the Starliner incident is it's retroactive in that sense. And Jared, has Boeing committed to you that they will stay in the Starliner program? Gotten any indications that they are finished with investing in this program? Thanks.
Yeah. So to answer the first part of the question, we are not conducting a new investigation. We did conduct an independent investigation, as would have been required had this been declared Type A mishap from the start. So in that respect, the work is done. The redacted reports are being made public. We're speaking to you all today. There is still ongoing work. As I mentioned before, like we have not arrived at the technical root cause of the SM and RCS thruster failures, and we are working alongside Boeing in order to solve that problem and implement the report recommendations I mentioned before so we can get back to flight. I'm not going to put words in Boeing's mouth. They released a statement that I think expressed the desire to continue to work with us, as they have done since CFT-1 returned from space, to solve the problem. And I think they acknowledge what I mentioned before, which is there is going to be extraordinary and continuous demand for crew and cargo access to low Earth orbit well after the design life of the International Space Station. And I think it serves the American people, certainly our international partners in the world, to have multiple providers capable of undertaking that important work. I fully anticipate Boeing will be there.
And now we'll head to Ryan Caton of NASASpaceflight.com.
Thank you very much for doing this, Ryan Caton, NSF. A couple questions. First of all, I was just wondering if there was a Boeing representative who was invited to attend today's conference. And second, I was wondering, considering both the recent WB-57 gear up landing and the Challenger and Columbia disasters are currently classified under the same type of mishap, if NASA's mishap definitions are sufficient for the modern day. Thank you.
So, as I mentioned, the mishap categorization is relatively, as I understand it, and I have some experience with it outside of NASA, is standardized across agencies and part of our Department of War services. So this would be the same if you were to reference ships that are damaged, aircraft-related incidents. The same type of standard is applied. Now, what it triggers can be very different. Here, Type A mishap for sure is going to get the attention of the administrator of NASA, and it's going to require an independent investigation. And that's how this should have always been done, and it's how we are characterizing it today. I don't think there is anything that is flawed about that process.
And now we will head to Ken Kramer, Space Up Close.
Thank you for doing this. Very informative. My question, for the administrator and Ahmed. I've been following this program from the beginning, and my impression has been that Boeing have just not taken a very aggressive approach, especially related to these service module and RCS thrusters. And that goes to the top of Boeing management. They're always hesitant to provide funding to move forward. So I wonder if you could talk about why they are so hesitant, and the fact that they still have to do tests. It seems to me this test should have been done already, and they should have been given top priority a long time ago. So I'd like to know why is there no sense of urgency from Boeing? Thank you.
Please.
I appreciate the question. Again, we have, as the administrator said, we discussed this this report with Boeing. We have partnership from Boeing management to discuss, the way forward. We're collaborating with their engineering team to do this work. In terms of, we're not going to speak for Boeing management. That's on them to speak for themselves. I think what the administrator is trying to communicate, and what I'm trying to communicate, is that we have to own our part of this. What we did, how we led through it, how we acquired the vehicle, how we decided it was qualified, how we behaved when we were operating it, and what we're going to do going forward. And that's the most important thing. It's difficult sometimes to look inward and do that work, but that's mandatory in this business when you're dealing with the rigors of human spaceflight.
And just a reminder, if you have any questions, press *1 to get in the queue. We will now head to space.com's Mike Wall.
Thank you for doing this. Yeah, just a quick question. Based on like what we've heard, there's standard definitions of what these different mishap categories represent. So I'm just curious, how did the original team kind of get away with not declaring this as a Type A mishap if it was clear it cost more than $2 million worth of damages, or with the delays and all of that? Like, what was the rationale at the time to actually not declare it in that category?
I am certainly not going to try and explain it, because we are here to acknowledge that that was a mistake. It should have been declared right from the get-go. I don't think this is ambiguous at all. There's a clear dollar threshold here, and the situation itself was, extraordinarily high visibility, right? This was a story that I think captured a lot of people's interest more than a year ago. So that was a mistake. And I think that that is why the independent report investigation, along with the ASAP committee, have arrived at a position that this should have been declared a mishap. And we fully, obviously, concur with it. So that's why we're righting the wrong here and trying to course correct. If you're asking, what were some of the, possibilities of why it was considered, I think we referenced it before, that throughout the development of this program is certainly leading up to flight on orbit as we evaluated options of how to bring the crew home, and then post-mission, when we decided what to do about it, the overarching programmatic objective of dissimilar crewed access to orbit was present in those discussions, where it probably, especially in certain cases, had no place being there when it directly tied to the mission and crew safety.
Now Anthony Leone with Spectrum News.
Hello, and thank you for taking our questions today. Mr. Isaacman, you explained what the Type A mishap is, but how much danger were Butch and Sonny in, particularly when they're having the thruster issues, and how much of what happened with Starliner impacted Butch and Sonny's decision to retire from NASA? Thank you.
I'm certainly not going to speculate on their decision to retire from NASA. They both had extraordinary careers. Outright unbelievable careers here at NASA, and grateful for all their years of service to science and discovery at NASA. How much danger they were in? Losing 6 off control is a huge deal. I actually want to give a lot of credit, and I mentioned it in my remarks earlier, to the flight controllers that made the decision to kind of challenge some of our flight rules and bring that crew to a safe haven, which is the International Space Station. Had that not taken place, had thrusters not been recovered, it could have very well been a different outcome. As I mentioned before, after we did undock Starliner, and it autonomously re-entered, it came home zero fault tolerant for another. That was a CM thruster failure that we were not anticipating at the time. So the spaceship was not healthy. And I think everybody absolutely, as I mentioned before, we got to the right place. How we got there was not correct, and that's why we are trying to set the record straight and classify this situation accordingly, so lessons are learned and not repeated. But we are grateful we have two astronauts here, and that we did properly investigate this, and that lessons will be appropriately learned across the agency, and there will be accountability.
Marcia Smith with Space Policy Online.
Thanks so much for taking my question. I think that's the question I still have in my mind, what you just said about there's going to be accountability. What exactly, succinctly, are you trying to change now? You're going to change some of the leadership. Are you going to try and change training or change the culture? Just, in just a couple of sentences, what precisely are you trying to change now?
I think first and foremost, we're trying to send a message about what is the right and wrong way to handle situations like this so that they do not reoccur. I think setting the record straight, classifying as a Type A mishap, ensures what happened here with this mission is appropriately recorded and can be referenced for future learning. This is how you course correct a culture. I do think that what we will have learned from this will inform how we handle future contractual procurements with our vendors. Space is extraordinarily hard right now. I mean, for sure, not taking anything away from SpaceX's success story with Crew Dragon. That was an evolution from Cargo Dragon to Crew Dragon. Lots of demand was able to be forecasted, and they delivered a service that has enabled us to send American astronauts to and from space now for more than 5 years. Our counterparts in Russia are still using Soyuz, which is essentially derived from more than a half-century-old spacecraft. What we're talking about is extremely hard. So I think by properly characterizing this, ensuring that the information is made public, we can look at it when we do subsequent procurements. Are there areas where we should stand back a little bit more and let industry and all their knowledge and experience inform the process? If it's not absolutely critical to safety of flight, for sure, we should welcome their ideas on how to arrive at the right outcome. And then there's areas where it is absolutely imperative, based on all of our years learning and leading in this challenging field of human exploration, that we should be establishing the appropriate requirements and go beyond insight, but proper oversight in that matter. And yes, I do think that as we work through this process, we will look at where there were leadership shortcomings, where people should have stepped in and tried to course correct when it was clear the conversation that was being had was not appropriate for the mission and the crew at hand, and we'll make adjustments. I do want to point out that I think that goes right up the chain of command. I don't know what, even at the most senior levels of the agency, you'd be waiting for to step into than when you had such a high visibility situation on orbit where astronauts no longer, at least at that moment, had a good, safe, certified way to come home. There were a lot of leadership failures in that regard.
Brandon Vigliarolo from The Register was unable to get on the call but sent in his question. He asked, does the blame placed on the CCP for prioritizing contractor results over technical rigor suggest CCP isn't a sustainable or reliable path forward for American spaceflight? Is letting private companies lead space development creating unnecessary risk for astronauts and the future of spaceflight? And I will just note that this is the last question.
Yeah, I mean, first of all, I want to pull this way up from the CCP level. CCP is a very successful program, extremely successful program, and helped return American spaceflight capability in the United States after more than a decade when the space shuttle was retired. I mean, a very, what I would consider dark day, or dark decade at NASA is when our dependency went overseas to send our astronauts to and from space, and our CCP program was able to bring that back. And in terms of leveraging private industry and expertise to enable America's space program, we've been doing that since the get-go. I mean, I can't emphasize that enough. People seem to think that's somewhat of a new development. It's not. We didn't get to the moon without the contributions of America's greatest aerospace industries. Boeing and McDonnell Douglas were, it's just some examples of it. And many of those names still exist today, and we also have new ones. And we have new approaches to contracting. Some things we procure, some we develop ourselves, and some we purchase as a service. I think, properly categorizing this situation, ensuring the information is made available, that lessons are learned, we can use that to make sure our culture is correct, our internal expertise is correct, that we restore core competency in the areas that are essential for our mission success, for achieving our national space policy, to make sure that when we design these procurements, we are taking the right approach from a requirements and an insight and oversight perspective. So again, relying on industry to get us there is one of our strengths at NASA. It is not a liability, but there are certainly things we can do better here in order to achieve our objectives. And step one in that is the conversation we have today and the materials we're releasing to you all today.
And with that, I think we will turn over the floor to the Associate Administrator to close us out.
Thanks, Bethany. And again, thanks to everyone for their interest, and of course the Administrator for his incredible leadership here. I think it's really important that we recognize that this is not about, it really is, this is hard to hear, and this for the workforce of NASA. And I've been here in the agency almost 20 years now, and it is hard to hear sometimes when we're talking about our culture and we're talking about how we do things. I think it's important to recognize that this form of leadership allows our culture to get better. And in the past, we've only really had honest conversations about our culture and our leadership and our sense of accountability and how we need to get better after the worst has happened. This was a really challenging event, and in our recent history, as the administrator said, we almost did have a really terrible day, thanks to the work that the team did in real time, as well as the wisdom that was showed, by the program ultimately afterwards when we were investigating that worked out. But that transparency is the key. We need to be able to talk freely about inside the agency, outside the agency, about what we're doing and when we're doing the wrong things. And we always talk about being able to speak up, but we don't all the time. And all of you that are hearing this probably feel that a little bit too. And I want to say that we know that, but we need to get better, and every day we need to get better. And so this transparency, it starts from the top. It starts with the administrator. It goes through me. It goes to everybody. Everybody owns that. And as we progress towards crewed lunar flight, as we continue to fly ISS, as we continue to develop these vehicles, as we continue to develop the incredible science machines that we're building, we need to be able to speak to each other. NASA is a family. And the extended NASA family outside, a lot of us have, on the outside, on the inside, have known each other for a very long time. And some of that it makes it hard sometimes to make sure that we're holding each other accountable. And we understand that. It's really important for you to hear that. We understand that, and this is what we're trying to communicate through this announcement, through the release of the products, and through the what we're going to do going forward. Recognizes just how close we all are, but also recognizes that despite that closeness, technical truth and rigor and focus in the right areas is really what we need from everybody. And I would say that it's also a little bit about. Like I said, we are a family, and Butch and Sunny are honestly like family to me. I will just tell you personally, that I've known them both for almost my entire career. On STS-129, I was the robotics lead for that mission, and Butch and I sat side by side together for hundreds of hours as we're preparing to install pallets on this amazing machine that now has been flying for as long as it has. He's really just a brilliant guy. He's got a great sense of humor. I'll tell you, one time that my first shift on console as a flight director, they make a big to-do about it, and then basically the flight director is supposed to tell everybody to leave, which I did summarily. But the next thing that happened after that was I got a phone call at the console, and it was Butch, and he was on board as Expedition 40. And he called me, and the first thing he told me was, "Man, it looks like they'll let anybody run this place." That's the kind of guy he is. When he came back from space, even from the Starliner on Crew 9, and during this whole incident, he stood amongst the entire world and said that he was also to blame, and that's an incredible thing. Sunny, same way. I mean, she's there's just an incredible American, just a brilliant astronaut. I first started working with her in STS-116. We're installing 5 trusses, and she's done incredible work in space all throughout the agency. It's interesting. A lot of you probably know. My parents are immigrants. I was born here, but they're from India, and they're naturalized American citizens now. But they still follow. My mom is still with us, and she still follows. She follows Sunny Williams because even in India, she's a rock star. And every time I see Sunny out at lunch or out at happy hour, she will find me, and she will make sure that we take a selfie and send it to my mom, because she knows that just how they have so much grace, and they're so competent, the two of them, and we failed them. The agency failed them, and even though they won't say that, we have to say that. We have to recognize that our responsibility is to them, and to all the crews that are coming, and to the crews that we're about to go fly, and and our responsibility is to each other too. We're a family. So I want everybody to hear that. I want the agency to hear that also, that this is what this is about. This is not about pointing fingers. It's not about assigning blame. It's about making sure that we are holding each other accountable in the incredible tasks that we have to do. And that starts with these sorts of discussions. And again, I think it's worth saying before I close, that the reason why Sunny and Butch are on the ground and having incredible adventures, the reason why we have this data that we have, the reason why we have all of the ability to really interrogate and learn from this, is because of the amazing people at NASA, because of their ability to react in real time, because of their fealty to technical rigor, because of their adherence to the lessons learned of the past, and making sure that we did conduct this investigation, and that we are holding that we are doing the right discussions, that we are doing the right test, and we are going to hold each other accountable so we can do the amazing missions that we have. And so with that, Bethany, I think I'd like to say thanks to everyone for being here, and thanks to the administrator for your incredible leadership.
And we'll wrap this up. Thank you.
And there we go. That is the conference covering the reclassification, shall we say, of the Starliner crew flight test to a Type A mishap. Hearing there from NASA Administrator Jared Isaacman and NASA Associate Administrator Amit Kshatriya. Some very interesting information said in that conference, as we just heard, and that full report, with some redactions required for legal reasons, is now available online. All 311 pages of it, so I'm sure we'll all be very interested in seeing EJ read through that live on the Flame Trench tomorrow. But in the meantime, before we get to that, over the last hour or so, whilst we've been listening into that conference, we have had updates on the Space Launch System rocket at LC-39B. That vehicle is now fully fueled, very exciting indeed. Fully loaded with hydrogen and oxygen on both the first and second stages. We can see there the aft end of the core stage. And the latest update we have from NASA came in at 14:41 Eastern Time. They say NASA teams have transitioned all cryogenic tanks on the Space Launch System rocket to replenish mode. This includes both liquid hydrogen and liquid oxygen tanks for the core stage and interim cryogenic propulsion stage. Cryogenic propellants naturally warm and evaporate over time, even in insulated tanks. Replenishment counteracts this by continuously adding small amounts of liquid hydrogen and liquid oxygen to maintain proper levels and pressure, ensuring the rocket remains fully fueled and stable as the countdown progresses towards terminal count. Following all stages replenish, teams will perform final systems checks and verify valve and sensor performance before transitioning to the terminal countdown sequence, which includes simulated launch operations and final readiness verifications. With all stages in replenish, the Artemis II wet dress rehearsal is now in its final fueling configuration, bringing this test wet dress rehearsal operations closer to terminal count. And that is something we all wanted to hear, and that is brilliant news. And we're basically pretty much back on time with where we're meant to be at this time in the countdown. Currently at L-5 hours and 31 minutes. Around this time is when we should have been getting into liquid oxygen topping on the ICPS, and we're already into replenishment. So we're technically running ahead of schedule, half hour ahead of schedule on that upper stage, with all stages now in replenish. So with that, around this time, usually on Thursdays, we do something called a Raptor side chat. And that happens over on Starbase Live. But you might have noticed there's a wet dress rehearsal going on right now. So we're not going to be doing a Raptor side chat over on Starbase Live. But we are going to be doing a Cape side chat on this live stream. So for the next hour or so, Chris B and the Starbase Live team will be taking you through some of the recent events over the last few days. I'm sure not only will SLS, but Starship and Starliner will also come up at some point. But with that, for the time being, first of all, I'm going to be thanking Alex for joining us on this first part of the stream.
Yeah, I guess we're being kicked out here by the SBL teams, right?
100%. Yeah.
Come on, get away. It's been fun. It's been fun. Glad to see that SLS is now fully loaded, and let's get that closeout crew out there, get all the crew stuff out of the way, and let's see how terminal count goes. But that's still like 5 hours away. So anyway, thanks for having me as usual.
Also, a big thank you to Alice joining us for this part of the stream.
Oh, you're most welcome, Ryan. I swear, every time I come and join you, they call a presser on me. I don't know what I'm doing.
Looks like your info card has been updated there, has it?
It has, yeah. I'm actually leaving N2K tomorrow, so I'm starting with higher orbits next week. So thank you very much to the team for letting me change that.
Very interesting. Keep an eye out for that on the internet. Also, thank you to Julia joining us from the field for this part of the stream.
Why, thank you very much for having me on. I may return later, but in the meantime, I hope you all have a good chat over the next hour here.
Indeed, and I have, of course, been Ryan Caton for NSF. I'll be back later on after this special edition Raptor Side Cape Side chat, and as we have 100% fueling on every tank in every stage, I'm going to hand it over to Chris B to talk about some whatever they talk about on Raptor Sides, I guess. See you guys later.
Well, hello, everybody. We weren't muted. We were just moving the microphones all the way from Florida, all the way over to Starbase Live, but then bringing it back here to this stream. So we are now live. Hopefully, if you can hear me. I'm getting 5x5s. There we go. There's a good sign. The 5x5s. It's Raptor side, but not quite. It's Cape side. It's odd, but it's also fun because we thought, well, we're not going to ignore Raptor side just because we're doing this very long stream with SLS. Because it's such a long stream, we thought, I know, why don't we take the Raptor side we normally do on SBL and bring it into this stream? And everybody wins that way, doesn't it? It works out perfectly well. It's the regulars from Raptor side as well. We're giving the commentators you've been hearing talk about SLS a break to go and get a cup of tea, or their some food, or whatever they want to do while we talk about not just SLS, but also Starbase and Starship. It's a crossover episode. That's right. We're going to be covering the two vehicles responsible for Artemis. Of course, Blue Origin's involved as well, but two of these vehicles here we're seeing are involved in the HLS program and Artemis program, so it makes perfect sense. Enough of my rambling. How about introducing who we got on with us? That'd be a good idea, wouldn't it? Let's say hello to Aaron. Hello, Aaron.
Hello. It's an interesting one today with our Cape side, Raptor side.
Cape side, Raptor side. I know I could have thought of a better name than Cape side. I was thinking Gator side, but I think that's actually taken by something, so I don't want to copyright anybody. But we're also joined by Elisa. Hello, Elisa.
Good evening, everybody.
We're also we were not really joined by Gage. Is very busy, but I think it'd be rude not to say hello to Gage at the very least. Hello, Gage.
Hey everybody, yeah, I've been here controlling the some of our Space Coast Live cameras throughout the stream, but I thought I'd pop on and say hi, and man, we got a fully tanked SLS at 39B. This is very exciting, Chris.
Indeed, it's just an excuse for chat as well, to spam chat with Gary emojis, the Grackle. So
yeah,
it's always worth it. Yeah, there we go, there they come. They're already coming. We're also joined by Jake. Hello, Jake.
Hey everyone, how you all doing? And yeah, this is a bit different, but yeah, looking forward to it.
Now, I'm reading off it's almost like an audio panel thing where it shows who's available on microphones or whatever. I see a certain Max Evans has popped in. I don't know if Max is going to join us on a Cape Side Raptor Side crossover episode or not. I'm going to see if he unmutes first. If not, he's coming to the wrong chat place, but we'll soon find out. But either ways, I don't see him unmuting, so I'm going to go straight to Roger. Hello, Roger.
Hey, Chris. Wow, what a day. A lot to talk about, guys. Thanks for joining.
Yep, indeed. Now, it's like normal Raptor Side. If you got a question, do the routine at NASASpaceflight, follow your question. The thing is, we've got lots of questions from the actual mainstream, so I will try and divert across to ones that came in recently. And speaking of things that came in recently, people who are on here might not be used to Raptor sides. We get crazy amounts of support for no reason, no viable reason whatsoever, because Raptor Side is a Starbase Live where we turn our microphones on talk for an hour. There's nothing brilliant about that at all. Yet we get crazy support. Here's the example. Patrick Bob has gifted a $500 tip. I'm not even joking. That's crazy. And it's not the first time. It's not even the third or fourth or fifth time. It's the sixth time I think Patrick's done that on a Raptor Side, which is bonkers. And then followed it up with 50 gifted Red Team memberships. And I saw 50 from you earlier, Patrick. So you've done 100. So that's 100 gifted memberships and a $500 tip, which is bonkers. I've seen streams with like 80,000 people on. They don't get that kind of support. And I've said it before, Raptor Sides, but again, if you're new to this kind of thing, where we're just babbling for an hour or so, which is what Raptor Sides are, then yeah, that actually is a regular thing from Patrick and the likes. It never gets boring, it never gets old, and it always is very much appreciated. It's absolutely crazy. Oh, Max is just listening. That's cheating. We could have got some Max on audio there on a Raptor Side in a crossover episode completely. I'll tell you what we're going to normally do, right? We need to update the status. I think Ryan outroed the mainstream with the status on SLS, but I'll give my own take because I've been covering it, obviously, and watching it and updating the article. It looks like it's all going to plan. I'm not trying to jinx it or anything like that, but it has got much... It's proceeded a lot better than we saw during the first wet dress rehearsal. They had a couple of holes for leaks. They had limitations on the leak rate. I think it's 16% they can go to without it breaching, but we've not had indications of any leaks at all, to be fair. And NASA, this time round, likely thanks to Jared, has been very transparent with this one. We've had engineering cameras, we've had regular timely updates, We didn't get that on the first wet dress rehearsal at all. We had one camera, plus our cameras, of course, and no engineering cameras. And the updates were like 30, 40, 50 minutes later because we do know people involved with the program. And we were hearing things way before NASA was putting out anything on their little blog page, as we call it. So this is a lot better on all accounts. The transparency, the amount of camera views we've got in tandem with our own cameras, and also the fact that it's going well. It's going very well so far. Still a long way to go, and even if we get through this without any issues, to get to the end of the night to go, that's it, we're detanking now, everything went fine, they will still go through a data review. The data review is where they will set the launch date, not before. There is a thing, going back to the Space Shuttle program, and going back to all crew launches, called a flight readiness review. There's a launch readiness review for all rockets, but there's also a flight readiness review. Agency level, SOMD they called it, flight readiness review. That is when they set the launch date, and not before. Doesn't matter how well this goes today, it doesn't mean March 6 is definitely on. They will do a data review. It'll take time. They'll take that data review into flight readiness review, the FRR, and then they'll decide the launch date from there. Roger, I'm going to bring you in because I'm talking a lot. Back to the days of the early crewed spaceflight programs. I mean, how does this rank to you? Because, yes, we've had boots on the moon. It's been amazing. Wonderful. The Apollo program was superb. This is going around the moon and not landing on the moon, but it has to be the most important mission for NASA since then.
Yeah, definitely. I mean, to get out of our own neighborhood, if you so to speak, get back around the moon at least. This is going to be a good shakedown cruise for this vehicle, and looking forward to what all the other private companies are going to be doing to support the Artemis II mission.
Indeed, yeah. And also Artemis, as you mentioned there, it involves 3 companies, if you think about it: Boeing with SLS, SpaceX with Starship, and Blue Origin with New Glenn. Now, that is basically what HLS's launch vehicle capacity is all related around. But we're looking at 2 of the rockets that are pretty much out there and launching, which is looking at SLS here. We're looking at Starship going to Block 3. New Glenn, we've just got the information from David Lim, who literally replied to me saying that the booster that landed on Flight 2 is going to be used for Flight 3. That's amazing flex from Blue Origin that they're going to do reusability on Flight 3. That is totally unexpected. In fact, you know what? I'm going to talk about that for a second, Jake. With the confirmation, as it stands right now, that Blue Origin are going to refly the booster that flew on Flight 2 on Flight 3, is that to you unexpected? Did you expect Blue Origin to be reusing their boosters this early in the flight program of New Glenn?
Yeah, I'm not totally surprised, although I didn't think it was very likely that sort of thing was going to happen. I mean, if they managed to pull off a successful flight of the first ever recovered booster, on the next flight, then all I can say is fair play. That's a hell of an achievement if they managed to pull it off.
It is, because I personally thought maybe the 4th flight. They'll do a 3rd flight with a new booster, because they have got a new booster in production. But also, the fact is, if they do fly this reused booster on Flight 3, that new booster we're talking about, which I personally thought with Flight 3, is pretty much down the road. And they could easily launch 2 New Glenns within like 4 weeks of each other, and that would be another flex from Blue Origin, because I call them New Origin from Blue Origin, because they would then be bringing up the cadence, and that's something that Starship really needs to start doing as well. We have the allowance here because we're on Block 3, and that is a new variant of the vehicle. It's Pad 2. It's a new designer pad. The stand down was always going to happen between Flight 11 and Flight 12. That was always going to happen. There's no unexpected delays here. This is pretty much what we expected. But after Flight 12, providing it all goes well, that's when we'll start to expect to see SpaceX build up the cadence. I mean, Elisar, we've been looking through the windows of Star Factory. We've seen all these ships line up in the nursery, all waiting their turn. If they start getting successful flights, such as Flight 12, Flight 13, we might start hitting 1 a month, maybe?
I mean, at some point, yes. I don't know if it'll be this year, but next year, definitely we can see once a month. If not, plus by then we should have a pad, at least the 39A, operational, apart from the one pad 2 at Starbase. So, if we're doing 2 of them, once a month is definitely doable.
Indeed. back to SLS. It's a crossover episode. We're going to be going between Starship and SLS, just like on a snap of a finger here. But I do have a question from Speedy Lad, and I think it's one of those questions where we can answer it and it updates several people in one go, because a lot of people will be coming in, maybe just popping in right now going, why is that numpty talking? I was waiting for Ryan Caton to give me an update. It's like a 1 hour break for the rest of the guys where we just do our Raptor side, but we do it on this mainstream. But the question is this further into the wet dress rehearsal than last time? Technically no, because they did go through tonight with the wet dress rehearsal 1, but they had issues. They never completed it. And this is a different thing. So we're not there yet where they've gone further because they've got to complete it. But it is looking a lot better. I think that's the context, is that so far so good. They've still got to get into what will be the business end of this test, which is the terminal count. We're not there yet. We're not expected to be there for several hours yet. In fact, look at the clock on the left-hand side, top left-hand side, still over 5 hours until the end of the test window. So we have a long way to go, but I will say that so far so good. And on the previous wet dress rehearsal, we knew of issues by now. We knew there were issues, there were leaks and what have you. They stopped flow of the liquid hydrogen and things like that. We've not had that issue this time round. The vehicle is fully loaded and stable replenished. This is all very good so far. So timeline, we're not there yet. But as far as progress and as far as lack of issues, this is a lot better. This is looking a lot better. And there's no like fluffing up of that at all. It literally is looking a lot better.
Hey, Chris, I think we have an update.
We have an update. Breaking news.
Yeah, so per Julia in the field, it appears the closeout crew is staging over by the VAB to get ready to depart to the pad for later in the count. So for those who don't know, the closeout crew, they're going to be going out to the White Room, which is the crew access arm there at the top of SLS, and they're going to perform basically what they would on launch day, except without the astronauts on board. They're going to close the hatches, they're going to close the launch abort system hatch, and get Orion configured for flight. But the closeout crew is staging to go out for later today, so that's exciting.
That's Eyes On update. That's not from NASA blog. That was Julia's own eyes, Mark 1 eyeballs, seeing it because she's out there. Our team is out there. That's something we do. If you're new to this channel, we're not one of those channels where we take NASA's feed and just restream it and talk over it. We do utilize what NASA provides us on these clean feeds, they call it fiber feeds, where you can see, like, we don't have a camera on the pad looking at the engines. That's not allowed. That's not an NSF camera. No. That's a NASA camera. And that's a feed, a clean feed that we can put into our feed as well. But if you look at the Starbase cameras for a start, they're our cameras, obviously. And then the top ones at the top, they're our cameras as well. So probably one of them's NASA, the other two are ours. We have people in the field at all our launches. That's why we make a big deal out of support we get, because we are literally putting a lot of effort and money into these things to provide you the best views. That's what it is. It's a roundabout thing where we get to support the community. We can do more and more things that the community really gets like, because you all like rockets. I would assume everybody in chat right now likes rockets. Tell me if you don't, and I wonder why you're here if you are. Talking about Artemis, by the way, I do like these questions because we do have a lot of new people arriving because of the interest in this mission. And they will ask questions that most of the chat will already know, but I don't mind answering them. Earl S. Hicks Jr. wants to know, so are astronauts flying on this mission or not? Yes, they are, 4 of them. This is the first crewed mission of Artemis, the first crewed mission of SLS and Orion. The first mission of SLS was Artemis I. That was an uncrewed test flight with Orion. This one is a crewed flight, this time with astronauts on board. And that sets the stage to shake out the vehicle with a crew on board before they start then progressing towards the later missions where we will end up with a lunar landing with boots on the ground again, the first time since Apollo. There are caveats in this mission that once they launch, they're not basically, we're going around the moon or nothing. They'll do lots of checkouts of the vehicle before they do the translunar injection burn. They have lots of ways that this might not even happen, where they launch and they just go around the Earth and come back down again if there's problems. That's a safety factor. That's on purpose, and that's what it should expect to always have on a NASA mission these days, because they don't want to take chances. But so far, everything is pointing towards things progressing to plan. We will see 4 humans going around the moon. I think it's the furthest, Roger, is it the furthest humans have ever been?
To my understanding, yes, because of their orbit they'll be going out farther than the Apollo missions did.
Yeah, which is exciting as it is. I mean, that literally is. For somebody like me, who got into this with the space shuttle program, all the missions I followed for 3 decades were 250 miles up and a little bit more if you're going to Hubble, There was a few missions that went quite high, but the shuttle's limitation was pretty much just under 300 miles orbit. You could not go any higher than that with the space shuttle. That was the limitation. Low Earth orbit, to be more direct, was the restriction for 3 decades of the space shuttle program. This is the return to beyond Earth exploration. And this is a big deal because this sets the stage. We've seen that SpaceX has realigned to something I personally think they should have done from the start, which was to go moon first. Mars is exciting. Mars is super exciting, and Mars is not off the table, as is being reported. It's just going to be after the moon. I'm bringing Jake back in on this one. Jake, this whole lunar first thing, I know we had Ryan Webber agreeing with me on this one, but I never got your take on it. With this refocus on the moon first, as Elon has portrayed it, because of the fact that it's easier to get there, they've got no restrictions on launch windows and things like that. Do you think that is the approach that SpaceX sensibly should be taking now? Because it does seem like a more viable plan than building a city on Mars in like 5 years.
Yeah, I mean, I absolutely think this is the correct decision. You know, obviously going to the moon first, and that can, you know, be a pretty good training ground for future Mars missions. And as I've said to other people before, if anything goes wrong with the lunar missions, you're a heck of a lot closer to Earth, and it's a lot less traveling compared to Mars. So it'd be, you know, a lot better to work all the stuff out with Starship now, using the moon first and then on to Mars.
Yeah, indeed. And it is, again, I'm going to mention, it won't be the last time I'll mention this. You are looking on this screen here with 1, 2, 3, 4, 5, 6, 7, 8. 8 views. 4 of them from KSC and 4 of them from Starbase. These are the 2 launch sites. These are the 2, the East Coast and the Texas coast, where they'll be launching these missions that will be responsible for pretty much returning humanity to the moon. I do personally think they'll beat China, because I see people in chat will usually go, but China might get there first. I honestly don't see it. I do not see it. And I do follow the Chinese program quite well. They are making progress, but they're still way behind the Americans, way, way behind. So I'm not fearing that too much. It's a nice little motivator to have politically, because you should always have someone pushing you. But I honestly think they're way behind compared to the Americans, unless you're talking about robotics and things like that. They're making good progress on robotics, but human, nah, I'm not seeing it personally. Aaron, I'm going to bring you in on this one. Starship, right? When will the first Starship from Florida? When do you think we'll see the first Starship launch from Florida?
Based on Pad 2 at Starbase and its construction timeline, I think the Launch Complex 39A pad should be ready for a launch by mid Q3 this year, or late Q3 this year. So a Starship launch probably early Q4, so October-ish maybe.
Yep, that would be pretty. Well, Jake, what do you think? I know you like keeping a good eye on the pads. Now we've got some kind of a template now, haven't we? Because 39A is following the same path as Pad 2 at Starbase. Based on watching Pad 2's readiness, because it is now just literally weeks away from receiving a booster for a static fire, how far away is 39A from being in that at that point of time?
I think from everything we've seen, it's roughly sort of start of Q3 of this year for the pad readiness. Although I wouldn't be surprised at all if the first launch does end up being maybe late Q3, start of Q4 from Florida.
Very good. I'm thinking, Roger, because there's a lot of questions which are related to news that has just come out, and I have covered them on my X feed. It might be worth doing that now, where people who are not used to this, by the way, people who are not Starbase Live regulars and used to Raptor sites, what I do is on a Raptor site for about 30 minutes, I go through all the latest X posts I've made. Luckily, most of my X posts are news. They're not just random thoughts of Chris. Otherwise, I have no viability whatsoever. Roger, shall we try it and see what happens? Because this is going to be quite new for a stream like this. Let's see. Hold on. Oh, that looks hurtful. Look at this. We've got presented in a special box. A special box surrounded by SLS. That's bonkers. There we go. Right, so we're going to start with the latest news that we did since the last Raptor side. So we didn't cover this in the last Raptor side on Tuesday because we'd then gone on to Wednesday and things like that. First of all, Firefly, the Alpha Flight 7 is now targeting no earlier than February 27th from Vandenberg. So that is a bit of a slip for Firefly's Alpha launch. But again, not too much of one. That's only literally 8 days away now. So that's pretty good. Then we had... this was the deluge test. Of course, we've not yet covered some of the things we've been doing. We did on the Monday deluge test. We had lots of clips, but I like this one. If I can press watch again. There we go. Thank God that's working. I was kind of fearing what would happen here. This was a slow motion video from Caesar of the Pad 2 water deluge test. Jake, I'm bringing you back in. This was impressive. I mean, am I right in thinking this was surprising amounts of power because I didn't think it'd be this good.
Yeah, I have to admit I was a little surprised about just how much water came out of that top deck. And obviously I know it spreads during our test the other day. It did spread out quite far, but obviously during launch operations, a lot of that water will be contained, more on the OLM. But yeah, I think it was a little bit more powerful than I thought it would be.
It's very cool. And the reason why I quoted Caesar's video there is because I wrote an article around what was in the SSU, which is our Starship update video. And basically, I thought it deserved an article on its own. So I wrote one around that with lots of pictures and what have you, because that was a fun thing to watch. And look at the rainbow. How pretty.
Chris,
then we had... Hello, what?
If I may, that test, because I was right next to Caesar.
Oh, yes, Gage.
And I gotta say, that was one of the craziest things that I've seen. We were definitely not expecting the water to reach all the way to Highway 4, because when the normal deluge started, I was like, oh, okay, right, it's just one of these again. And then when the top plate went off, oh my goodness, the rainbow that it produced after that was incredible. And it was very, very loud. So, yeah, this was definitely an amazing test to see in person. And this kind of makes me worry a lot less about Pad 2's condition after a launch.
You know, the fun thing is, Gage, I saw the unedited version of this video that Caesar's put on there in slow motion. It was in real time, and it got to about here at the end of this clip, and he stopped it there because at that point he starts running with the camera behind his vehicle because he's getting absolutely soaked.
Yep, we got a little wet after that test, so yeah, definitely.
Oh, brilliant. Right, there we are. Back to, look at that for segue. It's Gage's own tweet about what? X-Post, I should say. Sorry, I keep calling it Twitter. I'm old. Artemis II Wet Dress Rehearsal countdown has started. There we go. So this is where we are right now. We're into the countdown because it started obviously way before where we started live streaming. And that was the T-minus 45 hours and 12 minutes mark with big countdown clock at KSC. The famous countdown clock, but has been replaced since the days of shuttle. It used to be like light bulbs. I don't know what the technical term is for that old style countdown clock, but it was iconic. It's in the same place. It's just now LEDs and what have you, and fancy modern day technology. But it is the famous countdown clock in the same place in the press site at KSC.
In fact, if you go to the KSC visitor complex, they have, I don't know if it's the old one or at least a replica of one, but when you go right into the entrance of the KSC visitor complex, they have that old countdown clock that you were mentioning that they used back in the shuttle era. It's really cool to see. At full size, too.
That pleases me, Gage. I'd have been devastated if they'd just thrown it in some trash because it is iconic. There's too many shuttle videos I've got, not just the NASA ones, but people who went there with their VHS camcorders. Yes, I'm aging myself. I don't care. They're VHS camcorders. In fact, there's a video in L2. I'm not promoting L2 on purpose here because it's one of many, many videos going L2. But it was amazing because for some reason, the old-fashioned VHS recorders really caught the sound perfectly. I've seen videos on fancy digital cameras since, such as Artemis I, for example, with the SRBs, they've not got the same kind of sound for some reason. It's a bit like those old 60s photography of the Apollo program and 70s pictures where the vehicle just looks better because it's old-style film. I don't know if there's something now we've lost in digital, but it really is amazing. That countdown clock was always the iconic view as the vehicle was leaving the pad. Right, I've babbled on about countdown clocks too long, so let's move on to Gigabay. Oh, look at this. Elisa, talk me through this post of yours.
Yeah, that's what I've been doing for, this is the 4th month since they started essentially putting the cranes together for the one in Starbase, putting together the Gigabay. I mean, we talked about a monthly Starship launch and the cadence they're going to need, so they've been busy at it, and I've been keeping on the one at Roberts Road at the Cape as well, possibly trying to see if I can do similar time-lapse of month-by-month progress until they complete it.
Those cranes are hilarious. When in time lapse, look like the antennas of ants. They're just going crazy. But they're going to raise those cranes, aren't they? That's how they've done it. They've basically got them on these platforms where they can just raise them every time they add another layer to the Gigabay. So that is really kind of cool how fast they're building this. And of course, we have the one at Roberts Road. Let's segue. We're in a crossover episode with KSC and the Cape. Let's talk about the Gigabay at Roberts Road. Aaron, what do you think is going to be finished first? Roberts Road Gigabay or Starbase Gigabay?
I believe Roberts Road is ahead right now, if I remember correctly.
You do?
So I'm going to hedge my bet safely on that one, I think.
I think that's a very safe bet. I mean, we do have, thanks to Colleen at Starbase and Julia at KSC, we have a once a week, and I'll have to scroll back and find it, but that'll be just a mess on this stream, where every week, if you follow us on our feed, every week, Julia takes a photograph in the same position as Colleen does, and we can do a comparison between the two Gigabays, one at Florida, one at Texas. And yes, the one in Roberts Road, Florida, is progressing a lot faster than the one at Starbase, but they're all progressing, and we're getting closer and closer to these massive facilities where we're going to start seeing starships coming out of there left, right, and centre. And that's a good sign, because that means we've got the launch cadence up, and we can't beat a lot of Starship launches. They are impressive. Right, here we go. Alex noted that this is interesting because it was a fairing we thought was for 10:36. Oh, yes, I hit. Was that Gage?
Yeah, so this mission is very interesting because we saw this fairing roll out a couple of days ago, and we believed it was for Starlink 10-36. Then, just I think yesterday, those exact fairings ended up rolling back from 40 back to Hangar X, and that kind of scratched our heads a little bit. It's like, okay, interesting. Maybe something happened with those payloads, and they needed to go back and get swapped out for another fairing, which is likely possible. Then overnight, just this morning actually, we saw another fairing roll back out to pad 40. Unfortunately, it was in the middle of the night, so obviously I was not awake to track whatever fairing numbers they were, but it's either the same ones or it could be a different batch. And those rolled out just this morning, and then as you can see on the top left-hand side of your screen there, just underneath the Artemis II WDR clock, and thank you, Carson, we got a Starlink clock in T-minus 5 hours and 12 minutes. Falcon 9 is already vertical at pad 40, and I don't recall, but that is really, really fast, because that fairing rolled out at like 4 a.m. this morning Eastern time, and here we are like not even 12 hours later, and the rocket is vertical on the pad for a launch time in about 5 hours from now. So I don't know, is that a record from a fairing rollout to being vertical on the pad?
Maybe. I know a few people like Alex will have spreadsheets to tell us the facts on that one, but it was because we were all thinking, well, hang on a minute, maybe they're going to be pushing this one, but so far it's 5 hours to launch. So there we go. And of course, we will be covering that one. What a surprise. I'm sure no one will be absolutely surprised by that. We'll be covering this one. Regardless of what happens with Wet Dress Rehearsal, we'll find a way of covering both. Maybe inside this stream, but either ways, we have a dedicated stream for it if we need to. So either ways, we're covered. So we'll definitely be covering that launch. This was great. This was Rocket Lab, right? Rocket Lab are a bit cheeky. We know they're a bit cheeky. They're a little bit perky at SpaceX. Peter Beck, who's the CEO of Rocket Lab, is known to be a bit perky. It's mainly fun. We've seen interviews with Peter Beck. He can be quite fun. He likes eating his hat and things like that. We know what Peter Beck's like. But the admin for Rocket Labs was talking about the Mars Telecommunications Orbiter. And because Elon and SpaceX have announced their preference to go onto the moon first, they did this. Look at me. Look at me. I'm the Mars Company now. From the excellent movie that I've completely forgotten. It's the Tom Hanks movie. Someone chime in and tell me which movie it's called.
I believe that is Captain Phillips. I
That's
think.
it. Yes, it is. That's it. I'm normally pretty good with my movie trivia, but my brain wasn't working now. But it is a great movie, and that's the part where the Somali hostage, the Somali pirates took over the ship, and he's telling Tom Hanks, "I'm the captain now." Oh, that was hilarious. Right, so this is. Oh yes, we're really pushing this deluge thing, but it was fun. Let's face it. This was Starbase. This was a video. That's right. We got more clips. That actually is the video that was pinned in Starbase Live before I pinned this stream into Starbase Live, but I'll repin it later. The latest daily video, the one that's narrated by Daz. You know ones of your regular followers of our channel. Daz narrates over lots of footage that we get from Gage, from Colleen, and from Caesar. We put it into a nice little edited package. We put it into order, and then we have Daz talk over it. We even got Marty talking in Dutch as an alternate narration. We've even got the ambient soundtrack if you don't like people's voices. So either way, you can't lose. But that is from that video, and that's the little clip from it. We had Raptors rolling Arvax again. This one we're in the hundreds on the Arvax, 106, which is really good. And it's an important thing because our McGregor live cameras spot these vehicles and engines rolling across the road. We repositioned the cameras from what was a tripod stand view, because the tripod stand has been retired, to the new Raptor stands. And as a bonus, it happens to be in view of the road where they roll the stages and the engines past the cameras, which is excellent for spotting Raptors and excellent for spotting stages and things like that. And that is where it's coming handy for something like this. We're seeing the Raptor 3's, the new engine that's going to work with Block 3, making a lot of progress on the numbers. The higher the number, the more Raptors they've got, basically. I think you've worked out one for yourself. But that is great progress on the Raptor 3s. Jake, I think I probably asked you this about 5,000 times already on previous Raptor sides, but I'm feeling like they've probably got enough engines now for 1 to 2 flights, and that's why they've been installing the Raptor 3s on boosted 19. But we're looking pretty healthy on the Raptors now, aren't we?
Yeah, I think they've got probably enough Raptors produced now for a few flights. Whether they're all tested yet or not, that remains to be seen. I think they're probably most of the way through testing of all of them, though, for the first flight.
It's going to be really interesting to see how far they get, because if we go back to this kind of view in like 6 months' time, and we start talking about Raptors in 300s, for example, that might be enough to really have a flight cadence going. And people will go, "Well, Chris, I've just divided 33 Raptors on the booster and 6 Raptors on the stage, and you need more." Well, think about it. By then, hopefully they're catching boosters again, and they're catching ships. And when you catch the booster and catch the ship, you're catching the engines as well. That's the thing. That's the trick. And then you're reusing those engines. These are reusable engines. So once they get to a certain sweet spot on the amount of engines they've got in storage and in production and in readiness to launch, they'll start bringing these engines back by default by catching them. So that's the fun thing with the reusability, is that you don't need thousands of engines. The idea is that you return those engines and refly them, like Falcon 9. So it's good news all around, basically. Of course,
hey, Chris,
a long way to go.
Update.
Oh, update. Hello.
Sorry to interrupt you. We do have an update on the SLS Wet Dress Rehearsal number 2 for those who are just tuning in. So an update from NASA. So we are now at 1 hour and 10 minutes hold during today's Wet Dress Rehearsal countdown, and all stages of the SLS rocket remain in replenish mode, which is very, very good news. Now, NASA's pad rescue and closeout crew teams are moving to their staging area before heading out to Launch Complex 39B. Now, these teams ensure safety and readiness during the critical fueling operations and play a vital role in protecting personnel and hardware throughout the countdown. That is the quote from the NASA update. So just as we mentioned earlier that Julia saw the staging crew just staging right outside the VIB there, they're getting ready to head to the pad later on today. So that's good news for the Artemis II Wet Dress Rehearsal.
2 things, Gage. One, thanks for reading out, because our the way that's posted is in dark mode, and I hate dark mode, as you can tell from my X feed. I like light mode. I'm weird. Hey, I don't mind. I'm weird. I like light mode. I can see black text on white backgrounds a lot better than I can see white text on black backgrounds. That's just me. Don't hate me for it. But the other thing is, now in a 1 hour 10 minute hold because of Cape Side chat with Chris, I thought that's what it said, Gage. I'm sure it said that. NASA update, holding for Cape
Yeah,
Town.
yeah. So
Yeah.
right now, the clock is at T-minus 3 hours and 30 minutes and holding, and it'll remain that way for 1 hour and 10 minutes. Sorry, I should clarify that.
Yeah, I'm just looking the riot in chat right now. The fact that I've just mentioned that I prefer light mode. Oh dear, I've let myself down, but you know, I'm going to say what I think. There's actually one person who agrees with me. There we go. So it's not just everyone's like dark mode. Oh, there we go. Moving quickly on. By the way, before I move on, I need to thank some people. This happens on Rapsides a lot, and it is always bonkers. It really is. So chat is still writing about dark mode. Tall End has become a Capcom member, which means you have got access once the YouTube-ness and the Discord-ness interact with each other automatically. It will put you into our Discord, our member Discord, which is a great fun place. I spend way too much time in there because I've got a lot of work on, but I get distracted a lot by our own Discord. It is a lot of fun in there. It's not just rockets and all of the rockets. We've got about 50-odd channels, I think. It's more than that, probably. We've also got sports ball and things like that, so we can talk with the Americans about what football actually is, where you kick it with your foot rather than catch it with your hand. True story. But we've got lots of channels in it. It's a fun place, and it's a real nice community as well, I must admit. So you've got access to that now, long story short. Patrick Bob is back again. Patrick, you're getting carried away now. I mean, we got carried away before, but that's 150, isn't it? You've just done another 50 gifted memberships, which is the maximum you can do, by the way. So that is completely bonkers that you've done it 3 times, the maximum amount 3 times in one stream, which is what you've done. Anyone who joins this and goes, Chris is just talking about people giving 50 memberships and don't sound about. I really am. It's just my accent. I'm a Yorkshireman. we always sound disingenuous. It really is weird how it works. I really do appreciate it. I remember I started this site 20 odd years ago now. The channel's not 20 odd years old, but the site NSF is 20 odd years old. It's my, what I started. So when people support it, it really means a lot to me personally. We're not owned by some parent company, and we're just basically working for them. We own ourselves. We look after. We're editorial control for a start. It's a massive thing if you think about it. So when people support us, it means the world. It really does. Ron has become a PadRep member. Welcome, Ron. Bideford, hello Bideford, another regular, another big supporter regular as well. So nice to hear you, Chris, on this wonderful modified Raptor enjoying the coverage. Thank you. It is a bit weird, isn't it? It's a bit weird. We're doing a Raptor side on the main SLS stream. I always fear that we've got people, hardcore followers of big milestones like this wet dress rehearsal. They'll be tuning in, hearing me rambling on about this, that, and the other. This is just like the 1 hour or so break where we're just doing our normal Raptor side, but rather than do it on SBL, we'll do it on this stream instead. That's all it is. Don't worry. We'll go back to our regular programming afterwards. Apocalypse Cow, Danger Moo, as we call him, has gifted 10 Red Team memberships, loads of membership support. By the way, Fighting Falcon, I think Ryan might have missed this one, became a PadRap member earlier, so I'm making sure that Fighting Falcon gets a name shout out there, because I always like to make sure people who support us gets a little reference on our streams. So thank you very much for all your support. It's excellent and very much appreciated. Back to the feed. Here we go. Right, so this was Wet Dress Rehearsal milestones. I've been, obviously, while we're doing the stream, doing the X-Post and updating the article on site, making sure that side of things is updated, not just the stream itself. But we had lots of milestones in here. In fact, that's not a terrible idea. If you're joining late now, maybe you just finished work, if you're the UK, that would probably apply to you, as for example, and you want to just quickly catch up. You've got the article on site, and you've also got my X feed. You could just scroll back down and catch up. That's one way of doing it, which I'm going to do now anyway, but that's one way of doing it in your own time. There is the start of our stream. There is us getting very excited by the fact that we did not know this in advance, that NASA was providing engineering cameras this time round, unlike Wet Dress Rehearsal 1. Rejoice! NASA providing engineering cameras. I wrote. RS-25 is in chill down. We get to see this time. That was the milestone where they were starting to chill down the lines to the engines and to the tankage. What you got to do to not shock the lines as they start moving into slow fill and fast fill, because they are extremely cold cryogenics. Then we had, news from Blue Origin, which was a nice look at the fairing for their Flight 3 mission. I believe that was the one where I went, let's have a look, see. Yeah, it is one. Super. Is Blue able to confirm if Flight 3's booster is a new Tail 3 or reusing Tail 2? By the way, I got replies saying, Chris, it's already been announced that it's a new booster. I thought, well, hang on a minute, let's ask Dave Limp and see what he says. Aha! Dave Limp says Flight 3 will reuse Booster 2. So there we go. We got news. We had news. Thanks to David Limp, who's very interactive on X, I must admit. He's replied to many, many questions from us and others as well, which is really cool, especially for Blue Origin, because they used to be very quiet and very, let's say, secretive. Is that the right word for it? They weren't very open. But since the last year or so, especially with David Lynn becoming CEO, they've become a lot more open and talkative, which I think is always a good thing. And that was a good example. We got confirmation that Flight 3 will use Booster 2, a reuse of the, they call it tail, not booster, they call them tail. So tail 2 will fly on Flight 3. There was the loading stats from the Wet Dress Rehearsal. These are updates we've all got. Right, here we go. So we had one issue today so far, which was a minor one. It was a ground comms troubleshooting issue, which they did successfully resolve. That was only ground communications, nothing to do with hydrogen, to which Carson did this in our back room and I put it out. I can't believe it wasn't hydrogen. So I thought that was hilarious. Ah, dear me. I'm easy to chuckle, I must admit. This was when we got late notice that NASA was going to have a press conference about Starliner. We thought, hang on a minute, today's not busy enough as it is.
In fact, we actually did get a response from Boeing. If you'd like me to read it out, Chris.
Let me get through what Jared was saying first, then we'll do the Boeing one. That'd be a good idea, because then we've got a timeline. But yes, I did hear we got a response from Boeing. So let's do this first. We had good signs with Wet Dress Rehearsal going to plan. We've got the Starlink launch again tonight, which is where the booster will land off the coast of Bahamas for the second time. We've got NASA's all is well, as we're loading. They're not 100%, by the way, in all these stages. So I think I get to in a bit. Then we got the statement from Jared before the press conference where it was really... It didn't pull any punches. There's too much to talk about right now, but there was lots of issues with Starliner. And the bottom line is they're not going to launch Starliner, crewed or uncrewed, until Boeing resolve all the action items. So many action items. That's harder to say than I thought it would be. That I do wonder, and I will ask everybody in this before we get to Gage, after we get to Gage, if Boeing are going to continue with this. Gage, this is your chance to say what Boeing are saying on this now.
Sure. And then real quick, just a quick update on the Wet Dress Rehearsal. On the top box there, we are expecting the closeout crew to be arriving at the pad shortly. So keep an eye out for the white closeout crew van there to pull up to the pad there. But a statement we got from Boeing, they said, "We are grateful to NASA for its thorough investigation and the opportunity to contribute to it. In the 18 months since our last test flight, Boeing has made substantial progress on corrective actions for technical challenges we encountered and driven significant cultural changes across the team that directly align with the findings in the report." They go on to say, "NASA's report will enforce our ongoing efforts to strengthen our work and in the work of all commercial crew programs in support of mission and crew safety, which must always be our highest priority. We are working closely with NASA to ensure readiness for future Starliner missions and remain committed to NASA's vision for 2 commercial crew providers." That is a statement to NSF from Boeing.
Interesting. Right. Let's labor on this for a little bit, because the way that we got information from Jared, which was transparent and absolutely appreciated, and it didn't pull any punches, it was a lot worse than even we thought it was. They even got down to single fault tolerance during the landing, uncrewed. Thankfully, the decision was made not to bring Butch and Sonny back on Starliner, because there was a conversation about whether or not they should do that. It actually landed with issues. It was down to single fault tolerant, which is ridiculous. I mean, that is seriously bad. So that was new. And now we've got this statement, which is... Roger, what do you read into this?
Covering their backsides.
Yeah.
Why wasn't this a priority years ago? Why, I think they got caught. They're in spin mode. Very disappointing on Boeing's side. I'm also disappointed on NASA's side that they took them originally at face value, that their legacy, rather than evaluating everybody on a level playing field. So again, I'm very appreciative of what Jared did today. I think it's definitely going to, going forward, reiterating, crew safety has to be the priority for all this. Other goals come second.
Yeah, I'm reading this and I'm not getting much from it. It's almost like, okay, we've had our backs, sorry about the language here, our backside spanked here. Let's just take it on the chin. We'll say what we need to say. And I honestly do think Boeing will have a conversation with themselves saying, is this really worth it now? Is this really worth it? We can say we're committed, but we'll get to the point where it's going to be too much money. Remember, I do believe that the way things are is whatever work they need to do to rectify things, it's on Boeing's dollar now. Yes, they got a big contract for it, but it's now on Boeing's dollar. They can't go to NASA to give them, more invoices. So I wonder if they'll start thinking if it's worth it or not. Jake, what's your thoughts on this?
Yeah, it's pretty damning to say the least. There's definitely a future for Starliner with all the space stations that are planned. Whether Boeing actually wants to stick around in the space divisions long enough to be able to, to fly Starliner to all the space stations remains to be seen. But I'm not convinced this is the end of these sort of issues for Starliner and Boeing. If I'm being honest, I can't see this being the end of it. That's just my personal take.
Chap, I should ask you as well, chap. But I won't do a poll. Polls are always a bit iffy when you do a poll because you don't convert anything for fun, for trolling purposes and what have you. Just type in chat. Do you think Starliner will fly again? Yes or no? Let's see what it does. And while we do that, let's go to Aaron. Aaron, what's your thoughts on Starliner's future?
Reading the reports, I am not hopeful in the slightest that Boeing will keep this going. I do not think they will proceed with Starliner, to be honest.
You know what? Chat is split. I'm getting lots of no's now, but we definitely saw a lot of yeses to start with. It's split. Again, you could vote yes and still not be happy with it. Don't worry, you're not turning into someone like, I don't care about safety rules or whatever. People are voting yes, maybe just because they do honestly believe Boeing will fix it and just prove a point. That is the other thing as well. That is the thing. Boeing, your flip side is they could be motivated to say, this is bad PR for us, let's prove them wrong. You never know. You never know. Anyway, let's move on from that. And I'm still stuck on the I'm still stuck on the tweet. There we go. Moving on. There was, you know what? I will sometimes give my own opinion. It is my opinion, but I think most of you will agree with it. This is a leadership we all hope for and now receive from NASA. I honestly do believe that. And I wouldn't just post that for like, oh, Jared, we like Jared. Everything he's been coming across with, ever since the Inspiration 4 mission, I've been impressed with him. Super impressed with him. And I'm hard to impress. I am your standard Yorkshireman. I'm hard to impress. He is super impressive. And I am so happy that the bumpy road becoming NASA administrator ended up with him becoming NASA administrator. I really do honestly mean that. I would not just say that for saying sake. I would not say it for likes or anything like that. I say it because I mean it. So I really am impressed with him. And this was another example of that because I thought he came across perfectly well with this transparency and with the way he said it. It was hard hitting. It was pulling no punches. And that's what we need to do. So that was impressive. I found the way to retweet Jay. There is a statement from Boeing that Jay got from Boeing, which was, Jay gets a lot of statements from companies. He does very good work for us. He's a producer, but he's also a raving journalist where he gets these quotes from companies with faster than I do, which is really impressive. Right, we can go present now, please, Roger, because we've come to the end. That wasn't too terrible. Normally on a Tuesday, I have like 4 days worth of tweets to go through and it takes forever. At least at this point, when we go back to the main views, it's good pointing out that while I've been rambling on about our X feed, it's not just X feed, because remember, we've got a different audience in here for this one. We've got a lot of, people who are not normally going to Starbase Live. We have other feeds on other social medias for people who don't maybe like X.
Yeah, since we know that, as you said, not everyone is on X, we try and spread it out and be where you are, so you can keep up to date with all the latest happenings and all the latest news, be it on whatever's happening with the Wet Dress Rehearsal and the Starliner, or just latest ramblings on the various SpaceX sites, be it what's happening at the Cape, Starbase, on at McGregor. So we try and keep you up, be it on Facebook, Instagram, Threads, Blue Sky, TikTok. We try and be where you are, so you can stay up to date and share all the excitement of this wonderful time we are in spaceflight.
Still no love for the MySpace page.
Unfortunately, MySpace is read-only for the last couple of years, so we couldn't make it happen. I tried.
Well, I live by my MySpace page. going back to GeoCities and email lists. I'm old. I remember AOL Messenger. That was fun. What happened to that? Anyway, moving quickly on. Gage, I've got a question for you, right? Because you've been to them. And Roger as well. Roger and Gage will get this question. How far away can you hear SLS or Starship launches? So let's go for the Starship one. Let's go Gage first. Do we normally have our gang at River? And how loud is it from, and what distance is that?
Oh man. So from River, I believe it's about 3-ish miles away. I can't remember exactly, but it's about 3 miles away from Pad 1 at Starbase. Now Pad 2, the exact mileage may vary. I mean, it's close enough, but it's loud enough where essentially it vibrates the entire ground. Like it's basically witnessing an earthquake. If for those who live on the West Coast, if you've been through an earthquake, it's essentially that, but like not as terrifying. How about that? Versus Artemis 1, when I went to the Cape for Artemis 1, I was significantly further away, so I was where the public goes off of Highway 1 in Titusville. The lighting was incredible. I mean, it was a night launch, but the wind I don't think was in our favor. Even though yes, it has SRBs, it's supposed to be louder, right? But the wind was not in our favor that night. So Starship by far was definitely way louder. But I don't know about. I can't speak for those who have been at the press site. Maybe they have a different opinion on that. But our river site is about 3.5 miles, or no, about 2.5, 3-ish miles away. South Padre is about 5 miles away from the launch pad. But if you want to get closer, our friends over at Rocket Ranch, over at Outpost, the Rocket Ranch Outpost. Oh, and on screen you can see we have the Artemis II closeout crew is arriving at Pad 39B right now on screen. Look at that.
Well done, Gage. Yeah, I was just looking at that little white van. Look at that white van. It's a big van. But look at the scale for context. Van for context. It's van for scale. Because that is a big rocket, as you know by now. But that is the closeout crew arriving. That's another milestone towards the completion of this wet dress rehearsal. Hopefully all goes well. There's Ryan in chat with his silly D-Pod Dolphin username. Where's the van? There it is. A bit of a Jacqueline throwback there from Ryan. For those regular members of people who watch our streams, because they will know what the Blue Origin stream was like, where Ryan got very excited about that booster arriving back at the drone ship called Jacqueline, which is named after Jeff Bezos' mum, would you believe? It's a true story. More thanks, by the way. Dark Silver Space. I'm going to come to you next, Roger, by the way, about the sound, but I want to thank some people before I forget. Dark Silver Space has become a Padram member. Shaba has got his Blame Hydrogen shirts and stickers. They came in. That was from Wet Dress Rehearsal 1, where hydrogen was leaking, and when our store team decided to do a Blame Hydrogen merch range on the back of that. I thought it was hilarious. Everett's become a Capcom member, so you've joined our Discord, as has Seals has become a Capcom member and joined our Discord as well. Remember, it takes about an hour between the integration of your YouTube username and the Discord thing. It's automatic. It's not something I press a button on. It's automatic. But it happens within an hour, I've found. So don't be worried if it's not instantaneous, basically. Benny, we are very lucky we didn't have a Challenger event. Seems like ethics were in play here. I think Starliner is done. Not a terrible comment. Honestly, the single fault tolerant thing got me as well. We knew about the thruster issues during docking, but the single fault tolerant during landing, that was new to me. And that's where I started thinking this was serious. This was seriously bad. If you'd got into a situation where there was a crew on board, Butch and Sonny, for example, and they had a single fault tolerant landing, I'd have been like, "Wow, they dodged a bullet there," because he did land.
Actually, it was 0 fault, not even 1. It was 0.
What?
So even worse. Yeah, it was 0.
Oh my god. Yeah, that's not good. It's all shades of bad. So yeah, that's not good at all. because you normally triple fault tolerant. That's the way it works with spaceflight. You want it's usually 2.5. That's what they call it, but they do triple on purpose to keep within the 2.5. So that's just ridiculous. Oh, Astro 95 Media, which is Nathan. Hello, Nathan. SLS at 39B is 3.4 miles away from KSC press site. Starship Pad 1 is 3.8 miles away from NSF Riverside. Both are amazing. Cheers. Roger brings you back in. By the way, thanks, Nathan. Roger, your experience, because you've been to every Starship launch, if I'm not wrong.
That's correct. Yeah. I guess my best experience is that I went for all of them, but you feel it from the vantage point we have at our river site. For Flight 5, we weren't sure what to expect with the sonic booms. I was leaning against the NSF truck hood. Dan was in the back of it. When those hit, it knocked me into the hood like a body blow. It almost knocked Dan out the back of the truck. So, I mean, from there, it's spectacular. But I want to mention, we've had twice now from Brigham Young University, BYU, we've had researchers that have been out to the launches. They've installed audio equipment on our various sites. So they've done extended research on there. I'm going to post a link in chat here in a sec for that study, but you can go in there and you can see lots of good information on the sound effects and how far it goes around Starbase for the starships.
I forgot about that. They literally had that university installing special sound equipment at our sites, because we do own land in South Texas around Starbase, which is bonkers. It still never makes me think of anything else, but that is crazy. But it's true. And they installed sound equipment there, and they did obviously studies on this. So it was really cool that we got that kind of data at hand as well. Segue completely off that, Kit mentioned that I wore my Blame Hydrogen hoodie at an Asda gas station a few nights ago. I got a few funny looks from other drivers. I'm not surprised. I did notice that people were in chat saying that Asda petrol is cheaper than Tesco petrol. Maybe not up north it isn't. That's weird. Maybe down south it is, but there we go. We've got why are all NASA liquid fuel tanks painted rust orange compared to the white of commercial rockets? Well, the irony there is the external tank for the space shuttle was originally white because they painted the orange TPS foam for two reasons. One, cosmetic, although apparently the shuttle workers at the time said it up close and personally it looked terrible, but on TV it looked quite good. And the second reason was they were concerned about solar radiation whilst out on the pad impacting on the foam. They found the latter was not real or not a major concern, and then they realised they could remove what was about 300 pounds worth of paint and have that as extra capability, payload capability. So that's why after STS-2, the last time they flew with a white external tank, they've gone with this orange tank, and that is followed on with the core stage for SLS. If you think about it, the core stage is like a longer external tank from the space shuttle program. It is TPS foam. It literally is thermal protection system foam, and that is to protect the tank inside there, what would be normally a bare naked tank. It's something where during the space shuttle program there's a concern with the foam falling off. We know we're talking about disasters again, but Columbia, where the bipod ramp of foam the size of a suitcase came off during first stage ascent and punched a hole in the left wing of Columbia. That is not a concern with SLS because it's an inline vehicle. The space shuttle orbiter was on the side of the external tank and in the firing line of the foam liberations from the top of the tank, whereas Orion is at the top of the stack, inline vehicle, and not under any threat of being hit by TPS. So that is a completely, and the heat shield, let's face it, is completely protected anyway during launch. So that is not a concern. Oh, so many questions about things that I don't like talking about, which is Columbia and Challenger. We're there again because of Starliner. More questions coming in. Let's do a status update. I do like to make sure we keep a status update on SLS. We've had no updates since. They are in this hold now, aren't they, Gage?
Yeah, so they are in a T-minus 3 hours and 30-minute hold that it will approximately last for about 1 hour and 15 minutes. I can't do math in my head how long we're in that hold right now. And since then, the Closeout crew, which is the crew that'll be taking care of the Orion capsule and taking care of the astronauts as they get ready for flight, they have since arrived at the pad and as we speak are making their way up to the White Room, which is at the top of the rocket there on the crew access arm. And basically what they're going to do is they're going to basically button up Orion, get it ready for flight. They're going to, except the only difference is they will not have the astronauts on board. So they're basically going to close the Orion hatch. They're going to do their leak checks. They're going to close the launch abort system hatch, do all their checks there, and then they will depart the pad, and essentially the countdown will continue at L-4 hours. So in about 30 minutes from now is when the T clock is going to resume, because they're in this extended planned hold, by the way, because this is a wet dress rehearsal. So the closeout crew is at the pad now. They're going to get Orion ready for flight, essentially. They're not going anywhere today, but essentially what they would do on launch day. And that is where we are right now, the last update that we have received.
Super, thank you, Gage. A question I could answer straight away, but I'd like to give it to other people as well. Jake, it's a question for you. I know you know the answer as well. Benny wants to know, and thank you for your support, by the way, Benny. When do you think the first Starship ship will be built in Florida? Like stacked and flown, because the caveat is the first Starships will not come from Florida, will they?
Yeah, so as something we mentioned before, the initial vehicles for the launch site over in Florida will come from Starbase via the barge named You'll Thank Me Later. As for when the first ship will be actually produced over at Roberts Road, we're probably looking at sometime early next year. There's you got the rest of the framework of the build of the Gigabay to actually be finished first, and then you've got all the outfitting, even just getting a few work cells set up inside a Gigabay. That's still going to take some time, so I'd look at early next year at the absolute earliest.
Not to mention, they need to build a Star Factory there as well.
Yeah. Yeah, because that's a good point, Aaron. We've got the views of Roberts Road where you see the Gigabay rising. You've got the other facilities there already, and you've got the work site where they build things like towers and sections like that. But there's also an area they're going to have to build a Star Factory that we've not yet even seen the start of, compared to the one at Starbase. So you've seen how big Star Factory is at Starbase. It's huge. It's a massive, long building. They've not started that yet in Florida. So that's where Starbase is way ahead of the game on the ship side of things. Gigabay will be about... Remind me, Aaron, the Gigabay factory can it actually stack a full Starship, or is it just basically boosters and ships that will be in there and they'll stack them outside?
Can you repeat the question?
Yeah. Gigabay, it's not tall enough for a full stack Starship, is it? It's tall enough for the boosters and ships to be processed in, but they can't stack a vehicle inside the Gigabay.
Ah, yeah, okay. Yeah, so the Gigabay is not 130 meters tall, so they cannot stack a full stack. They have to stack the boosters and ships separately before they roll them out to the pads and then stack up the tower.
Because I've seen many a Grok video and Grok image where they have hundreds of full stack Starships inside, and I was like, hang on a minute, that doesn't seem right. But it is something. It's a sign where they've got so many bays.
Look, you can see the white crew, the white room crew there on that big box there. Carson, if we can full screen that. This is that closeout crew that we were mentioning earlier. You can see the Orion hatch there on the left-hand side. This is the first time that we are seeing this. Thank you, NASA, for providing this to us. We did not get this for the first wet dress rehearsal, but now we get to watch the Orion closeout crew perform their work during the wet dress rehearsal. This is so cool.
That was a deserved Alex ooh ooh ooh, because I did spot it as you did the ooh ooh ooh, but I didn't spot it before then. But that is a new camera view. Again, something we didn't get on the wet dress rehearsal one. We had one NASA camera for that. The rest were our cameras. Obviously, we were still fine. But these are the views that we were hoping we'd get. And this is a big milestone because anybody who watched the wet dress rehearsal one will know they had issues with this hatch during that attempt. So this time round, we're hoping we won't have issues, but we'll get to watch anyway. We'll get to see it. So this is going to be really fascinating to see.
Yeah, look at that. So that green-looking hatch there on the very left-hand side, that is the Orion itself hatch, and then the large one on the right there is the launch abort system hatch. So there's two hatches that they have to perform leak checks and close out ahead of their preparations.
Very good. I'll tell you what, I'd like to take more questions, but I'm going to watch this for a little bit because this is great views of not just the closeout crew inside the crew access arm on 39B, but you can see the inside of the hatch here.
Yeah, and I believe, I mean, correct me if I'm wrong, this is like the first time that we've seen inside the White Room, right? I mean, I don't remember if there was like pictures and whatnot, but this is like the first time that we're getting a live feed inside the White Room on Mobile Launcher 1, I believe.
I think so. Also, a big shout out to the closeout crew clothing, as I am used to the White Room clothing of the shuttle era. It was like this, but this seems a lot more funked up. This looks a lot more funky compared to what they used to wear. The iconic white suits are not new, but the design of them looks like they've been refreshed for the new Artemis era. And I say I would not mind this in our store. We couldn't do it because it'd be copyrighted. I'm sure it'd be just copying. But that is something I'd quite happily wear. To be honest, I don't know if it's just me.
And this is crazy because, like, not to mention, these guys are next to a fully fueled SLS rocket. Like, that is also another thing that's crazy to watch this here.
There's an even crazier job where, talking about a fueled vehicle, during the shuttle program, there was the Red Team Ice Team, which went out to the pad when the vehicle was fully fueled, literally fully fueled, and they would have binoculars and look up over the external tank looking for ice buildup, because big ice buildup on the external tank was a debris risk. Because if that ice fell off during ascent, then that's going to hit the orbiter probably. So they would go up to the pad when it was fully fueled, and there's videos and GIFs out there, if you search for them, where they are literally just covered in what looks like smoke, but it's not smoke, it's obviously the venting. But they are literally just getting absolutely wafted all over the place by this stuff, because they had to do it. They had to get close-up binoculars to look out for ice buildup on the external tank. That's the job that I would have wanted to do. That was incredible. It would be nice and cool though, in the Florida sunshine, get covered in this very cold venti vehicle, I must admit. Also, a little shuttle story for you. The astronauts I spoke to from the shuttle era would always say that it was surreal going out to the pad with a fully loaded vehicle, because the shuttle sounded like it was, and I quote, groaning, moaning, and farting. I've got it on a quote somewhere in an article. Literally, one of the shuttle astronauts told me that. Groaning, what was it? Moaning, groaning, and farting. That's what the shuttle was doing when they arrived at the pad. True story. They said that's when they knew the vehicle was alive. Crazy. This is quoted, that's not me talking, that's quoting an astronaut, by the way. Back to still Florida, but Starship. Why was the tower section rolled in Florida? So we're talking about that section of 37B. Oh, it's just 37 now, isn't it, Jake? It seemed too soon. Why did they roll a section of 37's tower this early? Any ideas?
Yeah, I think it's a pretty simple thing, really. I think SpaceX is just trying to clear out some of the tower assembly section spots at Roberts Road to be able to start assembling sections of the second Slick 37 tower. They're nowhere near ready to be able to actually start stacking the first tower yet. I believe they haven't finished the foundation yet. All the sections for the tower base are on site there now, but yeah, it's going to be a little while before they can actually start stacking that first tower. And then for anyone wondering which tower section actually rolled to 37 the other day, that was, I believe, module 6, which would be just above the QD arm.
Very good. C.H.E. Jones. I love it when he comes out of his cave to bless us with shuttle facts. Give me a chance and I could talk forever about shuttle facts. I have many a shuttle story. As you can imagine, I was covering it. I'll tell you a story within a story. When I started NSF, I would get home from work and I'd write a story a night. The amount of access I got, and we got, I should say, because there's people like Bill Harwood's been doing this from the early days. The amount of access you'd get from the shuttle program was crazy. You'd get nothing close to that these days. Even with the new transparency under Jared, nothing close to what you got. I'll give you one example. There was an issue with the intertank on external tank. I can't remember which mission. I think SS-127. I think it was that. I sent an email off to NASA Communications asking them for any details they could give us on this issue, because we saw people on the live cameras, which were 24/7, at the pad, showing them accessing the intertank at the pad. I got a reply back with PDFs of the area with like schematics, with the quotes I could use, and an option to interview one of the workers once he'd finished his shift. That was the kind of access we used to get. It was crazy. And you get, daily processing reports, everything like that from the OPFs. You could easily write several articles if you had time, but I wrote one a day on the space shuttle program. And I was spoilt by that. So when if you ever hear me moaning about lack of access or whatever, which I don't try and do, but I might sometimes come across that way, it's because we were spoilt rotten during the space shuttle program. The amount of access you would get was crazy. It's a different era now because, especially with the commercial providers, they are not going to be the same as NASA with the access, because we're talking proprietary, we're talking ITAR, we're talking things like that, and that's completely understandable. So, but for NASA, I was hoping Artemis would be more open than it was, but hopefully with Jared in charge now, we're going to start seeing that more. And today is a good example. We obviously had Wet Dress Rehearsal 1, and not just us, but a few people were saying it's a shame we don't have the external cameras like we used to do. And lo and behold, on Wet Dress Rehearsal 2, we've now got these internal cameras. So maybe we're seeing signs of things returning from the access and transparency side of things, which I hope will be true. Cool. I did see Baki saying that on the Starliner thing that we're hoping for a 4-hour flame trench with a full review from EJ on this one. Yes, I'm sure EJ will have a lot to say about this Starliner situation. I have a feeling he's on the stream, actually, on the Wet Dress Rehearsal stream later after me. So he might get some pre-flame trench chat about the Starliner situation. I do believe he's on from 5 p.m. Eastern, so maybe you'll get to hear some of the pre-flame trench talk from EJ on the Starliner situation. I'm sure he's got a lot to say on it, but that's kind of funny. That caught my eye, that comment. I do have a crossover question here. Here we go. Kit asks, this is a crossover question. There we go. Regarding HLS Starship prior to Artemis II, how many Starship landing attempts do you expect before the first successful landing stays upright? So that really is that's more about Starship. And the thing with Ship is, it's not about landing and what have you. Let me see if I've heard that question right, because they're going to be catching the ships on the chopsticks. Maybe uncrewed lunar landings, maybe, because that's going to be something that's planned. Yeah, the test landing on the moon. Thank you, Roger. Roger, I'm going to give you the question. What do you think, Roger? What do you think is the point at which Starship has passed its test before they start looking at the crewed missions for landing on the moon in Starship with the HLS?
I think fairly early on. I think it's one of these things that they will go for. But one thing I'm wondering, and it'll be interesting to see if SpaceX does this, is try to land them here on Earth. I know you got the aerodynamics coming in for just a ship, but the gravity is more, obviously on Earth. So if the landing system can withstand a landing here on Earth, like a Starbase or somebody, then it'll be good to go for the moon. So definitely looking forward to any signs of the lunar vehicle legs. We've already seen refueling ports going on the ship, so it's going to be exciting this year to see how they progress towards the lunar vehicle.
Indeed, yeah. I have a question that I would like to answer. That's from Max, who asked, do you think we'll ever see any more large-scale space planes similar to the shuttle? And if so, do you think they could ever get near to the flight plan rate cadence of Falcon 9? Right. I was a big fan of the X-33 Venture Star. Join in if you remember that. The X-33 Venture Star. That was pretty much a flying fuel tank, to be fair, rather than a space plane. But it was meant to be a successor, or at least a complement to the space shuttle. It was an SSTO. There you go, Josh, which was single stage to orbit. That's what it means. The X-33, which was the demonstrator, the small-scale demonstrator to the Venture Star, that was a larger vehicle, same vehicle, was built by Lockheed Martin Skunk Works. And I would get back from university on an evening and go to my local internet cafe. Yes, that's right, boys and girls. Before the days of internet at your home, we used to go to an internet cafe to go on Netscape Navigator to download on dial-up their one-a-day webcam image of the Skunk Works factory floor showing the X-33 being developed and built. And I used to look forward to that. I thought that was going to be a great vehicle. And it had a lot of promise. It was fully reusable spaceplane. And it unfortunately was ahead of its time. Tory Bruno former ULA, now Blue Origin, Tori Bruno worked on the X-33, and he said in a reply to one of my articles looking back on Adventure Star, saying, if that had been today, we would have been able to build it. The technology was just ahead of its day. The old flight, the way they designed the hydrogen tank, for example, it just didn't pass the stress testing when they were developing it and got cancelled as a result. But today it could have been built. And the question is, would it be needed today? You know, let's ask around. Aaron, I might be unfairly asking this question. Do you remember the Venture Star?
No, I do not. I think I might be a bit young for that.
Oh, that makes me feel old, but then again, I'm old, so that's fair enough. Elisa, do you remember the Venture Star?
Might not be as young as Aaron, but I also have to say I don't remember it. But any space plane is a cool plane.
This is where I need to do another article. I need to do another review article. When we get to some kind of like anniversary of it, I'm going to do another one. Gage, do you remember the Venture Star?
Oh, no. I'm too young too.
This is making me feel very aged. Jake, I don't think we've got much help with Jake either. Jake, do you remember the Venture Star?
I know of the Venture Star. And then
that'll do.
But that's about as far as it goes with me. Yeah, my knowledge on the Venture Star isn't the best.
Roger, save me. Do you remember the Venture Star?
Oh, of course. Carbon fiber tanks. Well, nothing can go ever wrong with carbon fiber, so you're set there. You got aerospike engines, which are the wave of the past. So yeah, it was a really cool looking vehicle, though. Too bad it didn't fly. I don't think they even had it on For All Mankind, but that would have been a cool render.
That's true, yeah. In fact, that could have. The thing with For All Mankind is they went the other route where they went to Sea Dragon, which was a vehicle that would have been amazing. The Sea Launch Sea Dragon. They invoked that as the pretend future. Ronald D. Moore, amazing writer, did an amazing work with the reimagined Battlestar Galactica and has done many other shows since, but he's also did For All of Mankind. He was great because he took the space program as he wanted it to be without the delays and without the changes. And he had Sea Dragon in that plan of getting to the moon and things like that with the big payloads. And of course he had Shuttle going to the moon, which was obviously not something I was going to reveal, but that was probably why Venture Star never came in, because Venture Star was basically a payload deployer on low Earth orbit, but at a much cheaper rate compared to Space Shuttle. That was about bringing the pound to orbit mass cost down. That's basically what Venture Star was about, rather than anything elaborate like going to the moon or Mars. But to answer the question, no, I'm not too sure there's a viability for it now. I think we've seen the sweet spot on the cost of getting your payload to space is all about the likes of Falcon 9 and Starship with the reusability and with the amount of mass to orbit you can achieve with that. So I think the market isn't there for it. The other market is micro launches, but we've seen how that doesn't necessarily equate to guaranteed money for development. Look at Orbex. So space planes, I'd love it, but I don't think it's just all that viable now. I think Falcon 9, for example, is where the route is. Its rockets are rapidly reusable, and that's what Starship's going to be. There we go. I'm getting pictures in my corner of my eye of Venture Star, and I'm going, oh, my beloved Venture Star. I do miss it, but it was a great vehicle to follow during development, at the very least. But that is going back many a year now. That's the 80s, isn't it? It's the 90s. So yeah. As far as SLS goes, we are getting to the end of this Raptorside stroke Cape side. So I'm making sure that we don't ignore SLS before we go back into our SLS proper coverage. I am watching the Closeout crew while talking, which is distracting. And I am very fascinated by Orion's hatch here, because this is very much something they had an issue with during Wet Dress Rehearsal 1. It's going to be fascinating to see how they close it on this one, because closing it was part of the problem on the first Wet Dress Rehearsal. So I don't know how far away we are from seeing hatch closure. Gage, do we have an indication on a timeline of when we expect the hatch to be closed?
Well, see, they are definitely all over the place when it comes to the timeline. NASA has posted a approximate timeline in the Wet Dress Rehearsal, but they have been all over the place. So, not really sure, but we're kind of watching here. But yeah, for those who are just tuning in, on the right hand side, this is our first ever live views from the White Room off of Mobile Launcher 1 that is attached to Orion at the top of the SLS rocket. On the left-hand side there, that is the wide view of the rocket, and then on the right is the inside of the arm. And on the, as you can see on the right box there, to the very left-hand side, just over that gentleman's shoulder there, the green-looking hatch, that is Orion's hatch itself. And then the bigger hatch on the right-hand side, that is the launch abort system hatch. So essentially, they're going to configure Orion for flight. They're going to close each hatch. They're going to perform leak checks. You know, for those who watch Crew Dragon flights, right? You know how the SpaceX ninjas, they hook up their iPads and their devices, and they kind of perform leak checks and whatnot. Kind of similar here, except this is Orion, and probably much more, well, I guess I shouldn't say Dragon isn't complex, but this seems like a lot more of a complex operation because this is going to the moon. Like, this isn't just going to the space station, right? This is going to the moon, which is such an exciting thing to see. And, you know, essentially, at least in my opinion, this test has gone quite well compared to the last attempts, right? Because, I mean, the only really issue we had today was a comms issue between the launch team and the vehicle. But other than that, they got fully tanked without issue, it appears. And now the next test is, this was the other, you know, Chris, you were mentioning this earlier, where the last issue they also had during the last wet dress was with that Orion hatch. So it'll be interesting to see how that goes this time around, and see how long they stay on the timeline here.
Very good, yeah. I don't know if we've seen the camera view lately, but I'm assuming this camera view showed it. November wants to know, what are those trash bags looking things at the bottom of the SRBs? Just from not seeing that view, but I'm sure the view may have been shown during the chill down on the RS-25s. During the shuttle program, they're called the baggies, the water baggies. They are literally big, massive red or orangey red, I should say, bags full of water, plastic bags full of water. They line the trench part on the mobile launcher for the SRB nozzles, and they are basically destroyed on the RS-25s, and they're destroyed at launch. And they literally are something that they pick up after launch in threads of like plastic afterwards. They're just there basically to protect the bottom end when they're doing work on the pad or what have you. And also they do actually provide a little bit of solar suppression if you think about it at the same time. But they were called the water baggies during the shuttle program, and I assume that's what you're referencing there. I am immediately, my mind is immediately brought back to, sorry, Roger's going, bags of mostly water. Thank you for the Star Trek reference, Roger.
Oh, you're welcome. Had to.
Yeah, you had to. Bags of mostly water. Ugly bags of mostly water, wasn't it? That's right, yeah. The Star Trek reference. People are probably going, what the heck's Chris talking about? It was a Star Trek episode where they found a life form that didn't like the look of these humans. Anyway, my mind was brought back to, I think it was STS-122. The flame trench on 39A, in fact, was still using the refractory bricks from the Apollo program. They'd been working pretty much fine during launches, but this one launch sent bricks flying, and it destroyed the side of the flame trench wall. And that's when they replaced the bricks in the side of the flame trench for both 39A and 39B. So that was something where it was a lesson learned. The water baggies did not really help at all there. Neither did the sound suppression. But that was just because they basically, the program had probably left it a little bit too long to revamp the flame trench. But it was refractory bricks from the Apollo program that were sent flying from all different directions during that launch. Thankfully, none of the bricks hit the orbiter, or they'd been quite a bad day. There we go. Right. So we have got through most of this little crossover episode, going from our Raptor side on Starbase Live through to this Cape side on our SLS Wet Dress Rehearsal stream. I do think that we are going to get to the point where we're handing over back to our SLS team, but I want to give some thanks to who's joined us on this Raptor side, or Cape side as we're calling it, this time round. Aaron, thank you very much for joining us, Aaron.
It's been a pleasure, Chris. It's been an interesting crossover.
It has, yes. And we'll do an update before we cross over, but I'm just going to thank people who have been on this before we do that. Also, thank you to Elisar. Thank you, Elisar.
It's been a pleasure as always. It was an interesting change from the regular Raptor size schedule, but fun to talk space with you all.
Very good. Thank you, Gage, as well.
Yeah, of course. You know, this has been fun to sit here and watch this test with all of you guys and the excitement with this mission. I mean, you know, I know, Chris, we're getting ready to hand over here in just a little bit. But before we go, I do want to ask you, Chris, what is the mission that you are most excited for in 2026? Like, is there that one mission that you are looking forward to? And I think I know the answer to this one, but I want to know what you think, Chris.
If I could think, I'd probably able to answer that one. Honestly, I'm looking forward to the first double catch, where we get a catch of the booster and also a catch of the ship. Now, I'm assuming, and I bring Jake in on this one, Jake, I'm assuming they will catch one vehicle on one pad and the other vehicle on the other, or will they try and catch the booster, lower it, get it out of the way, raise the chopsticks again and catch the ship with the same tower? Because obviously with a ship catch, it won't be minutes later, it'll be hours later, won't it?
Yeah, this is pad 2 we're talking about now, yeah? Or just as a whole?
Any pad.
I think initially they'll go with catching the booster first, then getting that out of the way, and then catching the ship. Eventually, I know some people are going to be quite dubious about whether SpaceX can achieve it or not, but I think eventually they will try and actually keep the booster on the pad whilst catching the ship at the same time. I mean, we've seen the plans that SpaceX has for the future, where they want to be launching, like, I don't know if they'll ever reach this point, but they want to be launching every hour. And to be able to do that kind of thing, you need to be like being able to catch the ships whilst the booster's still on the pad to be able to achieve that super rapid turnaround. It'll be interesting to see how it goes. I'm not sure if SpaceX will ever reach that point, but yeah, it'll be interesting nonetheless.
Indeed. Thanks for being on this one as well, Jake, as well. This longer, elaborate Cape Side chat, which was Normal Rapside. But Normal Rapside will return on Tuesday. I do believe I have an important meeting, Roger, on Tuesday. So Tuesday's Raptor side, maybe a Roger side, while I try and enjoy myself in Scunthorpe. Thank you, Roger.
Big shoes to fill, but we'll get through it.
Big shoes to fill.
Well, yeah. We'll take it. We'll see what happens on Tuesday. So please join us for the excitement, and we'll do a big reveal about who's hosting.
Yeah, I don't know about big shoes though. Otherwise, also Gage, thank you for being on this, and maybe we could do the opportunity now because we've still got 3 or 4 minutes before we hand over. Let's just talk about and get people back into the focus of SLS during this Artemis II Wet Dress Rehearsal 2 test. That's a mouthful, but it's true. Artemis II, Wet Dress Rehearsal 2. The milestones that we've achieved so far and what's to come.
Yeah, of course. And as we get ready to hand over to our dedicated team, just a quick update for those who have just tuned in to our Artemis II live coverage of the Wet Dress Rehearsal. Teams got on station about 2 days ago on Tuesday, February 17th, around 6:30 p.m. At night. And for those who watched our Space Coast live coverage, we watched the countdown clock the very minute that it started, and I believe it's about a 45-hour countdown. So it's a long countdown, and some have asked, like, why is the countdown so incredibly long compared to, like, Falcon 9 and stuff? Well, SLS has a lot more parts that they have to turn on. They have to there's a lot of things they have to verify before they can just, like, turn it on and load it with propellant, right? Teams powered up the core stage, they powered up the Orion spacecraft, the ICPF, the interim cryogenic propulsion stage. That's a long word for the second stage there. They spend multiple hours making sure everything's looking good, the communications are correct, well ahead of before they start loading fuel. So they did all of that Tuesday night and all throughout the day on Wednesday. And then it arrived to today, where the tanking portion of the test, the Charlie Blackwell Thompson, the launch director, has given the go for tanking, and she did that right on cue. In fact, actually, I think earlier than the timeline that that NASA gave us. And so teams got right on it. They started loading liquid hydrogen and liquid oxygen in the core stage. And the only issue that we have seen today is teams had a comms issue between the launch control and the vehicle. Luckily, they had a backup so that they don't lose all communications, right? Because that wouldn't be great. But within about an hour of the timeline, they got everything back up. So they're back onto the main communication system, and they were able to resume the fast fill of the liquid hydrogen, and they got the core stage fully tanked. They had presumably no issue getting the ICPS all fueled up, and now here we are at L minus 4 hours, where I believe the T clock is about to resume shortly. They're in a planned 1 hour and 10-minute hold. The white room, the white crew, as you can see on the right-hand side, have arrived at the white room, and they're performing the closeout procedures for the Orion spacecraft like they would do on launch day. And this is our first time that we are seeing this, thanks to NASA for providing this coverage for us, because unlike the last wet dress rehearsal attempt, we didn't have this. So thank you very much for sharing this with us. The white crew there is going to perform as they would do on launch day, except the only difference is there's no astronauts on board today because the vehicle is not launching. I know I've been watching chat. I see a bunch of people going, when's it going to launch? It's not going to launch today. Let me be clear. SLS is not going anywhere today. This is just a wet dress rehearsal with teams familiarizing themselves with fueling the rocket, getting Orion buttoned up and ready to go, and teams will hopefully, the plan is they're going to get into terminal count. They're going to count down to about around the T-minus 33-second mark, and then I think they're going to stop, and then they're going to recycle the countdown. They're going to do a whole bunch of tests today. The test window opens at about L-minus 3 hours and 59 minutes and is expected to go just past midnight Eastern time. So team's got a lot to do ahead of wet dress today, but that is where we are right now, Chris.
Yeah, it's actually quite interesting. Now, we've not lost any viewers. We've still got thousands of people who have managed to listen to us do this little sideways track from a Raptor side and a Cape side during the SLS stream before we go back into the business stream of business end even of the streaming of this wet dress rehearsal, the business end of the countdown for what is hopefully going to be a successful test that will allow NASA to at least proceed into the data check that will then result in a flight readiness review for a launch date setting for 4 people, 4 humans, to fly around the moon, one of the biggest missions for NASA for decades, which may be just next month. That is bonkers when you think about it, it really is. But that's enough of me rambling. Let's go back to the main commentary stream. I wonder, because I see his name, is Mr. Famous Ryan Caton in chat?
Hello, everybody. I am back. We had a very, interesting press conference there, and a very interesting Cape side, Raptor side special chat to follow. But thank you, Chris. Thank you, team. We are going back into our full-on coverage of the Artemis II wet dress rehearsal. Now, a little bit of housekeeping very quickly, because as you may know from the previous Artemis wet dress rehearsal live stream we had to do, unfortunately, YouTube has this annoying feature where we can only do a live stream which is 12 hours long. Now, you might notice we're nowhere near 12 hours yet, but because of the length of this test, it's going to be over 12 hours long. Therefore, we're going to have to split the stream up into 2. So, bear with us. You will be automatically redirected to part 2 of Wet Dress Rehearsal 2 for Artemis 2, if that makes sense. So stand by. We'll be right back, and we will be with part 2, so we can continue live streaming well beyond that annoying 12-hour threshold that YouTube has. So we'll be right back. Stay tuned. You should be automatically redirected. See you in a minute.
And here we go.
There's the W. Here's ignition.
Doubling up.
Did it just do a Kerbal? Back to the moon and beyond.
Put that in the big bag, you know.
Back at home, we all have a lot of work to do, but from here, that sure looks like a perfect flow.
Propulsion continues to be normal.
We did have an observation.
Equalize.
343 unfolds to go.